Are you someone aiming to work for top companies or improve your data structures and algorithm skills? Then watch this video to learn more about data structures and algorithms. We will cover how to implement key data structures like arrays, linked lists, and trees and solve common algorithm problems. We will also explore sorting, searching, and other important algorithms so you will know not just how they work but also why they work. Plus, we will explore how Python is used in generative AI, including chatbots and art generators. And here's the best part. We will also prepare you for job interviews with practical coding challenges and tips. So, say goodbye to feeling unprepared. Let's get started.
The first thing that you really have to think about whenever the term data structure comes into your head is what is a data structure, because it is a term that gets thrown around the entire world of programming. And if you're a non-technical person who has ever gone for a technical interview, either for a programming job or something along the lines of that, data structures are extremely important for interviews. And why is that, right? Let's answer these questions. First of all, what is a data structure? A data structure is basically a way of how we can store data in a structured manner. In fact, the answer lies in the name itself, right? So data structures not only provide a very good and an efficient way to actually store your data, but also whenever it is required, right, that is when it shows its power. That is when it brings out all the efficiency that I just spoke about now. And then when you think about it, having a structured way of approaching things not only in the world of programming, but works everywhere, right? Think about organizing your books in a bookshelf or maybe your kitchen cabinet, right? But then when you again think about data structures as a whole, when you come to programming languages, there's varieties of data structures, right? In your book rack, you'll only have books. There's a good chance. In your kitchen cabinet, you might have only stuff that's required for your kitchen, right? But in a data structure, when you're thinking about a programming language, here things will slightly change, and there is a good chance that there can be a lot more things at play, right? Think about not only how to store data, but how to organize them, how to access them, and how efficient is this entire process of storing, organizing, and accessing going to be. Right? This is what makes up a data structure. To give you an example, just like the book example that I just told you about, think about organizing fruits in a basket, right? Because this is exactly what happens in our case as well, right? Look at your screen right now. You'll see a couple of bananas, apples, watermelons, and mangoes that are arranged in their own baskets, right? Now, if everything was jumbled and if I asked you to put it back like that, you can do it, right? Exactly. Now, in the case of a data structure in Python, what happens is the data that it sees is usually numbers or character data, right? Now, if it's an integer, it can be 1, 2, 3, 4, 5. If it's a floating point number, it can be 3.14, 4.9, 6.9, 5.8, anything like that, right? And then, of course, if you have any sort of string data, for example, hi, my name is Anirudh Rao, right? So just similar to organizing these, there also we each have baskets where if Python sees a data which happens to be either integer, floating, or anything like that, it will automatically try to put it in these baskets that we have. Now, to dive right into the details of it, to understand what exactly is it that we're doing with respect to the data structures that are present in Python and many other programming languages, ladies and gentlemen, you have to think about two ways of how data structures are meant to be used, and of course, the purpose of it. First of all, you have built-in data structures and user-defined data structures. See, now built-in data structures, as the name itself suggests, right, it comes built in with the programming languages. It talks about something fundamental, it talks about a scaffolding structure, or it talks about an already ready syntax that you guys have to use to just ensure that your storage options are being met. And of course, whatever it is that you want to use the storage for, you have time to concentrate on those applications rather than breaking your head on how to store the data, right? So that's built-in data structures. User-defined data structures are some of these data structures which we require in a case where we have not just a lot of data, but sometimes you have a solution which will require you to take a non-linear approach of how you should not only store data, but process them and derive insights out of them. In those cases, right, user-defined data structures are very much useful. Now, if you take a look at all the built-in data structures and the user-defined data structures, especially we have in Python, you'll see that the built-in data structures, of course, apart from the int, float, string, and all those, you'll see list, dictionary, tuple, and set. And then take a look at user-defined data structures. User-defined data structures, I've given you 4 on the screen right now, but you can have any number of user-defined data structures for that programming language, right? For example, Python itself has a lot more than 4, but these 4 happen to be so popular that you guys have to know about them. So all right, guys, now we will take a look at all the built-in data structures that we just discussed, right? Now, whenever the talk is about built-in data structures, the first question you really must ask yourself is, what is a built-in data structure, or why is it even called a built-in data structure, right? Now, a built-in data structure basically is present natively in the Python library as well, right? So when you take a look at all these various built-in structures that we're discussing, be it lists, be it tuple, set, dictionary, whatever it is, all of these are present directly for usage, right? You really do not have to install anything on top of Python or work with any sort of dependencies to work with these as well, right? Fantastic. Now, the first data structure that you see on your screen is lists. So what are lists? List, as the name itself suggests, whenever you're trying to make a list of things, what are you trying to do? You are sequentially trying to organize something in an orderly fashion, or you're trying to arrange something in a fashion where the next time you take a look at the list, you understand what's going on. Similarly, right, it's not the exact analogy, but similarly here as well, with respect to list, we have a storage in the form of an array-like structure, right? With respect to list in Python, the advantage here is that every single element in the list, right, all of these positions are indexed. So if I wanted the first element, the second element, the last element, or any element that is present in an entire list, I can actually use its index position, its addressing, and eventually start picking that up, right? In fact, there's an example on your screen right now. We have a sample list here, which contains of, all the types of data that we can have, right? We can have integers, we can have floating point numbers, and look at this, ladies and gentlemen, we can also have a string data type, right? And of course, all of these are completely valid, and all of these are output as an actual list as well. So this is something you really have to know in terms of lists. The next thing that we're going to take a look at and discuss is dictionaries. Now think about a dictionary at your home, right? Before even understanding what's present on the screen. If you take a look at a dictionary, if I have to search for a word in that dictionary, how do I go about moving around the dictionary, right? If my word usually starts from S, I go to that index position, I open all the pages that start from S, and then I alphabetically start looking for the word, right? The working of dictionary in Python is also similar, where we take the concept from the actual example that I just told you, right? So we have something called as key items, and we have something called as the values that correspond to these key items, right? Think about structured data, right? Maybe your name, your phone number, and your email address, and your Aadhaar card number, let's just say. Now, if you have to list all of these for your entire family members, you will have it in an order, or even if it's unordered, you will have it. Let's just say there are 4 people there, right? So you can pick up each one of the 4 as and when you require, right? Similarly, here in dictionaries, we have something called as a key, and a key is basically associated with a value. So if you have to access the value, you can just look for the key, and eventually the key is hooked up to the value, where you can find out the data that is stored in the place that's mapped for that key, right? So if you're wondering about these pairings, how many pairings can we have, or can they be accessed, or can they be added as and when required? Of course, with respect to dictionaries, all these key value pairs can be added, accessed, modified, and removed as and when you choose. That's a huge advantage here, right? Now take a look at the example on your screen. In fact, here we have a dictionary which contains of 2 items. When I say 2 items, I'm meaning 2 key value pairs. The first item that we're talking about is basically an apple, but the key associated with respect to apple is first. The second item that we're talking about is ball, but the key associated with ball is in second, right? That's the output that you can see. So I hope we are clear with dictionaries. The next interesting data structure that we're going to take a look at in Python has to be tuple. Now, ladies and gentlemen, tuple is literally the most used data structure we have in Python. Now that we just took a look at list, one thing you really have to understand about tuple is that the working is very similar to what the lists provide us. But then, ladies and gentlemen, there's a very important point. But here in terms of a tuple, you really cannot change the value of that particular tuple when it is in execution or when it is underway. So if I have a tuple called as sample tuple 1, 2, 3, and then if I want to change it while it's executing, or if I want to change it and just add in more details or remove elements as such, that is not possible. Why? Because tuple is an immutable data type. When I say immutable, basically it means that you cannot add any more data into that particular tuple. So if I have to create a tuple called 1, 2, 3, 4, instead of adding it to the sample tuple here, I'll create another tuple and add that particular value and discard the one that I have at hand, right? So the working is very similar to that of lists. And again, lists use square brackets for all the people who want a shortcut to remember lists, sets, and dictionaries, right? When you guys are beginning, a list uses a square bracket, a dictionary uses a flower bracket, and a tuple uses a round bracket, right? So I hope we're clear with these three data structures. Now, let's take a look at the fourth one, which again uses flower brackets, and this one is called as a set. Set, the name itself should definitely take you back to your school days, where you might have learned about these concepts of sets and how you should have an ordered collection of unique elements present, right? So if I have a set, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, the entire output of it will actually be 1, 2, 3, 4, 5, 6, right? That's how a set works. In a set, you cannot have repeated elements. Every single element that is present in a set should be 100% unique to each other, right? In fact, look at the example on your screen right now. First set is the name of our set, of course. And again, similar to dictionaries, here we use flower braces as well. But the difference here is that we do not have key value pairs. If you had the same flower bracket structure where you had a key value pair, immediately that would become a dictionary. But since we don't have that and we have individual elements, you can take a look at it and you can think of it as a set, right? In fact, the example that I just spoke to you about is on the screen. 1, 2, 3, 4, 4, and 5. So 4 is repeated, right? But in the output, you can see that 4 is present only once. So no matter how many repeated elements you have in your set, once you try to perform operations on it, or once you try to actually store it in the form of a set and try to access the output of it, you will only have access to the unique elements that are present in that particular set. Right? Fantastic. Now, this was about the built-in data structures. We checked out list, we checked out dictionaries, we checked out tuples, and we also checked out sets, right? Remember the brackets, remember what's immutable, and understand that for all of these data types, you do not have to install any sort of dependency to work with, right? Now, let's take a look at user-defined data structures. When the name itself suggests user-defined data structures, what are we trying to do here, right? For example, let's talk about the data structure that you see on your screen right now. Stack, right? Think about a stack of books. Again, a stack of books is shown on your screen right there. How would you arrange a couple of books? Let's just say you have 10 books. How would you arrange it in the form of a stack if you just had to put it on one top of the other? Right? I'll repeat that. So how would you arrange books in a stack, right? You would obviously take it and put it one on top of the other. Now, this actually has a principle of approach and how you are actually accessing and removing elements, or in this case, books, right? If you've kept all those books on the ground, or maybe on your bed, or maybe on your table, there's only one way that you can have complete access to the book. That is the top book, right? You have 1, 2 books and you can access the top one and you can start picking up the book from the top to the bottom, right? This concept is called as last in, first out, or in short, you might have already heard about it. It's called as LIFO, right? So if I have a stack of books, or if I have a stack of elements in Python, what can I do with it? Well, you can actually add any sort of data you require to the stack, remove any sort of data, you can access it, change it, modify it, work with. When you're adding an element into a stack, the operation is called as pushing, and when you're removing a data element from a stack, or in fact even a queue as well, it's called as popping, the operation that goes into it, right? But one thing, ladies and gentlemen, you have to think about a stack is that once you've stacked it on the ground, on your bed, be it on the table or wherever it is, you cannot start pulling out books from the last, right? You have to hold everything else and manually yank it out forcefully. So this concept does not apply here in Python. So the data access, if you want to remove the third book on your screen, if you have to remove this book on your screen, you basically have to remove the first one, remove the second one, remove the third book, and then put these back into its place, right? So it's not like you'll just divide it into two things, pull that book out and put it back again, like how you would probably see in a cartoon or so. That's not how it works. If you want a concept that works in that way, the next user-defined data structure will be pleasing to you guys, because this is a queue. A queue data structure is something that literally every one of you guys watching this particular video, in fact all of us, when I say including me, have seen and either been a part of a queue, or of course we know how it works, right? So queues are again used in real life a lot. The principle here is slightly different from the stack. Here we use this concept called as FIFO, first in first out, right? That's how an actual queue works. Whoever comes first gets priority, they get served, and then they go out and the next person walks in, right? You can see the effect on the image that's shown on your screen right now. Now, whenever you're taking a look at queues though, maybe let's just say the fourth person in this queue forgot her car keys or forgot her mobile phone or anything. Can she just walk out of the queue from the back as well? Is it possible? Well, of course it is possible, right? The advantage of queue compared to stack is that here operations can be performed both from the front and the back. When I say front and the back, what I'm trying to mean is the head and the tail, right? For example, the head of the queue is the first person who was there to be attended to, right? The tail of the queue will involve what? It will involve the last person in that queue. So basically, including all of these things, operations can be performed either from the top, or you can actually take the tail section and you can start either removing data or adding data from there as well. So this is how a general queue works. And when you're thinking about implementation in Python as well, remember one thing: FIFO, first in, first out. So depending on your object access, depending on what's actually required, you will be either thinking of using stacks or queues in most of these situations, right? Now that we are clear with stacks and queues, I want to take a look at another interesting data structure here, another user-defined data structure here. It's called as trees, right? Now, when we've been talking about these user-defined data structures, what we're trying to do is we're trying to use the syntax and the logic of Python to build ourselves our own data structure. That is the reason why all of these data structures are called user-defined data structures. I am sure you guys figured that out by now. Right? Fantastic, right? So when we're talking about a tree data structure, again, think of an actual tree, right? In an actual tree, you find root, you find the leaves, and of course you find, all the branches and all of that. Now try to see if you can take a look at the image on your left and find any of those, right? Let me help you out. This one, the node, this is a top node. Basically from this particular node, we have all the other nodes that are coming out, right? So this can be considered as the root. This can be considered as the primary. And from that, whenever you see every other node into it, there is a concept of the parent relationships that we build here. For example, 2 and 3, the nodes 2 and 3 have their parent as 1, because from 1 you got 2 and 3, right? Similarly for 2, now 4 and 5 become the children of 2. Similarly for 5, 6, 7 and 8 become the children of 5. Getting it, right? Now, one important thing that you really have to understand is that when you're working from the root node all the way to the leaf nodes, now what I mean by leaf nodes is basically all these nodes which do not have another connector node. Let's take a look at what they are. Are we having any other nodes connected to 3? No. So that's a leaf node. Similarly for 4, similarly for 6, similarly for 7 and 8, right? So most of the results of these computation that we perform when using a tree data structure usually lies in these leaf nodes aspect of it, right? They are the last nodes, but hey, in our case, they are some really important nodes that we are going to have to use, right? So breaking up a problem into a solution where you require a data structure which needs to be broken down in a compounded form, right? So if you have a very complex data set and you want to break it into modular chunks and use it as a solution, eventually one of those modules will give you a solution. The tree data structure is exactly what you guys should use, right? Fantastic. The next data structure that we're going to take a look at is the graph data structure. Now again, we've been using graphs, and I'm sure you guys have seen graphs. You have worked on graphs, be it school, be it college, or you guys might have seen the rise in the coronavirus spread. That's a graph as well, right? So we're talking about graph as a data visualization entity there. But in terms of Python, what are we doing? Well, here, graph is a data structure which basically has a structure which is very similar to a tree, but then the working of a graph is very different, because this sometimes is a closed loop structure which has a collection of nodes and edges. Now, you already know what are the nodes, right? So what are the nodes that you see on your screen right now? 0, 1, 2, 3, and 4. What are the edges that you see on your screen right now? Well, in between 0 and 1, there is an edge. Between 0 and 4, there is an edge. Between 4 and 1, there is an edge, right? Now, even though I directly do not have an edge from 4 to 2, we go through 3 and we still have an edge there, right? This is the concept of nodes. Nodes are also called as vertices, in case that's what you might have learned in your school or college, or in fact edges are also called as arcs, right? So regarding vertices, arcs, nodes, edges, you have to understand and you have to make sure that you do not get confused in these concepts. So as I told you, a graph is a closed connection of all of these nodes and edges. So can I have n number of nodes here? If I'm talking about a graph data structure in Python, it has to consist of a finite set of nodes and edges. Only then it is called as a graph data structure, right? Now think about a fantastic example of where this exact data structure is used. In fact, it's Facebook. Facebook is a fantastic social media that all of us, if not most of us, know and use. How do you think each of the individual people present in the Facebook's network get connected to others, right? When there is a connection from one person to another, think of it as an edge. But then these two people sitting in correlation with what we're discussing right now are the nodes, right? So you have nodes, you have edges, and now think about all the billions of people that are on Facebook, right? So it just becomes an entirely different network. It becomes a very super complex intertwined web. But then I had to really simplify it for you to talk to you about graph in terms of Facebook, right? But yes, this is used in Facebook, and if you break it down to its most simplest levels, you definitely will see this data structure used there and in thousands of other places, I'm sure. Right, guys? Now I have one more bonus data structure that I want to talk to you about. This is again the favorite of a lot of interviewers out there. So if you're a non-technical person who's had a chance to attend a technical interview, there is a very good chance you'll be quizzed on, first of all, everything that we have learned until now. Secondly, there's a good chance there's a question that's going to come up if you're looking for a career in Python, C, C++, C Sharp, or Java. 99% of the time they're going to ask you a question saying what are linked lists. Right. So to answer that question, linked list is another user-defined data structure that we have here in Python. Of course, we do not have native support for a linked list in Python. As in, we just saw how we can work with list, how we can work with sets and all of those, right? We have a valid syntax to use that. But to implement linked list in terms of Python, you actually do not have it in the standard library. So you have to use functions, you have to use other lists, and you have to use manual logic to actually implement a linked list. First of all, what is a linked list? Well, a linked list is basically a collection of elements tied up in a chain structure, right? It's basically linked. Again, look, the answer lies in the name of the data structure itself. A linked list is basically a sequence of elements that are connected to each other in a way where you can move around and access one or the other element as and when required. Now, if I have three elements that you can see on your screen, right? 5, 10, and 20, how do I even know that the location that holds the value 5 is able to talk to the value 10, right? This is where a simple concept of pointers are used. I'm sure you guys know what pointers are, right? Pointers are nothing but the simple addressing system that we use, the address that we attach to a variable, so that even though we do not know the value or where the value lies, as soon as we have the address in our hand, the second part of what I just said will negate itself. We will have an address. We know where that particular element 5, 10, or 20 exists, right? So if you just take this particular entity here 5, and there will be another criteria here called as next. So next is basically the name of the pointer. You would point that to where the data element of 10 exists. That is how the linked list works. Again, there's multiple types of linked lists. There's a single linked list, there's doubly linked list, there's a circular linked list. So there's many types, and it can get really complex. But one thing that we've seen a lot is that in terms of Python, linked lists are not super popular because you again have a lot of other data structures that you can try to use, and you can build the same application using something else where a linked list might have been a good fit, right? So implementation has to be done manually, but then even though it has to be done manually, even though it's not in its standard library, this is a super important data structure that again is used, asked, and worked with by all the professionals out there. So make sure you guys know your linked lists, right?
Now let's go ahead and work with some non-primitive data structures in Python. So the main non-primitive data structures in Python are tuple, list, dictionary, and set. So when it comes to all of these data structures, so you can store multiple elements inside one data structure. So till now we've worked with only variables, and when it came to variables, we could store only one value in one variable. Now let's say if you go to a music concert and you'd have to store the names of all the people attending the music concert, and the strength of the audience would be around 10,000. So to store the names, you would require 10,000 variables. Now that's a lot of variables, and you'd have to manually store all of these names inside 10,000 variables. So that's a humongous task, and that's a tiresome task. So this is where you would need these data structures, where you can store multiple elements inside one single data structure. So we'll start off with the first data structure, which is basically tuple. So when it comes to tuple, it is an ordered collection of elements enclosed within round braces. So we have Curious Jason over here, and he'll be coming in between to give us some pointers. So Curious Jason tells us that tuples are immutable. Now, what does he mean when he states that tuples are immutable? So basically, when you go ahead and create a tuple, so let's say you add 5 elements inside one tuple. Now, you can't change or modify the tuple which you have created. So that would basically mean that, let's say if you have 5 elements, then you can't change the value of the second element or the third element, or you can't add another element inside the tuple which you have already created. So this is basically the immutability nature of tuples. And this is how you can create a tuple. So you will use these round braces over here, and inside these you will given the values, right? So as you see, tuple is actually a heterogeneous data structure. So over here you are storing a numerical value, a character value, and a Boolean value. Right, so let's go to Jupyter Notebook and work with tuples. So let me create a tuple. So I'll name the tuple as tup1, and I'll give in the values. Right, so this is our tuple tup1. Let's see how can we access individual elements from this tuple. So accessing elements from tuple is the same as accessing elements from a string. So all you do is, given the name of the tuple, which is tup1, you given this square braces, and then if you want to extract the first element, which is basically present at index 0, you will type in 0 over here, and you have extracted the first element, which is 1. Similarly, if you want to extract the last element, you have to type in -1, and you have extracted the last element, which is 23. And if you want to extract a sequence of elements, so let's say I want A, true, and B. So this would be from index number 1 going on till index number 4, because we'd want 1, 2, and 3. So I'll type in 1:4, right? So I've extracted A, true, and B, right? So this is how you can extract individual elements from a tuple. Now, as I've told you, a tuple is immutable. So let me go ahead and try to change the value which is present inside a tuple. So I'll type in tup1, and let me change the value which is present at 0th index. And I'll change it to, let's say, 100. And we get an error over here. So the error is tuple object does not support item assignment. And that is because tuples are immutable. Now let me try to add a new value inside this. So we've got 1, 2, 3, 4, 5. So that would mean this is index number 4. So let me try to add something at index number 5. I'll type in Harry Potter. Again, we get the same error. So tuple object does not support item assignment because it is immutable. Now we'll head on to the next data structure, which is a list. So lists and tuples are quite similar. The only difference is lists are mutable while tuples are immutable. Now, what do I mean when I say lists are mutable? So this means that lists can be changed once they are created. So if there are 5 elements in a list, so the second element or the third element can be modified. And again, since I've said that there are 5 elements, so another 5 elements can be added inside this list. So this is the basic difference between lists and tuples. And this is how you can create a list. So you'll basically given square braces, and you'll given all of the values inside the square braces. So let's head on to Jupyter Notebook and work with lists. So I'll type in L1 and I'll give in some values over here. And then I'll print it out. Right, so this is a list over here. And accessing elements from the list is same as tuple. So if I want to access the first element, I'll type in L1, I'll give in square braces, and then I'll give in 0. So I have extracted the first element. Now let's go ahead and access a sequence of elements. So I want to access these 3 elements over here, true, 2, and B. So this is index number 2, and then going on till index number 5. So L1 and 2 colon 5. Right, so true, 2 and B. So we have successfully extracted these three sequence of elements. Now let me go ahead and actually change the values inside this list. So I'll change this value 1 to 100. So I'll type in L1 0 and I'll assign the value of 100. Now let me print out L1. So as you see, initially the value of this element was 1 and then we have changed the value to 100. Now let's say I want to add a couple more elements inside this list. So I'll type in L1.append and I'll add an element and name it to be, let's say, sword. And then let me print out L1. Right, so I've successfully added a new element. So now I can actually add a list inside a list. So let me again use the append function over here. And then I'll add a list inside this. So I'll type in 1, 2, 3, 4, and 5. So let me again look at L1. Right, so I successfully added this new list inside this list. Now we can also go ahead and remove these elements. So to remove the last element, we've got the pop function. So I'll type in L1.pop. So as we see, this last element has been popped out. Now again, let me type in L1.pop and let's see what will be popped out. Right, so this time this element sword has been popped out. Now let me have a look at the modified list, right? So we are only left with these values because sword and this list has been popped out. So this is how we can work with lists. Now let's head on to the next data structure, which is a dictionary. So dictionary is actually quite different than a list and a tuple because it consists of key value pairs. And these are actually unordered collection of key value pairs which are enclosed within curly braces. And again, dictionaries are mutable. So this is how you can create a dictionary. So you'll put in curly braces over here. So first you'll put in the key. So over here the key is apple and then you'll give in a colon and then you'll give in the value. So for the key apple, the value is 10. And then you'll give in the next key value pair. So after comma, the next key value pair is orange 20. So orange is the key and 20 is the value. So let's go ahead and create our own dictionary. So let me create the dictionary over here. I'll type in D1. And then I'll give in these curly braces over here. So I'll just give in some names of fruits. So let's say the first key is mango and the price of the fruit would be the value. So mango costs 45 bucks. And then we've got apple. So let's say apples cost us 30. And then we've got orange and then orange costs around 77. After that, we've got guava. And then this would cost around 125. Now let me print it out. So this is our dictionary. Now what we have is key value pairs. So if I want to access only the keys, then we have the keys function. So I'll type in d1.keys. So I'll give in the name of the dictionary and then I'll follow it up with the keys function. d1.keys, right? So I have extracted all of the keys, which are mango, apple, orange, and guava. Similarly, if I want to extract all of the values, which are basically the price of all of these fruits, I'll type in d1.values and I have extracted the prices of all of these fruits. Now, let's go ahead and modify some of these elements. So I want to change the cost of mango. So I'll type in d1 and then I'll give in the name of key. So the name of the key is mango and the cost would be 100. And then I'll type in D1. So initially the cost of mango was 45 and then I've altered it to be 100. So this is how we can work with dictionaries. And then we've got the final data structure, which is a set. So a set is an unordered and unindexed collection of elements enclosed within curly braces. So what do I mean by unindexed? So when I say unindexed, this basically means that sets don't have any index to it. So we can't really access the elements with respect to their indexing. And also another thing to be noted is sets do not allow duplicate values. So let's say if you add a value 10, then you cannot add the same value again. So it will take the value only once. And this is how you can create a set. So you'll have curly braces over here and then you'll give in all of the elements inside it. So let me create my final data structure over here. So I'll type in 1, A, and then I'll give in a floating point value, let's say 3.78. Let me print out the set. So this is our set over here. Now what I'll do is I'll copy this and let me try to add some duplicate values. So I'll add 1 all of these times, and then I'll also add a. Now let me print out S1 and then see what value do I get. So we see that duplicates are not allowed. 1, even though I have given around 5 or 6 times, it has been taken only once. And A I've given 2 times, but then again, it comes only once. So obviously set does not allow any duplicates inside it. Now let me go ahead and add some new values inside the set. So I'll type in s1.add hello world. Right, so I've added this new element. And if I want to add more than one element at a single time, then we've got this update method. So I'll type in s1.update and I'll give in a list of values. So I'll type in, let's say, Sparta, and then I'll type in 123. Then I'll give in, let's say, 3 plus 9j. Then let me print out s1. Right, so all of these elements have been added. Again, you see that the order of these elements is not preserved. It is random, right? So 3 plus 9j comes over here, and then we've got 123, right? So the random is not at all preserved. All right, so we are done with the basic data structures in Python, which were basically tuple, list, dictionary, and set.
Now let's talk about our first linear data structure, that is array. So what is an array? It is a linear data structure. That means elements will be stored in a linear fashion, right? Linear fashion. Now, if you talk about array, let's take an example. Now let's consider that this is how you represent an array in the form of a row, right? And let's suppose it contains elements 1, 2, 3, and 4, right? Now, with every memory location, there will be some address, right? So let's suppose these are the 4 elements, right? 1, 2, 3, and 4. And these are some addresses. Let's suppose this is 100, and this is 104, this is 108, and this is 112. Now, if you talk about memory, obviously these addresses will be hexadecimal. And when you talk about this particular array, it will be somewhere in the memory with 4, or you can say 4 bytes of memory for each integer. Now if I consider this integer, and let's suppose integer takes 4 bytes. Now these 4 bytes are available for each integer. Now this is an integer, right? Now it takes 4 bytes. Now the second address will start from 104, right? Because now again this will take 4 bytes, then 108, again it will take 4 bytes, then 101, 112, right? So in memory it will be somewhere around. But the thing that obviously you might be thinking, okay sir, let's suppose this is our memory, and now if we have 4 and 4 bytes, that means 8 bytes here and 8 bytes here, but they are available in chunks, right? This is one chunk and this is the second chunk, and rest of the memory is occupied. Can we store this array in your memory, in the memory? No, because it needs contiguous memory allocation. That means when this is the scenario wherein you have memory allocations or memory locations available in a one big chunk, right? That means if you talk about this array, it requires 4 into 4, that is 16 bytes are available, and they are available in a contiguous memory fashion, right? Or they are available in such a way that it is a one single chunk of 16 bytes. Okay, so then only you can store the elements at that location. Now obviously for simplicity I'm taking this addresses as a integer number, but in reality those are hexadecimal numbers. Okay, so it is easier for me. Okay, so now one more thing is that the elements are stored in a linear fashion, right? But can we access elements randomly? Yes, with the help of indexes. So if you talk about this array, right? 1, 2, 3, and 4. Obviously, there will be a name associated with this array, right? Now we have index 0, 1, 2, 3. Now, why indexing starts with 0, or why there is a 0 and indexing always starts with 0? Now, the question is that, right? Now, let's try to demystify this fact that why indexing starts from 0. Why not it starts from 1? Now, if you remember, right, I told you that there will be a name associated with this array, that is ARR. Now, this ARR is nothing but name of the array, and name of the array represents, right, it represents its base address, right? Now the base address of this was, earlier we spoke about it, so it is 100, this is 104, this is 108, and this is 112, right? So now this is 100. Now so let's talk about how you access We will talk about in the coming slides. We will see how to declare and initialize our array. But let's suppose if we talk about how to access this, we use array and then the subscript and then the index. Okay, the index is 1. Now I told you name of this array represents the base address. So base address is 100. Now plus 1. Now this 1 represents 4 bytes. Okay, so the 4 bytes, then what internally happens, it boils down to 100 plus 4. That means 104. Now 104 is not the first location, it is the second location. Okay. Now similarly, if you talk about accessing the second element or third element in the array, it boils down to what? Array of 2, which is nothing but 100 plus 2. Now this 2 is nothing but 8, right? 100, 108. So you will be accessing the third element in the array. Now how can you access the first element? So ARR of 0, now it boils down to 100 plus 0 because there are no bytes, right? So it boils down to this, that array indexing starts from 0, and now you know why. And this is how you can access elements randomly, so with the help of these indexes. Okay, so now you might be thinking, okay, now we have an array, can we store different elements, right? Can we store, let's suppose this is the array, can we store, in this we will store integer, then we will store a floating point number, then can we store a character? No. If you talk about any particular array, let's talk about this array. Now the data type or the type of data that you can store in this array will be homogeneous. That means you can only store similar elements. Okay, so these are some facts, and this is how array works, and what are the addresses, what are the indexes. Can you store different elements? No, you can only store similar elements in the array. Now let's talk about the applications of array. Now you might be thinking, sir, why do we need this array? What is the reason that we are using this array? So basically, when you talk about arrays, now obviously when you have a scenario wherein you want to store your elements in a linear fashion, right? And that too, you want to store them in a contiguous memory locations, right? So that you can use your CPU or you can use your memory efficiently, right? Not the CPU. You can use your memory and you can utilize your memory to the maximum, right? So you want to utilize your memory efficiently. At that time, you can use this. But obviously, it will have some drawbacks, right? It will have some drawbacks. That is why we have different data structures, right? So if you want to store your data in a linear fashion, you can use arrays. Okay. Now it is also suitable for the scenarios wherein you require frequent searching, right? If you want to search an element in an array, you can directly go and access these indexes one by one, right? So in a linear fashion, you will access, okay, is this the element that you're looking for? No. Is 20 the element that you're looking for? No. Is 30 the element that you're looking for? No. Is 40 the element that you're looking for? Yes. One by one, you can access all those elements and try to search for the element that you are looking for. Okay, so it is suitable for applications which require frequent searching. Now let's talk about one dimensional. So if you talk about 1D array, it can be related to a row, like we saw in the example, right? So that is what is a one-dimensional array. It is represented in the form of row, and we have addresses like 104, 100, 104, 108, 112, and 116. And indexing will be obviously 0, 1, 2, 3, 4, and then there will be a name associated with this array, which is ARR, and then you can store the elements in this array. Let's suppose here it is an integer array. Okay, so you can store only integer elements, and the size of this array is 5, and you have stored the elements 1, 2, 3, 4, 5. So now it can be related to a row wherein elements are stored one after the other, like you see. You have 1, then you have 2, then you have 3, and all of these numbers are in a contiguous memory, are available in a contiguous memory allocation. Okay, now when you talk about 1D array, there is only one index used, right? When you try to declare and initialize your array, at that time you will use one subscript. Okay, so how you can use that? So let's suppose if I talk about this special array that I have defined here, right? You will define it ARR, and then the the index is that the number of elements that are present here, which is 5. So only one subscript will be there, or one index will be used. Okay, so this is how you declare your array. So now let's talk about the declaration and initialization of this array. So obviously, when you talk about the array, there will be a name associated with the array. And then the data type. Are you going to store integer values in that array? Then the that one subscript or one index that we use, and then definitely the size of the array. So this is how you declare your 1D array. Now, how can you initialize it? There are different ways with which you can initialize it. Obviously, here you are declaring it. Then you might use a for loop to initialize all the elements, or you can declare or initialize your array at once. So how do you do that? So you will write, and let's suppose this is the integer array, and you don't have to specify the size. You can directly write the elements, right? And those elements, let's suppose those are 1, 2, 3, 4, and 5. In this case, when you're declaring and initializing your array at once, at that time this size becomes optional. You don't have to specify explicitly the size of the array, but obviously the size of this array will be 5. Okay, now since you are declaring and initializing it at once, so this is optional. But in the case wherein you are not initializing it, at that time the size becomes very important, and you have to mention this size explicitly. Okay. Now let's talk about two-dimensional array. So also it is known as 2D array. So it can be related to a table like this, or you can also say a matrix wherein you have rows and columns, right? Now in this, elements are stored one after the other in such a way that you can think of it as a 1D array. Now this is what 1D array, right? As we have already seen it, right? And inside this one ND array, you have another 1D array, right? Now this is known as 2D array. So now how it works, right? Let's suppose you have numbers over here, and you have four numbers: 1, 2, 3, 4. Then you have 5, 6, 7, 8. Then you have 9, 10, and 11, and 12. So this is a 2D array of having, and this will be similar to what? Of having three rows, right? You will have three rows, not four rows. You will have three rows, and in those three rows, right, you will have what? Four columns. One, two, and so numbers will be like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, done. So now obviously this will have, let's suppose this is a zero based indexing, and this will have a zero index here, one index here, and one. Now internally what is happening, it will be a 0 0, then it will be a 0 1, then 0 2, 0 3, then 1 0, 1 1, 1 2, 1 3, then 2 0, 2 1, 2 2, and 2 3 indexing, right? So similar to that, we will have this index will be 0 0, this will be like this, and this will be like this. So if you want to access the element that is present at this location, what you will do, you will run two for loops, right? One will be starting with from a, let's suppose one will start from I equal to 0 to the length of this outer array, that is 3 less than 3, right? So and the another from 0 to the number of rows that are there. Okay, so this one will be the outer loop, this one will be the outer loop, and this one will be the inner loop. That means the number of columns that are there. So this is for row, and this will be for column. That will start from 0 to less than 4. Okay. So this is how you iterate, and it will be similar to this. And now what about the addressing, right? What about the addresses that will be there? So this will be, let's suppose if this is 100, now this will be 104, this will be 108, this will be 112, this will be 116, because internally it is treated as if they are again in a contiguous memory location, but this time around you have a 1D array, and inside that 1D array you have another 1D array. So for declaring it, you will use two subscripts, right? So it will be something, the name of the array, then two subscripts. And now this will represent the number of rows, and this will represent the number of columns. So in this case, the number of rows will be 3, and in this, and the number of columns is 4, right? So this is how you declare your what? A 2D array. So dimension depends upon the number of subscripts you are using. So this time around, we are using two subscripts. Now, let's suppose you are using three subscripts, right? So similar to like this, 3, 3, and 3. Okay, so this time around, this is a 3D array. And similarly, you can have multi-dimensional array, right? And you just need to keep on adding the subscripts. That's it. Okay.
Now we shall learn regarding array implementation. right? We are solving three different problem statements here. The first one is we are creating one-dimensional array. It is very simple and people can understand it in very easy way. And the second one, we are concentrating on creating two-dimensional array. That means usually we use it for matrix, which includes rows and columns. Also, we call it as M and N or M cross N. All these three are the names which you can give it for two-dimensional array. And also two-dimensional array is used for different purposes. At the last, we are trying to sort, search and insert, delete the elements inside an array only which is having integers. So these are the problem statements we are solving for arrays in Python. So let's quickly hop into the IDE and check out the first problem statement. That is how to create one-dimensional array and insert elements inside that. Also put up the output, whatever the input is given by the user on the screen. So let's hop into the IDE now. Here I'm using Google Colab in order to put up the first program, right? So we'll rename this. I'm naming this as one-dimensional array. So now we'll come to this IDE and we'll type one-dimensional array example where you are including array size and you are asking the user what are the different inputs, and then we are presenting the same inputs received by the user on the output screen. So to quickly save the time, I'm just putting up the code now. So this is the Python code where we'll be using for one-dimensional array. I'll explain what is happening here. The first thing is we are asking how many elements to store inside the array. For example, it might be 5, 6, 10. So whatever the integer number is, the whole number, we can give it, right? So again, we are assigning a variable for input. So whatever the input is given by the user will be assigned to the variable called num, right? Then we are assigning an empty array. Why? Because whatever the size has been defined by the user is put up here. So if it is 5, it can take only 5 elements. If it is 6, it can take only 6 elements. That's how it goes. And immediately we'll ask to enter the elements inside the array. Then we'll be pushing through a for loop and we'll be using one important piece of code here, that is arr.append. Append in the sense will be assigning the elements one after the other at the back of the array. We are not putting up the elements which is inserted by the user in middle or in the front or somewhere, right? So append will always ensure the elements which is given by the user is put up at the back of the array one after the other, right? So next we'll display whatever the array elements are. So the array elements are, again you have to push through for loop because it has to just print the elements one after the other. So let's quickly run this program and check out how does this output look. Right? So it is asking how many elements do you want to insert into array. So I'm just putting up 3 as of now. So enter. Then it will ask you for first number. I'm putting up 4. And then the second number, that is 5. Then I'm giving 7. Okay. So it will display 4, 5, 7. Also, you can modify this outputs by giving commas, by giving spaces between those. If not, it can generally display this way, 4, 5, and 7. So this is about one-dimensional array in Python. Let's see the second problem statement in arrays for Python, right? So we are going to create two-dimensional integer array where you can insert row number and column number, and it will fill up the elements inside the array accordingly. So let's quickly switch on to the IDE, that's Google Colab, and check out how does 2D array work in Python. So here I have named this particular file as 2D array, and you can name it whatever you want, and I'm putting up the code here. So explaining the code for you that we have asked for row numbers. So how much the row should be in your matrix. I'll take it as matrix only because usually rows and columns will be using in matrix. So number of rows should be given by the user, and we'll store that number in r underscore num, that is row number. Again, we'll ask the user input number of columns, right? So whatever the number is given, integer value, whole numbers, is stored in cnum, that means column number. You can accordingly put up the variables as per the problem statement. So here, to keep it relatable, I have used rnum and cnum. Next, we are going to assign whatever the values we have, right, that is given by the user, that is, it might be a row number or it might be a column number, we'll assign that with the elements. So to assign, we'll be using for loop, because one after the other it has to be printed, right? At last, we'll be printing the final array and final matrix, two-dimensional array in 2D array. I've just put up a abbreviation here so it's understandable for you guys. So TWO2, D is dimension underscore array, ARR. I'm not put up completely array, it's just ARR. So this is how we initialize and the variables declaration, and this is how we execute the program. Let's quickly see the output of this. So I'm running. It is asking for the first time, that is input number of rows. So the number of rows I'm giving here is 2, and again I'll enter. It will ask for number of columns. So then it is 3 here. I'm entering that and it is giving you 2 rows and 3 columns. Also, if you want, you can arrange it as per matrix. So one after the other, but here I'm showing it for you guys just with, see, you can count 3 columns you have and 2 rows. Right? The bracket defines the rows here, right? The first bracket, set of brackets is for first row and second set of brackets is second rows. So this is how 2D array works in Python. So we are going for the third problem statement which we are solving for array in Python. So it says implement search, sort and delete operations on array of integers, right? So I'm breaking these 3 operations, that is search, sort and delete, into 3 different programs to make it simpler rather than combining everything and making it to one huge program. So first I'm concentrating on deleting elements inside an array of integers in Python. So quickly we shall hop into the IDE and see the program. Here Google Colab is ready and the page is empty. I'm just pasting this particular code in order to use time efficiently. So explaining this code, the first line it says enter the size of an array, right? We are first accessing an array size. For example, it might be 10, 5, 8 as per the user command, and then we are inserting so many elements into that particular array. Say for example it is 5, right? So we are inserting 5 different elements which we have already seen by now. So next it is asking which element to delete, right? So we are telling an element, an integer, to delete. Then it will display the new array for you. So for loops are there in order to keep the array in sequence, and it might be printing or it might be taking input from the user. Both we are using for loop only, and append is for putting up the elements into the back of an array, right? We are not inserting element in middle or somewhere in the front. Abruptly, the insertion should not happen. So one after the other sequentially, in order to append, in order to insert the elements, we use arr.append. So let's quickly see what is the output of it. So if you have entered any element which is not there in this particular array, right? So it will give you element does not exist in an array. So this is how the program will work. So let's quickly see the output now. So it is asking for array size. I'm giving 3. I'll enter. Then entering all the 3 numbers what I want to give. Okay. It will ask you which value to be deleted, right? I'm giving value 5. So the new array is without 5, that is 4 and 6. So this is how it will work. And immediately I'll show you if you give any element which is out of the array bound, how it will give you an error. So I'm taking 3 elements again. 5, 7 and 8, right? So it will ask you which value to be deleted. I'll say 1. 1 is not there in the array. It is just 5, 7 and 8, right? So if you put that, it will say element does not exist in an array, right? So this is how deletion will work in Python arrays. After knowing how to delete element in an array, so we have to see next, how do you sort elements inside an array in Python? So let's quickly hop into the IDE and check out how do you sort elements inside an array, right? So here we'll start coding. Just putting up the code here. So array is already defined. The elements are 10, 22, 38, 27, 11, so on, right? So we have 5 elements here to be sorted in ascending order, and you can also make it descending as well. I'm showing you for ascending order. So what is happening here? I've just put up a comment for better understanding. Displaying elements of original array. Original array in the sense whatever it is here is displayed first, right? So next it is sorting by using for loop, right? So every element it will chuck and it will try to compare with the next element. If it is greater, it will push up that particular element to the back, and whatever it is lesser will come in front. So this kind of exchange will happen and it will sort in ascending order. So ascending in the sense from smaller to higher number. So quickly it will display after sorting the elements of array sorted in ascending order are so and so. So let's quickly see what is the output of this particular code. Right? So we have original array which we have given, that is 10, 22, 38, 27, 11, and then we have the sorted array. So in ascending order it is 10, 11, 22, 27, 38. So this is how it will sort. The major function where it will be sorting is we are using this particular lines of code which I am just highlighting in this particular IDE, where it will compare each and every element inside the array to the next one. If it is greater, it will push it to back. If it is lesser than the compared array element, it will push it to front. So this operation will happen in this particular lines of code, right? You can also sort by using sort function directly as well. So this is a simple example to know how sorting will happen in Python. Now we shall see how do you search an element inside an array. So here I've tried to put up occurrence as well. So let's quickly search and see elements in an array in Python ID. Okay, so this is the code in order to search the element, also find the occurrence of it, right? So here this is the array set. So I'm giving the number 1, 2, 3, 1, 2, 5. So you can see 1, 2 has been repeated. Those two integers are repeated. So first it is showing up the created array. Whatever the array which has been given is put up in the first place. And next what it is doing, it is trying to find the occurrences of it. So with the help of index, right? So the element 2, the number 2, so where it is present and how many times, right? So first where it is present, it will show that. The second time will not be counted. First occurrence will be counted. So let's quickly see the output of this particular code, right? So here the new created array is, so whatever the given array by the user has been put up in the first line, and the second line it is saying the first occurrence of 2 at position 1. Why? This is 0, 1, 2, 3, 4, 5, right? So 2 at the first time is present in the index value array 1, right? Again, next it is searching for 1, where it is the first occurrence of 1 in array is at index point 0, right? So it is showing the output 0. Again you have 1 here, that is 0, 1, 2, 3. Also you have second 2 in fourth position, but still wherever it is available at the first is being demonstrated in this particular program, right? So this is how the occurrence is counted. Also the elements are searched in Python.
Now let's talk about advantages of arrays. So obviously when you have indexes associated with the array, right? We have indexes. So it is easy for us to access any element, right? With the help of this index. So if I want to access the third element, you can directly go ahead and say ARR of 2 in the 1D array, right? So you can directly access elements with the help of indexing. Similarly, it is easy for us to iterate through it, right? With the help of one for loop, we can iterate through all the elements, right? One by one that is there, okay, that are there in the array. And similarly, if you want to do the sorting, we can go ahead and easily iterate through these elements one by one and look for an element. If we are trying to search an element in the array, let's suppose we are searching for 3. So one by one we will search. Okay, is this element 3? 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 Right? And if this element is 3, we can easily search. And also for sorting, right? Let's suppose we want to sort this array. What would it be? It will be simply what? If you have 4 here, 3 here, 2 here, 1 here, and let's suppose you have 0 here. Okay, so now you want to sort this in the ascending order. So what you will do, you will use two loops. One will focus on this first element, and then the second one will compare all the elements. Okay, and then at the end of this thing, you will have the largest element at the end of the array. So sorting, iteration, searching, it is easy in array. You just have to iterate through all the elements one by one. Now, it is a replacement of multiple variables. Now, what do you mean by this thing? Let's suppose you have an integer, or let's suppose you want to store the roll number of 10 students, right? So, what you would have done earlier prior to what? When you don't know the arrays, what you would have done, you would have said roll number one, and then or you can say S1, S2, S3, S4, and one by one you can store the roll numbers in these integer variables, right? So as soon as our students increase, now let's suppose we are talking about here 10 students. Now as we talk about 100. Now what happens if we talk about 500? Are you going to write 500 variables, integer variables, S1 starting from S1 to S500? No, it is a very inefficient way of doing so, right? So instead, what you can do, you can create an array and you can create an integer array and name it student, and therein you will have the size which obviously represents the number of students that are there, and in this case it will be 500. Now if you want to change it to tomorrow, if you want to change it to 600, you can go ahead and easily change it to 600, right? So it is the replacement of multiple variables. So this is what it means. Now let's clear the screen, and now let's talk about disadvantages. There is one disadvantage that can be easily noticed is the size. Now, obviously, when you're talking about 1D array, right, the size, or any array, right, the size is there, right? So you cannot exceed this size. The elements cannot exceed this. So let's suppose you have the size is 5, you can only store 5 elements, right? You cannot go more than that or beyond that. Now, if you have a size 100 and now you're trying to store only 2 elements, anyway, the 100 memory allocations will be there for this array. That means you are wasting your memory. You are not utilizing it efficiently. Okay. So this is what it means, that size is fixed and you cannot store more elements. And if the capacity is more than occupancy, most of the array gets wasted. Okay. So these are two things. Apart from this, you need a contiguous memory allocation. That means if chunks of memory are available here and there, you cannot store an array which is, let's suppose here you have 16 bytes and here you have 16 bytes. Only if you have an array which is of 16 bytes, that means if you have an array of size 4, that array can be stored here. But if you have an array of, let's suppose, size 8, you cannot store 4 elements here and 4 elements here. That will not be happening. Okay, that cannot happen rather. Okay, because it needs contiguous memory allocation. So there is one more disadvantage. And the last but not the least is that insertion and deletion is difficult. Now, why do you say that? Let's suppose you have an array and you are having in this array 1, 2, 3, 4. Now let's suppose you want to insert a value 0 at this location. Now what you need to do, you insert the 0 and rest of the elements, every element will be swapped. So swapping is required, right? Swapping is required. Plus there should be memory available so that you can store that element. Else, if there are only 4 elements and now you want to store 0, and the size is also 4, at that time around what happens, you will store 1 and rest of the elements will be swapped and you will be losing this value. So it is very difficult to insert the value. Now, same thing will happen when you're trying to delete, but at that time you will not be losing data, but yes, swapping is required, right? So let's suppose you want to delete this location. So what you will do, or delete this number, what you will do, you will overwrite this with 3, you will overwrite this with 4, and let's suppose if there is 6, you will overwrite this with 6. So at the end you will have 1, 3, 4, 6, right? 1, 3, 4, 6, and one memory allocation is there, and it will contain the same element, that is 6. So next time around, you will just overwrite this. So again, the swapping is required. So it is very difficult to insert and delete an element in the array.
Let's see the concept of stack. Now coming to the stack, stack is a linear data structure which follows last in first out order. That means the element which are inserted at last will be removed first. That is LIFO order. Last in first out. Now insertion and removal of the element has done at one end. I will explain you now. So let's see an example of a stack. So here if I'm having 23, 45, 67, 89, 11, and let's suppose I'm having 50. So these are the elements that has to be inserted in this stack. So now what I will do, so this is my empty stack, let's suppose that, and inside this stack I will insert these elements one by one. So first I will insert 23, after 23 I will insert 45, then I will insert 67, after 67 89, 11, and 15. So this is my stack. Now as I told you, the element which is inserted at the last will be removed first. That means last in first out or LIFO order. So you have seen here 15 is the last element that has been inserted here. So now if you want to remove the element, then 15 will be the first element that will be removed. So for insertion we are using push. So push was used to insert the element and pop will be using to remove an element from the stack. So 15 is the last element that was inserted. So now I will be using pop to remove this 15. So once 15 has been removed, then I am having element 23, 45, 67, 89, and then 11, right? So once again if I want to remove the element, then my 11 will be removed. So once again I will write here pop. So always remember that push operation will be used for the insertion and pop operation will be used for the removal. So whatever the elements I was inserting here, 23, 45, 67, 89, 11, 15, I was using push operation. So if I'm writing push 23, then 23 was inserted. Then after that if I am writing push 45, then 45 was inserted. And after that if I'm writing push 67, then 67 was inserted, and in this way I can use the push function to insert the element. Now as I written here, insertion and removal of the element has done at one end. Why? If you see, this was my stack, right? So this is my stack. So whatever the element I was inserting in an empty stack, I was inserting it through one end, right? And I was doing insertion through push operation. Now if I'm doing the pop operation, then also I'm doing the pop operation through one end. So that's why you can see that here it is written that insertion and removal of the element has done at one end. So this was the basic concept of stack. Now let's see the example of stack. So you can see here, this is my pile of coin, right? So this can be considered as the example of stack. Why? Because the last coin is removing first here. So this follows last in first out. So I will remove one coin, one coin. So if I'm removing step by step, that means the last coin will remove first, and in this way if I will follow, then you can see that I can remove one coin one after other, one after other, and in this way this will be the example of stack. Similarly the same example goes for the DVD. If I am removing one DVD after other, then this can be example of stack. So the DVD which was inserted at last will be removed first. The same goes for the books. The book which is on the top will remove first, and after that if I am going one by one from the top, so you can see that the last book that was kept will remove first, and in this way these can be the example of stack. So this was the basic example of stack. Now let's see some functions associated with stack. So we are having push function. So as I told you that if I'm writing here push 23, and let's suppose this is my stack. So this is an empty stack, so it will insert 23 here. So here you can see that it is used to insert the element x at the end of stack. So here instead of x, if I'm writing 23, then it will insert 23. Similarly pop function, as I told you that pop will remove the element from the stack. So it is used to remove the topmost or last element of the stack. So if there is only one element in the stack 23, and if I'm writing pop, then it will remove 23, right? And also please remember that it will remove the topmost or last element. In case of this stack we are having only one element, so this will be the last element. So if I'm writing pop, then 23 will be removed. But what if I'm writing here push, let's suppose that 25, then 25 will be inserted here, and once again if I'm writing pop, so this will be the last element, so 25 will be removed. So this was the basic idea about push and pop function. Now coming to the size. So size function will give me the size, or you can say the length of the stack. Next we are having top, so it will give the reference of the last element present in the stack. So let's suppose that this is my stack and I am having 23, 25, and let's suppose 27. So this is my last element here. So top function will give me the reference of this last element. Now Coming to the empty function, so empty function returns true for an empty stack. So if this is a stack and if this stack is empty, then the empty function will return us true, right? So this was the basic idea about functions in stack and what will be the time complexity for each function. So here the time complexity for each functions will be big O of 1 for push, pop, size, stop and empty. So for every function, time complexity will be big O of 1. So this was the basic idea about the functions. Now let's see the stack implementation. So there are several ways to implement stack in Python. We can use list, we can use collection module from where we can provide dequeue class, and we can also implement through queue module. So these are some ways from which we can implement stack in Python. So now let's see the implementation using list. So in implementation using list in Python can be used as a stack. So we can use list as a stack in Python. So in Python we are having append and pop function. We don't have any push function in Python. So if you want to insert the element, we need some function, right? So we can use the append function, which is used to insert the element. Now coming to the pop function, yeah, we are having pop function in Python, and pop removes the element in the LIFO order. That means last in, first out. And as we know that our stack also follow the LIFO order, the elements which are inserted at last will be removed first. So these two are the functions that we will be using here in list. Now let's see the logic of this. As I told you that list in Python can be used as a stack, right? So here I am using list as a stack. So this is my stack variable and this is an empty list. And now as I told you that if you want to insert the element, then you can use append. So this was my empty list, that is stack. And as we know that in Python, list is denoted by square brackets. So now what I will do, I will write here stack dot append, and inside this append, if I'm writing x, so x will be inserted in my list. Now coming to the pop function, if I'm writing here stack dot pop, and if I'm writing print, and inside that if I'm putting it, then whatever the element I'm having, it will remove. So let's suppose that this is my stack, and in this if I'm having x element, so if I'm writing stack dot pop, so it will remove this x element, right? Because I am having only one element here, so the last element will be removed from the stack. So this is the basic idea from where stack can be implemented using list. Now let's see the practical example. So now for practical implementation, I will be using Jupyter Notebook. So I will click on here new, and then I will go for Python 3. And if I'm writing here, I'll give the name here stack. And let me comment it down first here. I will write here hashtag, and I will write here implementation using list. So as I told you that stack can be implemented using list. So I'll create a stack variable, and this will contain list. This is an empty list, and after that I will write here stack dot append, and inside this if I am writing here welcome, and after that once again I'm writing stack dot append, and I will write here now 2. Once again I will write stack dot append. I'll write great learning. So you can see that this is my append. Now if I'm printing my stack, so I will click on run button. So you can see that this is my list, and earlier my list was empty, but now through append function I have inserted welcome to great learning. So now this is my list. Now what I will do here, from this stack I want to remove the element. So for that I will be using pop function. So I will write here stack dot pop, and I will put this stack dot pop inside a print function. So I'll write print, and now let me execute this. So on executing, you can see that I am getting great learning. So that means the element which was inserted at the last has removed first, right? And as I told you that pop will always follow the LIFO order, last in, first out. So if I'm printing my stack, you can see that I am getting welcome to, because great learning has been removed through pop function. If once again I am writing here, let me copy and paste this, Control C, Control V. So once again I am performing here stack dot pop, and if I'm printing stack, then you can see that I will be getting welcome only. So you can see that welcome I am getting, and here stack dot pop, if I am doing, then 2 has been removed, right? So clearly we can see that we can implement stack using list through append and pop function. So this was the basic idea about stack implementation using list. So the another way the stack can be implementation using dequeue. So we'll see the concept of implementation using collection.dequeue. So here stacks in Python are created by the collection module which provides dequeue class. So now let's understand, this is a collection module. So in Python I will write here from collections. So from collections module I will import my dequeue class, right? So I will write from collections and then I will write here import dequeue. So dequeue here is double-ended queue, and here append and pop operations are faster as compared to list. Why? Because the time complexity of dequeue is big O of 1, whereas the time complexity of list is big O of n. And also in list, if you are inserting more element, then the list will grow and it will go out of a block of memory. So Python have to allocate some memory. So that's why on inserting more element in a list, the list will become slow. So that's why we come with the another way. From the collection module we import dequeue, and then so I will create my stack variable and inside that I will assign my dequeue, right? So now I will perform the same operation that I was performing in list. I will write here append and pop. So always remember that dequeue will be preferred more as compared to list because the append and pop operations are faster here, right? And rest all the concept is same. So let me execute it. So now let's see the implementation with dequeue. So let me comment it down here. I will write here implementation using dequeue. Now after this, as I told you that if I want to implement dequeue, then is a class, right? So I have to import it from the collection module. So for that I am writing here from collections import dequeue, and I will write stack variable, and inside this I will assign the dequeue. Now after this I will write here stack dot append, and let me write the value as x here. And if I am printing my stack, so on execution you can see that I am getting my dequeue as x. Now let me append some more values. So I will write here stack dot append y, and after that I will write here stack dot append, let's suppose z, and once again if I'm executing, so I will write here print stack, and on execution you can see that I'm getting xyz. Now let's perform pop operation. So I'll write here stack dot pop, and let me put inside this into the print function. So as we know that if I'm writing here stack dot pop, so the last element which was inserted will remove first, so z will be removed here. So you can see that it's z has been removed. Now if I'm printing my stack, so I'm getting here only x and y. So you can see that list and dequeue are the same. The only difference is that dequeue is faster because the append and pop operations are faster in dequeue. So this was the basic idea about the stack implementation using dequeue. Now let's see the stack implementation using queue. So here in implementation using queue module contains the LIFO queue, that means last in first out. So here basically what happens here, it works same as the stack, but it is having some additional functions. So it is having some additional functions and works same as a stack, right? Now we have seen that in list as well as in dequeue we were using pop as well as append operation, right? But here to insert the element we will be using put operation. So if I'm writing here put of 3, then that means it will insert 3 in my stack. So similarly if I'm writing here get function, so it will remove the element. And as I told you that it works same as the stack, so the last element will be removed first here. Now we are having some functions available in the queue module. So the first function, that is get. So as I already told you, in get function it is used to remove the element. Now coming to the max size, so here max size means the number of maximum elements that are present in the queue. Coming to the next function, we are having empty function. So if a queue is empty, then it will return true, or else in other case it will return false. Next, full. So whenever the queue is full, it will give us true. Similarly, put, I have already discussed about the put, that if you are inserting any element, so you can write the put, and suppose if I am inserting here 2, so it will insert 2 in a queue. Now queue size. So queue size will give me the size of a queue. So let's suppose that if you are having a 3 elements that are inserted in queue 3, 2, 4. So what will be the size of the queue? Queue size will be 3. Now coming to the logic, so how can I import LIFO queue through the queue module? So I will write here from queue, and then I will write here import, and I will write here LIFO, and then I will write here queue. After that, as I told you that stack can be implemented through the queue module. So I will create a stack variable here, and I will assign here LIFO queue. So I will write here LIFO queue. And now if I'm writing here stack dot put, and if I'm writing 2, so this means I am inserting the value 2 in a stack. Similarly, if I'm writing here stack dot get, so that means I am removing the value from the stack. So this is the basic idea. Now we will see all these functions in the practical coding example. So let's start with the coding part. I will write here comment, and inside this comment I will write here implementation using queue. Now after this, what I have to do, I have to import LIFO queue from the queue module. So what I will write here, I will write from queue import LIFO queue, and I will create a variable stack, and I will write now LIFO queue. So after creating stack variable, as I told you that if I want to insert the element in a queue, then I have to use the put function, right? So I will write here stack dot put, and I will insert here, let's suppose 2. So you have seen that I've already inserted a 2 element. Now let me insert some more elements. So I will write stack dot put, and I will insert 3 here, and after this I will write stack dot put 4. So this is all about the put function, right? So we have seen several functions in queue. So let me write here function. So here I will write print, and if I'm writing here stack dot queue size, so as I told you that queue size will give you the number of elements that are present in the queue, and I have inserted 3 elements, so the queue size must come as 3. So on execution you can see that I am getting the queue size as 3, right? Now I've also told you about the max size function, right? So inside this, if I'm writing here max size is equal to 3, and if I'm writing here once again print, and if I'm writing stack dot full, so as I told you that full function will return true if my stack is full. So here I have allocated the max size as 3, and I have inserted 3 elements. That means my stack is full. So on execution you can see that I am getting true, right? Because my stack is full. Now if I want to remove the element from the stack, then which function I can use? I can use here stack dot get. And now if I'm once again writing print stack dot full, will I get true value? No, because I have removed one element. So if I'm running it, so on execution you can see that I'm getting a false value. So here you can see that we have used the put function, get function, full function, queue size function, max size. So this is the basic idea about the stack implementation.
Now let's try to understand queue linear data structure. What is queue? Queue is a linear data structure. That means all the elements in the queue are stored in linear fashion. Now it follows a principle of FIFO. That means there's a restriction that whatever is the first item in is the first item that is to be out. Okay, so now let's try to make a queue. Let's suppose you are in a queue and you're waiting for a movie. You're waiting for a movie ticket to buy. Okay, so there is one person, then there is another person, right? So these are few persons here, right? And you're waiting in a queue. So now the first person who is in the queue will be the first person who will get his ticket, right? Makes sense, right? So he will be the guy who will get his movie ticket first, and he will be out of the queue. Then the next person who is in the queue is the next person who will get his tickets, right? And let's suppose a new person comes in. He's not going to go ahead from this person, rather he is going to go behind this person. Then the next person comes, he will go after this person, and in the same way. So this is nothing but a FIFO principle. Okay, the first person in is the first person out. Okay, now insertion will always take place from the rear end. Okay, and if you talk about deletion, it will always take place from the front end. Okay, so this is our front end and this is our rear. Cool. So, for examples, buying tickets from the counter, or it can be a movie ticket, or it can be a bus station. You are in front of a bus station trying to get tickets for your bus, right? These are some examples. Now, there are four major operations when you talk about queue. What are those major operations? Let me clear my screen. So, NQ. So, you are going to insert an element in the queue. This is what you mean by NQ. DQ, you are going to delete an element, okay, from the queue. Then peek first, that you're going to peek the first element that is in the queue. And peek last means that you're going to peek the last element that is in the queue. So you will have two pointers. One is front and another is rear. And with the help of these pointers, you're going to NQ, DQ, peek first, peek last. You're going to perform these operations. Now, one major advantage of these operations, these four operations, is that all of these operations are performed in a constant amount of time. That means the time complexity of performing these operations is O of 1. So that is why when you talk about competitive programming, Q is most commonly used data structure because of these things, right? Because of its time complexity, right? You're able to perform your operations in a constant amount of time. Now let's talk about applications of queue. So it is used in scheduling algorithms of the operating system, like first in, first out scheduling algorithm is there, round robin is there, and we have multi-level queue that is there. In all these algorithms, queue is used, okay, for storing the data or the processes. It's also used in maintaining playlists. Like when you have a playlist, let's suppose you have 10 songs in a queue, right? And after one song, the next song which is in the queue will be played, and it goes on for like this, right? So for maintaining a playlist, again, a queue is used. It's also used in interrupt handling. Let me take an example here. You know the process state diagram of operating system. So it is also used at that time. So when you have an interrupt and therein if your process is being executed at that time, that process is preempted out and it is stored in a queue. Now, the next time when this priority or this interrupt is handled, once it is done, then it starts picking up the process which was in the queue and starts executing that. In the meanwhile, if there are some other processes, that those processes will also be in the queue. So a queue is maintained, and once the interrupt is handled, they will start taking out that process that was being executed earlier and executes it and completes its execution and terminates the process. So it is also used in interrupt handling.
After learning what is queue in Python, theoretically, let's know how to implement that into practicality. So queue will be having two different basic operations, that is NQ and DQ. So these things will be shown in with a simple example in Python. So let's quickly hop on to Python IDE, that is Google Colab. For the reason I'm using it is visible for everybody to access because it's online availability and it is open source. So let's quickly start the simple program for queue displaying two different functions, that is NQ and DQ. So here is the Google Colab environment where you'll be working. So I'm just pasting the code here, which is already done by me. So in order to avoid time, and I'll explain each and every line of code here now. What we are doing in this particular code is we are creating a class called queue, right? We are also giving different functions for NQ and DQ. NQ is nothing but entering or inserting values to the queue, and DQ is deleting values from the queue, right? As you all know, queue will follow FIFO, that is first in, first out. So wherever you want to buy a ticket, for example, in your railway stations or anywhere, you will stand in a queue, right? So whoever in the first will get the ticket first and he or she will move out of the queue. It's same in here as well, but the elements are not humans, it's all integer numbers. So whatever the number you put in first is the first number to get out, right? So let's quickly see. Here we have two different functions as I mentioned, that is enqueue and dequeue, and later you will display. We are seeing three different functions, displaying, enqueue and dequeue. So what happens here is we are using self.queue.append. So here whatever the item, whatever the number you give, right, it will be inserted to the back of the queue, right? It is maintaining the sequential process of inserting the numbers or the integers or the values you give in order to insert into the queue. And while deleting, you can use pop, right? Is it append for insert and pop for deleting. And display is nothing but a normal print statement. You will display whatever the queue it is accordingly. So let's quickly run this program. Here I have just used certain numbers 1, 2, 3, 4, 5 numbers, and the after dequeuing, right, what it should display, it should remove 1 first, and 2, 3, 4, 5 should be displayed. So let's quickly see how it is, right? Okay, so as you can see, whatever the queue is given is printed at the first place, that is 1, 2, 3, 4, 5, and then after removing the first element, right, so the first person will be removed because it is FIFO. So 2, 3, 4, 5 is there. So this is how a simple basic queue will work in Python. So after knowing a basic queue implementation, right, let's see one of the type of queue, that is circular queue implementation. There are many types of queues, but still I'm taking circular queue as an example and showing you the same operations of inserting and deleting elements from the queue. So let's quickly hop into the Google Colab IDE and check out the program. How can we build a circular queue in Python? Here is the program for circular queue, and what are the different elements we have inside this program? Let me tell you. The first part is class declaration. So here my circular queue is the class, right? So class can be named accordingly or whatever you feel right. So keep it very program oriented rather than keeping which is off topic. So here it is my circular queue, and then again we have two different initialization, that is for enqueue as well as dequeue. So whatever the elements we use here, right, whatever the items we try to insert in the queue, we have to ensure whether the queue is full or the queue is empty and there is still space or not. So all the conditions should be checked. So let's hop into enqueue and check out what are the different conditions you have to check. So the first thing is the queue is full or not. So before inserting something, say for example, the queue size is 5 and the element 6 has been inserted, then it has to show an error message, that is, there are only 5 spaces, they are inserting 6th element, it is not allowed, hence the queue is filled. So in order to print that, we use this, the circular queue is filled statement. So the next part is you have to know how when it is empty, right? In order to have the dequeue, the main condition is whenever the elements are out of the queue, then it has to be declared as the queue is empty. So nothing to delete from the queue, it's all the elements or items are deleted already. So the error message or the statement to the user will be the circular queue is empty now, there is nothing to pop out or delete or dequeue. So apart from that, also you can also find if you are trying to print something, right, if it is empty queue, it does not have anything, then you have to show up the no element in the circular queue found statement. Why? Because if there is no elements, there is nothing to show or display, the display function does not work, the print does not happen. So this is the basic idea of this particular code, and accordingly we have used the iterations and the declarations. So next you have to look at the inputs what we are giving. I'm trying to give 12, 22, 31, 44 and 57, right? So the 5 elements for the queue is being given, and what you have to do is you have to check the initial values. First you have to display the initial values, what is the exact queue which you have given with the elements to the user, and then which is deleted. So the first element is deleted obviously, but yes, how the circular queue is different from the basic queue, right? So let's quickly run the program in order to see the output. Okay, if you could see the output here, right? So initial queue values. So is whatever we have given here, that is 12, 22, 31, 44 and 57. So after removing an element, so obviously the first in first out process, the first element will be removed. So it is 22, 31, 44 and 57. What is difference between a normal queue and a circular queue? If you could see here, right, in the last space after 57 you have a space allocated. So in normal queue, it is not connected. Here, the front and rear is being connected, forming a circle, right? If the first element, for example, 12, goes out, the 22 will take the first place and 31 followed by 44 followed by 57. The last place will be empty, right? So it is in circular motion. So whatever you want to insert again, right? So that will, for example, if you want to insert 6, right? 6 will sit in the fifth position, that is after 57, right? This will be connected circular motion, that is front will be connected to the rear part. So this is the difference between the normal basic queue and the circular queue.
Now let's talk about advantages and disadvantages of queue. First, we are talking about advantages. So it follows a principle of FIFO, or the elements are stored in a FIFO manner. That means, let's suppose this is a queue, and in this queue you have elements. So the deletion will take place from the front, right? And the insertion will take place from the rear side. So this is known as dequeue, the deletion, and insertion is known as enqueue operation. And both these operations are performed in a constant amount of time. So that is one of the advantages, right? And the insertion from beginning and deletion from end takes a constant amount of time. Plus, if we want to do peak first, peak last, all these operations are performed in a constant amount of time. And this is most widely used data structure when we talk about CP, that is competitive programming. When we talk about competitive programming, this data structure is most commonly used because of these features, that all the operations that are performed like insertion, deletion, peak first, peak last, enqueue, dequeue, all these operations are performed in a constant amount of time. Now let's talk about disadvantages. Since we are only able to delete or insert from the front and the rear, that means deletion from front and insertion from the rear. So the restriction of insertion or any manipulation, right? We have a restriction over these, right? What? These operations, insertion and deletion. So this restriction is always there. And so this data structure, that is the queue, is not much flexible, right? We are fixed. We can delete and insert element in a fixed pattern or in the FIFO manner. Thus, it's not much flexible.
So now let's start with the linked list. So linked list is a collection of group of nodes. Now what is node here? So here you can see that this is a node. So a node will contain a data as well as reference. So each node contains data and reference, which contains the address of the next node. So this is a node, and as I told you that node will contain a data as well as reference. So let's suppose I'm inserting the data here 20, and this is nothing but a reference, or you can say that pointer. So this pointer will contain the address of the next node, right? So as I told you that linked list is a collection of nodes. So this is nothing but a single node. So let's suppose if I'm having more than one node, and if I am connecting them, then it will form a linked list. So we will see the linked list representation in the next slide. Now, so linked list is a linear data structure. Now coming to the last point, we know that in array as well as in list, elements are stored at the contiguous memory, whereas in linked list, elements are stored randomly. Now let's see the representation of linked list. So as I told you that linked list is a collection of nodes. So let's suppose that this is my n1 node, this is my n2 node, and this is my n3 node. So each node will contain data as well as reference, or you can say pointer. So this is data and this is reference. So now I will give the address of this n1 node. So let me write the address of this n1 node as 2010. I will give the address of this as 2020, and I will give the address of n3 node as 2030. So these are the addresses. So as I told you that each node will contain a data. So let me assign here data. Let's suppose 10 is here, and a reference, or you can say a pointer. So I told you about pointer, that pointer will contain the address of the next node. So what's the address of next node? The address of next node is 2020. So I will write here 2020. So this pointer or this reference, or you can say this link, will contain the address of my next node. And what's the address of my next node is 2020. Now again, this will be a data, and this will be a reference of my N2 node. So let me assign here data as 20, and what will be the reference? The reference will contain the address of the next node. So here it will be 2030. Now again, this N3 will also contain data, so I will assign here 30. So now you might have a question that what should be reference here? So now, are you seeing any node after this N3 node? Do we have node N4 or N5? Not, right? So this reference will be assigned to null. So I can write here 5 because there is no next node is present there, right? Now coming to head, what is head? So head will contain the address of my N1 node. That means 2010, right? So this is my linked list representation. Now the question arises that why linked list? So now why do we need linked list? Because linked list is having more efficiency for performing the operations as compared to list. So what are the operations that we are performing in linked list? We can perform the operations like insertion, deletion, as well as traversal. So it is having more efficiency in performing the operation. So moving to the next point, as I already told you that in linked list elements are stored randomly, whereas in list, or you can say in array, elements are stored at contiguous memory. Now moving next, accessing the elements in linked list will be slower as compared to list. So if you want to access the element in linked list, it will be slower as compared to list. Why? I will tell you the reason. Now let's see this slide, linked list representation. So here this is my N3 node, right? And if I want to access the data elements of this N3 node, then I have to go from N1, N2 and N3, then only I can access the elements. Whereas in case of list, we can access the element through indexing, but in linked list it's not possible. So you have to go traversally, right? Here traversal means that you have to go through each node. So if you want to access the elements of N3, then you have to start with N1, then you will go to N2, then you can go to N3. So that's why accessing the elements in linked list will be slower as compared to list. Now coming to the last point, here in linked list, utilization of memory will be more as compared to list. So let's start with the singly linked list. So I have already showed you the representation of linked list, which is same as the singly linked list. So in singly linked list, I'm having here a data and reference in a node. So let's suppose that this is my N1 node, this is my N2 node, and this is my N3 node. So as I told you that each node will contain data as well as reference. So I will give here data, let's suppose 10. In node 2 I will give as 20, and here I will give as 30. And each node is having an address. So let's suppose the address of this N1 node is 1000, it's having 1100, and it's having 1200. So this reference, or you can say that link or pointer, this will contain the address of the next node. So this will contain 1100. Similarly, this reference or this link will contain the address of N3 node. So I'll write here 1200. And here after N3 node, do you see any node? We are not having any node. So here this link or this reference will null. Now coming to here, what is head here? So head will contain the address of my first node, that is 1000. So in singly linked list, the traversal is done only in one direction. So what do you mean by traversal? Traversal means that you are going through each node. So let's suppose that if you want to go to the N3 node, first go to N1, then N2, then only you come to N3. You can't directly jump to N3. You have to go through N1 and N2, then only you come to N3. Now let's see some operations in singly linked list. So we are having several operations in linked list. We are having insertion, deletion, traversal. So insertion as well as deletion can be done at beginning, at any specified node, as well as end. Now coming to the traversal, I have already told you that traversal means you have to go through each node. So going through each node of the linked list is a traversal. Now let's see the pseudocode of singly linked list. So if you want to create a node in a singly linked list, then what should be the code here? So I will write first here class node. So here I have created a class whose name is node. So this class node will also be having an object, right? I will create object later on, but let's see. Let's suppose this is my n1 node. As I told you that a node will contain data as well as reference, right? So instead of reference, I'm writing here next. I'm taking a small word here so that it will be easy for coding. Now, so this is my node creation. Now, what I will do here, so in this class node, you have seen that I am creating a init method, or you can say a constructor. So to create it, first I will write a reserved word, that is def, and then I will write init method. So I will write first def and then underscore underscore init, and then I will write underscore underscore, then I will write self and then comma comma data. So why I have written here self, I will tell you later on. And I've also passed data as a parameter here. So inside this I have written self.data is equal to data and self.reference is equal to none. So why I have written this? Because my node will contain data as well as reference. So I will write here in this method self.data is equal to data and self.reference I have written here next, so I will take here next is equal to none. So when you are creating a node, let's say this is a node n1. So initially it will be having a data, and because I'm just creating a node, as of now I'm not linking this node, so the link, or you can say the reference, will be none, right? So this is my initial node. I have written here self.data is equal to data and self.next is equal to none, right? Now this is a class whose name is node. I can create the object. So how to create an object? I will write here n1 and then I will write here class name node, and inside this class I will pass the parameter 7. So here now what will happen? Instead of self, my object will pass here. So my n1 will pass here instead of self. So now it will be n1 dot data is equal to, and what's my data? Data is 7. Now the next step, we are having the self dot reference is equal to none, right? Let's see here, self dot next is equal to none. So instead of self, my n1 is there, so n1 will be passed here, and n1 dot next I will be having a none. So this is nothing but a creation of my node. Now if you want to check, then we can write print function, and when you will write here node1 data inside a print function, you will see that you are getting the value as 7. Similarly, if you are writing node1 dot reference inside a print method, then you will be getting none. So now this is the idea about how to create a node. Now let's see this into a coding. So I will be using here Jupyter notebooks. So I will go on here new, and then I will click on Python 3, and here you can see that I am getting a name untitled 21. Let me change it. I will write here linked list and I will write here Python. Now let's create a node. So I will comment it down, creating a node. So first I will create a class and I will give the name as node, and inside this class node I will create my init method. So I will write here def, which is a reserved word, and then I will write here init, but before that I will write underscore underscore, then again I will write underscore underscore, and then I will write here self comma data. So why I have written here self? So when I'm creating a class object that is n1, I've already showed you in the example. So instead of self, n1 is passed. So as we know that we can create a multiple object of a class. So if I'm writing here n2 or n3, then instead of self I can pass n2 and n3 also. So now let's create a node. So I will write here self dot data is equal to data, and I will write here self dot next, I will write here none. So this is my node creation. So whenever I am having a node, it will contain a data and it will be having a reference. So initially it is not linked, so the reference is none. So this is my class. Now I will create an object of node. So I'll write here n1 and I will write class name and I will pass data as, let's suppose, 8 value here. So if I'm executing it, so on executing, this n1 will go to the self and this 8 will go into the data. So my n1 dot data is equal to 8 and my n1 dot next is equal to none. Let me print it. So if I'm writing here print, and inside that, if I'm writing my n1 dot data, once again if I'm writing print function, and inside that if I'm writing n1 dot next, then you can see that I'm getting the data as 8 and the next, that is a reference, I'm getting as none because I didn't link this node to any other node. So this is the basic idea how to create a node. Now let's see how to create a class of singly linked list. So when will my singly linked list will be empty? So as I told you that if this is a node, let's suppose n1, this is another node n2. So n1 and n2 are connected with each other. So we are having a head pointer which always points to the first node, right? So if there is no head, if head is none, then my linked list will be empty. So now what I will do here, so I will create a class and I will give the class name as, let's say, singly linked list. And inside this class, once again, I will write init method. So I'll write here def underscore underscore init underscore, and I will write here self. Now here I will write self dot head is equal to none. So this is my condition to create a class. So if the head is pointing to none, that means it is not pointing to any node and it shows that linked list is empty. So now let's see the creation of singly linked list. Yeah, so let me remove this. Now I will create a class. So creating a linked list. So if I want to create a linked list, I will create a class of linked list. So I will write here class singly linked list. So this is my class, and inside this class I will once again write init method. Inside this singly linked list I will create a init method. So I will write def underscore underscore init underscore underscore, and then I will write here self. And when my linked list will be empty, so when self dot head is equal to none. So this is the simple way to create a singly linked list class. Now, so after creating a class, now let's create a object of this linked list. So I'll write here SLL singly linked list, this object name, and now I will write the class name. So class name is singly, and then capital LL is there, right? So on execution, always remember whenever you are creating an object and if you are executing it, so inside this class init method will always run. I will show you the example. If inside this init method, let's suppose if I'm writing here print Gaurav. So I've created the object here SLL, and right now if I'm executing, then you can see that Gaurav is executing here, right? So always remember whenever I'm creating an object of class and whenever I'm executing it, so whatever the statements are inside the init method, it will execute. So on execution, what will happen here? I will get here SLL dot head is equal to none, right? So SLL is my object. So instead of self, SLL will assign here. So SLL dot head is equal to none, right? So this is my basic concept of creating a node and creating a linked list. So after creating a node and then creating a class of singly linked list, now let's see the traversal in linked list. So what is traversal? As I already told you that traversal means going through each node. So now let's see when we can do the traversal in a linked list. So this is my singly linked list. So this is n1 node, this is n2 node, this is n3 node, and this is n4 node, and each node will contain a data as well as next, right? So this will contain a data next. Similarly, N3 and N4 will contain a data and next. So as of now, these nodes are not linked with each other. And if I want to do the traversal, then I have to go through each node. That is from N1, then I will go to N2, then N3, and then N4. So now let's see the case scenario. So the first case will be if self.head is none. So in that case, my linked list is empty, right? So when my linked list is empty, I can't do the traversal. So in this case, I will write here print linked list is empty if condition. This is if condition. And then I will write one more condition else, and inside else if my self.head is not none, then what I will do, see, as we know that head will be always pointing to the first node. So this is my head here. So I will create a temporary variable a is equal to self.head. Now if I want to traverse, then I have to develop a logic so that I can go from n1 to n2 to n3 to n4. So I will use a while loop. Let me write here, this was else, and inside that I'm writing a is equal to self dot head. Now I will write a while loop. So I'll write here while a is not none. I'll give a condition a is not none, because if my a is none and here a is self dot head, so if self dot head is none, then it's an empty linked list, so traversal can't be done. So inside this I will write a logic a is equal to a dot next. Now what is a dot next here? Let's suppose that this is a n1. If I'm writing here n1 dot next is equal to n2, so that means I am linking this node n1 node to n2. The link has been generated. Now if I'm writing here n2 dot next is equal to n3, then again the link has been generated, and this next will contain the address of n2. So let's suppose the address of n2 is 1200, so this next will contain 1200. Now if I'm writing here n3 dot next, so we know that this is next here, right? So n3 dot next will be n4. So you can see that I am writing here a is equal to a dot next inside a while condition. So initially this will be my a, the loop will run, and my a will shift to n2. Similarly my a will be is equal to n3, then similarly my a is equal to n4. So in this way the traversing will be done. So I have given you the basic idea. Now let's see the coding to understand in a better way. So let's see the coding of traversal in linked list. So let me write here in comment traversal in linked list. So first I will create a class of a node, and I will give the name as node, and inside that I will create my init method. So I'll write def underscore underscore init underscore underscore and then self, and I will write data also, because I will pass the data element value. So I'll write here self dot data is equal to data, and then I will write here self dot next is equal to none. So this is my node in which I'm having a data, and I'm having my reference or link, you can say that, as none. Now after creating my node, I'll create a class of singly linked list. So this is a class of my singly linked list, and inside this class once again I will create a init method. Now so as I know that my singly linked list will be empty when my head is pointing to none. So if head is pointing to none, then linked list is empty, so you can't traverse, right? Because traversal can't be possible in the empty linked list. So this is my linked list. So inside this linked list, first I'm giving the condition self dot head is equal to none. Now inside this same class SLL, what I will do, I will create a function def, and I will write here traversal, and then I will write here self. Now I will give the condition. So the first condition is that if your linked list is empty, so when your linked list will be empty when self dot head is none, then you can't do the traversing. So I'll write here if self.head is none, I'll write print singly linked list is empty. And I give the another condition else. So the first condition was that if self.head is none, the linked list is empty. Now coming to the next condition, when my self.head is pointing to the first node, then only I can do the traversal, right? So I will create a temporary variable where a is equal to self.head. So why I'm creating a temporary variable a? Because I want my head value to be fixed. I don't want to change my head value, but I'm using while loop here. So a value will be changed. So that's why I've created a temporary variable in which I have assigned self.head so that head value is not changed. Now after this, what I will do, I will write here while a is not none, I'll write simple print a dot data, and then I will write here end is equal to, then I will write quotes and I will give a space so that whatever the data elements are printing, there is a space between them. And then after that, I will write my logic a is equal to a dot next. So a dot next, why I'm writing here, to connect one node with to the another. So this is my main logic that I have written inside a traversal function. Now let's see how to execute this program. So first I will create a node. So let me write here n1 is equal to node, and let me insert the values 5. So I'll create 4 nodes in this. So I'll write here n2 is equal to node. I'll give the data element value 10 here n2 node, and n3 I'll give the value as 15, and I will give the value for n4, let's say 20. So these are the nodes, right? After creating node, what I will do here, since this is a SLL class, so I have to create the object of this also. So I'll create an object here. So let me create the object. I'll create here SLL is equal to SLL. So just write any variable name. So I have written here small SLL, then I have written equal to, then I have written the class name capital S small l, then I have written open and close parenthesis, right? So this is a way of creating a object of SLL class. So as soon as I've created this SLL object, this init method will run automatically, right? So my SLL dot head is equal to none initially. Now what I will do here, after this I will write here SLL dot head, and I will assign to n1. Now I have to connect the node. So what I will do here, once I've created n2 node, so for connecting I will write here n1 dot next is equal to n2. Similarly, after creating n3 node, I will write here n2 dot next is equal to n3. And after creating n4 node, I will write here n3 dot next is equal to n4. Now what I will do here, I want to call this function. So how to call this function? So what's the object of this class? This is, right, small SLL. So I will write here SLL dot, what's the function name, traversal. So I will write here traversal. So now what will happen here, once you are calling this function, so instead of self, this object will go, SLL will go here, right? Now let's execute this, and then I will explain you the logic how this is working. So on execution, you can see that SLL.head is equal to n1. So here n1 is not defined, yeah, because once I have to create n1, after that I have to assign it, right? So let me write here control X and then control V. Now if I'm running it, you can see that I am getting 5, 10, 15, 20, right? Because here first I have assigned SLL.head is equal to n1. So here what was the mistake? I didn't create the n1 node first, and I have assigned the SLL.head is equal to n1. So first you have to create the node, then only you can assign, right? Now let's understand the logic. So here n1 is the object of class node, right? So n1 is equal to node 5, and 5 is the here data element value. So when I'm writing this, so what I will get here, so instead of self n1 will pass, and instead of data 5 will pass. So I will get here n1 dot data is equal to 5, and I will get here n1 dot next is equal to none. So after this, I've created the object of my singly linked list. So what will happen, as soon as I'm creating the object, this init method will run. So instead of self, SLL will pass. So I'll be getting here SLL dot head is equal to none. So as of now, you can see that my SLL dot head is equal to none. So still my list is empty, right? So I have to assign this SLL dot head to n1 so that my head is pointing to n1. So here I have written SLL dot head is equal to n1. So now my head is pointing to n1. Now after that, once again I have created the node n2. So what will happen here? I will get here n2 dot data is equal to 10. Let me write comma here. And n2 dot next I will be getting as none. Now, as soon as I've created my n2 node, what I will do, I will connect n1 node with n2. So I've written here n1 dot next is equal to n2. So initially my n1 dot next is equal to none, but now my n1 dot next is equal to n2. So as of now, I've created the node n1 and n2, and the head is pointing to n1, and I've also linked the n1 node with n2. Similarly, once again, I'm creating an n3 node. So n3 dot data, n3 dot data is equal to 15. And after that, n3 dot next is equal to none. Now after creating this, what will happen? Once I've created my n3 node, then I will connect n2 with n3. So I've written here n2 dot next is equal to n3. Similarly, once again I will create my n4 node. So again the same logic will perform. N4 is equal to node 20. So again I've written here n4. So n4 is my object of class node, and n4 will passed into self, and my data will be 20. So let me write here n4 dot data is equal to 20, and the same thing n4 dot next is equal to none. So after creating n4, now I will connect n3 to n4, right? So I'm having only 4 node here. You can see that I've created n1, n2, n3 and n4. So after n4, I don't have any node. So what will be n4 dot next is equal to none. So that's why I didn't write anything after this. So now it's time for calling this function. So how to call this function? So I have already created the object of SLL class. So the object was a small SLL. So I write small SLL dot traversal, which is the name of this function. So inside this self, SLL will pass here, right? So what will happen here? SLL dot head. So SLL dot head is what? Initially SLL dot head is equal to none, but I have assigned here SLL dot head is equal to n1, right? So this is not none. So it will jump into this condition. So now what will happen here? Let's see the logic. So here a is equal to self dot head. And what's my self dot head? My self dot head is SLL dot head. So my a is equal to SLL dot head. So now after this I have created a while loop. So here I will write here while, and then instead of a I will write SLL dot head is not none. So after this what will happen? This is my while loop. So here I have written while a is not none. So my a value is SLL dot head. So is my SLL dot head is none? No. Why? Because my SLL dot head is pointing to n1. You can see that my SLL dot head is pointing to n1. So it's not none, right? So what will happen here? Initially my a is, let me write here, a is SLL dot head. So now it will print me the value a dot data. So what is a dot data? So SLL dot head is nothing but pointing to n1. So I will write here n1. So a dot data is nothing but it's equal to n1 dot data. And what's n1 dot data? N1 dot data is 5. So it will print 5, right? So you can see that I'm getting 5 as the output. Now if you see here, a is equal to a dot next. So what is my a? A is nothing but my n1, right? So I'm writing here n1 dot next. So here you can see that I'm getting a is equal to n1 dot next. So again it's a while loop, right? So once again it will jump here. Now a value is equal to n1 dot next. So n1 dot next is pointing to none. No, n1 dot next is pointing to n2. So it's not none. So this condition is still satisfying, right? And once again it will print the data. That is, here the a value will be n1 dot next. So now once again if I am moving to the print statement, so a dot data. So let me write here a dot data. So what will be the a dot data? This time n1 dot next. So what is n1 dot next? N1 dot next is nothing but n2, right? So n2 dot data it will give. So n2 dot data is what? N2 dot data I am getting as 10, right? So it will print 10. Similarly, once again you can see that my a is equal to, I will be getting here a is equal to n2 dot next. So once again it's going n2 dot next. So n2 dot next is containing the address of n3, so it's not none. So once again it will print here n2 dot next dot data. So what is n2 dot next? N2 dot next is nothing but n3. So n3 dot data will give me 15, right? Now what will be a? A is equal to a dot next. So my a value is here n3. So n3 dot next, right? So my a value will be here n3 dot next. So once again it will go here. So a is equal to n3 dot next. So n3 dot next is none. No, it's again pointing to n4. That means n3 dot next contains the address of n4, right? So it's not none. So a is equal to n3 dot next. So what is n3 dot next? So n3 dot next is nothing but n4. So n4 dot data will give me 20, right? So after giving me 20, once again I am getting here n4. Now what will happen here? A is equal to a dot next, and my a value is n4, right? So a is equal to n4 dot next. So if I'm getting here n4 dot next, so what is n4 dot next? N4 dot next, I'm getting here none, right? So yeah, this condition is not satisfying, and hence the loop will end, because n4 dot next is equal to none, and my condition is while a is not none. So this is the basic logic. So in this way we'll get the values 5, 10, 15, 20, and the traversal will be done in linked list. Now after traversal, we will see the insertion in singly linked list. So insertion can be done in three ways. We can do the insertion at the beginning of the node. We can also do the insertion at the end of the node, and we can do the insertion at a specified node. Now let's see the insertion first at the beginning. So in the previous coding example, I was having 4 nodes. So let me write here the name of node n1, n2, n3, and n4. And I've also shown you the traversal in linked list. So here I've assigned the data as 5, 10, 15, and 20, right? And this n1 was connected to n2. Similarly, n2 was connected to n3, n3 to n4. So we have seen the traversal like this. Head was pointing to my n1 node, right? So this is nothing but my link. So link will contain the address of this n2 node. Similarly, this is again the link of n2 node. So this will contain the address of n3 node. So up to here we have seen, right? Now I will insert a node at beginning. So let me create a node nb. So how I will create a new node? I will write here nb is equal to node, and I'll write here data. So nb is nothing but it is an object of a class node, right? So here instead of data, if I'm passing 2, so my data will be here 2, and this next value, or you can say the reference, will be none. Right now I didn't link this nb node to anyone. So this is my nb node here, and let's suppose the data is here 2 and it's not connected, so initially it will be none. Now I have to find the link between nb node to n1, right? So what will be the step? nb dot next is equal to self dot head. So this is a simple logic. So when I'm writing nb dot next is equal to self dot head, that means I'm creating a link from nb dot next, because this is my next, right? And I'm creating a link from nb to n1. Now if I'm creating a nb node, then this is my first node. So you can see here nb is now my first node. So head must point to nb, right? Because head will point to the first node. So here I have to remove this head and point to here. So for that, which logic should I write? I will write here self dot head is equal to NB. So now my head will be pointing to this NB. So let me remove this. So I will write here. Now let's see it in coding. So this is my traversal code. So what I will do here, inside this class singly linked list, I will create one more function, and let me create the function, and I will give the function name, let's suppose def, and the function name insert at the beginning. So I will write here insert at beginning. So I have to insert here. So which parameter shall I give here? I have to write self first. So after self, I have to give data, because I want to put the data value inside a node. So inside this function, I will first create a node. So nb is equal to node. nb is equal to node, and then inside this node, I will write here data. Now, after this, I will perform my logic. So what my logic is? My logic is nb.next is equal to self.head. So nb.next is equal to self.head will create a link between nb and n1 node. And after that, I want to change my head from n1 to nb. So I'll write here self.head is equal to nb. So this is my function. So how to call a function? So here you can see that this is a class SLL. So the object of this class is SLL. So I can call it through. I'll write here SLL dot, and after that I will write here insert at beginning, and let me put the value here 2. So I will call this function, and instead of data I have given the value as 2. So all the statements inside this function will execute. Now I want to print this function, right? So here you can see that the traversal logic is written here. So I'll write here SLL dot traversal, and now if I'm executing it, so you can see that I'm getting my output. But let me write here print. So if I'm writing here print, then I will get my output in the next line, right? Because here inside this print I didn't write anything, so it will give a space. So now if you see, I'm getting 2, 5, 10, 15, 20. So the NB node was having a data element as 2, right? Here you can see that my NB node has been inserted. So this is my first node. So the new linked list will be having the elements 2, 5, 10, 15, 20. Now let's understand the logic, how this thing is working. So here I have given the data as 2. So data is equal to 2 here. And now after this, NB is equal to node. Instead of data 2 will be here. So now if you see this is my object of NB, right? And this is a class. So here what I will get here, I will be getting here, let me write comma, I will be getting here NB dot data is equal to, what's the data value? 2. And now I will getting here NB dot next is equal to none. So this is the creation of a node which is having a data element as 2, and its next, that is the reference, is none. So this means this node is not connected with any other node. Now I have to connect this node. So I have written the logic here nb dot next. So here you can see that nb dot next is equal to self dot head. So what is my self? Self is nothing but I am calling through the object SLL, right? So instead of self, it will be SLL. So SLL dot head is what? SLL dot head is my N1. Here you can see that. So it will be N1. So here SLL dot head is nothing but my N1. Now what will happen here? NB dot next, and this is the N1 node. So I have created a link between these two nodes. So NB and N1 node are now connected. Now after connection, I have to change my head position. So initially my head position was assigning to N1, but I have to change it. So how to change it? So here instead of self, my SLL will be here. So SLL dot head is equal to NB. So you can see that I have changed my head position. So this is the basic logic for the insertion at the beginning. So what I've done here, I've created a node, then I connected the NB node with N1, and then I've changed the head position from N1 to NB. This is the basic logic for insertion at beginning. Now we'll see the logic of insertion at end. So this was my node. Initially I was having 4 nodes, n1, n2, n3 and n4. But I've created a new node, right? Insertion at beginning. So this will be my head, and it was containing a data as 2, and the link of this nb node contains the address of n1 node. So n1 node data was 5, here 10, for n3 it was 15 and 20, and n1 was connected to n2, n2 was n3, n3 to n4, and here next value was none. So this is the singly linked list up to insertion at the beginning. Now we will see the insertion at end. So for the end insertion, I have to create a node. So let me give the node name here any, and once again this node will contain a data as well as next, or you can say the link, but this is the last node, insertion at last, so this will contain the value as none. So initially when you are creating any node, then its link is pointing to none. So this is the any node, and here the link is pointing to none, but this is the last node, so I want the link to be none itself, right? Now I'll give the data here. So let me write here any is equal to node and then data. So this is my basic creation of node. Now what I will do, I want to create a link of this any node with n4, right? So this is my any node, and I have to connect any with n4. So as we know that in linked list you have to go through each node. That means you have to do the traversal, right? You can't directly jump to any. You have to first start from nb, then n1, n2, n3, n4, and then you can go to any. You can't directly jump. So now what will happen? We know that we have to go from nb to n1, n1 to n2, n2 to n3, and n3 to n4, and then we can come to n4 to any. So we have to develop a logic. So this is my head. My head is pointing to nb, so I don't want to change my head. So I'll create a temporary variable, a is equal to self.head. Now you might have a doubt that why I'm creating a temporary variable, because I will use this temporary variable in a while loop, so that if I'm using a while loop, then the value of a will be changed, right? So that's why I've created this temporary variable, so that my head is fixed. Now I'll create a while loop. I will write here while a dot next is not none. So here I will give a condition while a dot next is not none. So why I'm giving this condition? Because here you can see that inside this while loop I will write here a is equal to a dot next. So what will happen here? My a is equal to this one, self dot head. Initially my a is here, right? And here it will check a dot next is not none. So this is my a, right? So a dot next is pointing to n1. So is it none? No, it's not none. Why? Because a dot next will contain the address of n1, right? So here it will execute the statement inside this while loop, and I am having the statement a equal to a dot next. So my a value will be here. So my new a value will be here at n1 node. Similarly, once again this while loop will work, and again a dot next. So a dot next is pointing to n2. So it is none? No, it's not none. So once again a is equal to a dot next. So my a value will be coming here. Similarly, once again this loop will work, and my a value will shift here, here. So up to n4 my a value be here. Now I have to create a link between n4 and any. So how can I create a link? I can simply write here a dot next is equal to any. So if I'm writing a dot next is equal to any, so this none will be removed, and I will create a link from n4 to any node. So this is my logic here, and here this a dot next is equal to any is not inside this while loop. It is outside the while loop, right? So indentation is here up to a equal to a dot next. This is outside this while loop. Now let's see the coding part. So I've zoomed it so that you can see it clearly. Now after insertion at beginning, I will create a function inside the class node itself. I'll write here def, and I'll write here insertion or insert at end. So insert at end, and once again I will write here self comma data. So now if I want to insert the element at end also, then I have to create a node. So let me write here node any is equal to node, and then I will write here data. Now after creating a node, I want to traverse, because this is my last node. So if I want to reach to the last node, I have to go through the each node. So that's why I will create a temporary variable here a is equal to self dot head. So once I'm creating a temporary variable, I'll create a loop. So I'll write here while. So while a dot next is not none, then a is equal to a dot next. And now after this, I will simply assign a dot next is equal to NE. So this is the connection of my last node, that is N4 node, to NE, right? And here I have created this while loop so that I can go through each node. Now let me print out this. So what I will do now, I will simply write here SLL dot insert at end, and let's take the value as 25 at end. And now I will display. So I'll write simple here SLL dot traversal. So let me do the execution here, and on execution I'm getting the output, but it's confusing, so I'll write here once again print, so that I can get space between the outputs. So here you can see that I've inserted a node which is having a data element as 25 and which is inserted at the end. So this is the execution part. Now let's understand the logic, how this thing is working exactly. So here I've given the data as 25. So data is equal to 25 here. Now what will be here? Any. If you see here, then my any dot data is equal to 25, and here my any dot next is equal to none, right? So this is my creation of a node. Now after this, what will happen here? So here you can see that a is equal to self dot head. So instead of self, SLL will pass, right? So SLL dot head. Why SLL will be passed here? Because I am calling this function with my object SLL, right? So SLL dot insert at end. So instead of self, SLL will pass here. So here SLL dot head was my NB, right? So it will assign to NB. So as we know that NB was my first node, so head will be the pointing to NB itself. Up to this was the logic. Now coming to here you can see that a dot next. So what is a dot next? So here a dot next is equal to NB dot next. Why? Because my a value is NB. So NB dot next is my none. No, it's not none, because NB dot next contains the address of N1. So that means it's not none. So once again inside this loop, what will happen? My a will assign to a dot next, that is NB dot next. Now you might have a doubt, what is NB dot next? NB dot is next is nothing but N1, right? Here you can see that. So NB dot next is equal to N1. That means my NB is connected to N1. Similarly, once again, what will happen here? This is a loop. Once again, it will go here. So if you see here, a dot next. So what is a dot next? My a is equal to N1 now. So I will be getting here N1 dot next. Right. So once again, a is equal to N1 dot next. So what is N1 dot next? So my a value will be here N2, because N1 dot next is N2, right? So once again it will go N2 dot next. So N2 dot next is nothing but N3. So inside this, once again a value will be assigned is N3. Then once again N3 dot next will go. So in this way you can see that we are going through each node and we are connecting them. Now what will happen here? Once I reach to N4, right? So I have to create a link from N4 to NE. So I will write here N4 dot next is equal to NE, right? So if here you see, this is my while loop. So inside this, at last what I will be getting here, I'll getting here N4 dot next. Because N4 dot next is none, right? So this loop will end. If you see here, you can see that N4 dot next is none. So my loop will end here. And what is my a dot next value? So instead of a, I was getting N4. So N4 dot next was my none, but I have assigned here N4 dot next to NE. right? So that means now n4 is connected to any. Now what will be the any dot next? It's none, because this is last node. So here you can see that while creating the node itself, I got any dot next is equal to none. So this is my basic logic of insertion at end. So we have seen the insertion at the beginning of the node. We have also seen the insertion at the end of the node. Now we will see the insertion in between. So that means we will see the insertion at any specified node. So initially I was having 4 nodes, n1, n2, n3 and n4. Then I've done the insertion at beginning. So this was my node nb, and then I've done the insertion at end. So this was my node ne. And these were the 4 nodes n1, n2, n3, n4. And we were having the data, right? 5, 10, 15, 20 and 25 for any. And for this we were having the data as 2. Right. Now what I will do, I have to insert the node at a specified position. So the process will be the same. I have to create the node first. So for creating node, what I will do here, let's suppose this is my nb node. So initially I'll create a node nb is equal to node data. So when I'm creating a node, then this will contain a data and this next will contain none. So let's suppose that these are the positions. Let me give the position at 1, 2, 3, 4, 5, 6. So let's suppose that at position 3, I want to insert this NB node. That means in this position. So initially if you see this linked list is connected like this, right? NB is connected to N1, N1 is connected to N2, N2 to N3, N3 to N4, N4 to NE, and NE is connected to none, right? Because we don't have any node after NE. And initially my head will be pointing to my first node, that is NB. Now what will happen here? So let's say at position 3 I want to insert my node. So what will happen here? So this will be my position 3, and after that this will be my position 4, 5, 6, 7, right? So what will happen here, as we know that our head will be always pointing to the first node. So I will create a temporary variable a is equal to self.head. Now you might have a question that why I'm creating a temporary variable a, because I will be using this temporary variable in a loop. So in a loop I will do the iteration, so a value will be changed, but I don't want to change my a value, right? And a value is self.head because head will be fixed. So that's why I've created a temporary variable here, a is equal to self.head. Now what I will do, I will create a loop. Which loop? For loop. So let's suppose that if you want to insert this NB node at position 3, then in a linked list you have to go through each node, right? So first you have to go to position 1, position 2, then only you can come to position 3. So that's why I'm using here for loop. So I'll write here for I in range, and then I will give the value here 1 and position. Then I will give the value here 1 and position -1. Now you might have a doubt, why I'm giving here position -1. So see, this is my node, right? 1, 2, 3. I want to insert this node at third position. So I have to traverse here from 1 and then 2. Then only I can go to 3. That's why I've written here position -1. So let me correct here. It will be position -1. So here you can see that my position is 3. So I will write here for I in range. Range starts from 1. And what is position -1? 3 minus 1 will be 2. So as I know that if I'm writing here for I in range 1, 2, then this 2 will be excluded. So that means for I is equal to 1, my iteration will be done, right? So here, what do you mean by a equal to a dot next? My a is equal to self dot head. So if I'm doing here a dot next, that means my temporary variable a is now shifting to here n1 node, right? A dot next is nothing but it will contain the address of n1 node. So this will be my new a. So you can see that through iteration, the a value was moving from NB to N1, right? And after N1, I want to connect this NB node, right? So after this loop, what I will do, this is my NB. So initially my NB dot next is none, right? When you will create a node, then we will assign the data, right? NB dot data is equal to data and NB dot next is equal to none. So I want to connect this NB dot next with this N2. So I have to write a logic. So what I will write here, I'll write here NB dot next is equal to, I will write here a dot next, because my a value is assigning to n1, right? So if I'm writing a dot next, then a dot next will contain the address of n2, right? So that's why I've written here nb dot next is equal to a dot next. So that means nb dot next will contain the address of n2, right? And after that I have to link this node also. So for linking this node, I will write here a.next is equal to, what's the name of this node? NB. So if you see here, what will happen here? Let me remove this. So this connection, so when I'm writing here nb.next is equal to a.next. So this is my nb.next. So nb.next will be connecting to this n2, right? And here I've written a.next is equal to nb. So a.next will connect here, right? So in this way, we can insert a node at any specified position. Now let's see the coding example so that we can understand in a better way. Yeah, so this was our program, and here we have already done the insertion at beginning and insertion at end. So once again, I will create a function, and for creating a function, I will write def, and then function name, let's suppose I will write here insert at a specified node. I'm writing this large name so that you can understand easily. Or else you can also give the shorter name too. So insert at a specified node. So first I'll write here self, and what are the parameter I have to pass here? I have to give the position for this and then data. So if I want to insert a node at any specified position, then again I have to create the nodes. So I will create here nib. So node in between, I've given the name nib shortcut. So I will write here node and then data. So I've created my node in which node.data is equal to data, and then node.next is equal to none. So I will give the data value, then data value will be assigned here. So what will happen here? After that, once again I will create a temporary variable a is equal to self.head, and then I will create a loop for I in range 1 comma position -1, and after this I will write here a is equal to a dot next. This is a logic for traversing through each node. So if I'm giving here position 3, then I will go through the n1 node, then n2 node, then only I can reach to the n3 node, right? So after traversing from the n1 node, n2 node, I'm having n3 node, so I have to connect it, right? So how to connect that n3 node? So for connection, I will write here nib dot next is equal to a dot next. So that means at position 3, if I've created nib node, so nb node was there, n1 node was there, nib node is there. So that means I am connecting nib dot next is equal to n2, right? Now what I will do, I have to connect nib node with n1 also. So I'll write here logic a dot next is equal to nib. So a dot next is what? My n1 node, which will contain the address of nib node. So this is my logic. Now if I want to call this function, let me again copy and paste this. What's the name of the function? Insert at specified node. So I will write here insert at specified node, and then I've given here position and then data. So I will here pass the position at 3 position. I want to insert a node, and let's say data is 7. And once again I'm calling it through SLL dot traversal. So if I'm executing it, then you can see that I'm getting the output. So for getting the output in the next line, let me write here print. So you can clearly see in the output that at position 3, a new node has been inserted whose data is 7. So now let's understand the logic. So the logic is simple here. Here my position was 3, right? So let me write here position 3 and my data was 7. So when I'm creating here nib is equal to node data, so what will happen here? Once again here nib dot data will be equal to 7, and here nib dot next is equal to none. So after creating the node, here a is equal to self dot head. So a is equal to self dot head. So instead of self, my SLL will be there, right? Here you can see that I am passing SLL. So instead of self, SLL will be passed. So SLL dot head is what? SLL dot head is nothing but it's NB. So SLL dot head is equal to NB. So my head is pointing to the first node, that is NB. Now coming to the loop logic, here you can see that position is 3. So 3 minus 1 will be 2. So if I in range 1 comma 2 is there, then for I is equal to 1 only, this loop will run. So I is equal to 1 here. What will be the A dot next? A is equal to A dot next. So what is my A here? A is nothing but NB. So NB dot next. Right. So NB dot next is what? NB dot next is nothing but it's N1. So here if I am writing here NIB dot next is equal to A dot next. So what is my A dot next? A dot next is N1 dot next. So you can clearly see that NIB dot next is N1 dot next. And what is N1 dot next? N1 dot next is nothing but N2, right? So you can see that I've created the node and initially NIB dot next was none, but here NIB dot next is N2. So that means the node I've created at a specified position I've connected to the N2 node. Now after this, once again A dot next. So what will be A dot next? A dot next is equal to NIB. And what was my A? A was my N1, right? So N1 dot next will be NIB. It's simple. So what is my A dot next? A dot next is N1 dot next. And now here you can see that I am assigning NIB into A dot next. So here N1 dot next is equal to NIB. That means NIB is assigned to N1 dot next. So here you can see that with these two logic, the node I have created, that is NIB node, I have done the connection with N1 and N2. So this is the basic program of insertion in single linked list. So now after seeing the insertion operation, now let's jump into the deletion operation. So even deletion operation will be of three types. We will see the deletion at beginning, deletion at end, and we can also delete a particular node at any specified position. So now let's see deletion at beginning. So I was having a node here NB, and then I was having N1, and at position 3 I've inserted a new node, right, NIB. Then I was having a N2, N3 and N4, and at last I was having a any node. So if you see, now I'm having a total 7 node, 1 2 3 4 5 6 7, right? So now NB is connected to N1, N1 is connected to NIB. So what does that mean that NB is connected to N1? So that means the link, or you can say the reference of NB will contain the address of N1. Similarly, NIB is connected to N2, N2 to N3, N3 to N4, N4 to NE. So the link of NE will be none because it is not connected to any other node. So initially my head will be pointing to right, and let me write the data here. So NB I was having a data 2, N1 I was having 5, NIB 7, N2 10, 15, 20 and 25. Now in deletion, what I have to do, I have to delete the first node at the beginning. So what will be the logic? If I want to delete this node, then my head will shift here, right? So let me create the logic. So initially what I will do, I'll write here A is equal to self dot head. So I have created a temporary variable A, and inside that I have assigned self dot head. Now after creating a temporary variable A is equal to self dot head, what will happen here? Since I will delete this node, so I want that my head must be pointing to N1, right? So what will be the logic? So I will write here self dot head, and I will assign here A dot next. So my A is equal to self dot head, right? This is my A initially. So A dot next will be N1, right? So I have written here self dot head is equal to A dot next. That means self dot head is equal to N1. So now my head will be shifted from NB to N1. So let me remove this head. So my head will be here. So this is my head. Now since I want to delete this NB node, so since I have to delete this NB node, so I want to disconnect this link from NB to N1. So how to disconnect this link? So what will I will write here? I will write here A dot next is equal to none. So this is my A. So if I'm writing here A dot next is equal to none, that means that NB is not connected to N1, right? So let me remove this link. So I will remove this link. So once this link has been removed, that means this node has been deleted. So this is the basic simple program for the deletion at the beginning. Initially you have to create a temporary variable in which you are assigning self dot head. Now I will change my self dot head. So I'll write here self dot head is equal to A dot next, and then I have to disconnect the link. So for that I will write A dot next is equal to none. That means NB dot next is none. So a dot next is equal to none means it doesn't contain the address of the next node. So now let's see the coding example. So this was my coding part. So I will create a function. So I will write here def and let me write the function name at deletion at the beginning. Deletion at beginning. And inside that I will write here self. So what will be the logic? So first I will create a temporary variable. I will write here a is equal to self.head. As we know that we gonna delete the first node, so my head will be changed. So I'll write here self.head is equal to a.next. So that means now my head will be changed. Now after that I have to disconnect the link. So for that I will write here a.next is equal to none. And let me call this function. So I will copy this thing, Control C, and let me Control V, and then I will also copy this. So deletion at beginning is the function name. So how to call a function? I will write here SLL. So this is the object of a class SLL.deletion at the beginning. And now if I am running it, then you can see that I am getting the output. But let me write here once again print so that I can see the output in the next line. So now you can see that the new singly linked list is from 5, 7, 10, 15, 20, 25. So that means my NB node that I was created has been deleted, right? So this is the basic logic for deletion at the beginning. So we have seen the deletion at the beginning. Now we'll see the deletion at end. So let me first create my linked list. So we have done the deletion at beginning. So now my new singly linked list will start from N1. So my singly linked list will start from N1, then NIB, then I was having N2, then N3, N4, and then at last I was having NE. So N1 I was having the value as 5, NIB I was having the value as 7, here 10, 15, 20, and then 25, and NE dot next was none. So let me connect all these nodes. So now as we know that head will be always pointing to this N1. So this is my singly linked list. Now what will happen here? I want to delete this node. So how to delete this node? So in a linked list, if you want to delete any node, then you have to go through each node. You can't directly jump to the last node. So once again, I have to go from N1, NIB, N2, N3, N4, and at last NE. Then only I can delete it. So now let's see the logic here. So now coming to the logic here, you can see that I have created here two variables. Now you might have a doubt that why I have created two variables. I will tell you the logic. So here I have written here previous is equal to self.head. So previous is nothing but it is assigning to N1 and this is my head. So I'll write here previous. And I have created here a is equal to self.head.next. So what is a equal to self.head.next? Self.head is nothing but it's previous, right? And previous.next is NIB. So this is my a. Now what I will do, I will create a loop and write here inside this loop while a.next is not none. Then I will write here a is equal to a.next and previous equal to previous.next. Now you will see the logic here. So is a.next, this is my a.next. Is it none? No, it's not none. A.next contains the address of N2. So what will happen here? A is equal to a.next and previous equal to previous.next. So my new a will be this and then previous will be this. Similarly, once again, this is a while loop. So once again a.next is not none. So it will see, oh, a.next is not none. So once again the a will be here and then previous will be here. Once again the loop will run. It will see a.next is not none. Once again the a value will be changed here and then previous will be here. Similarly it will see here a.next is not none. So a will be here at any node and here previous will be here. Now it will check a.next is none. So this while loop will be end. So here you can see that my a is here at the last node and my previous is at the N4 node. Now what I will do here, I have to delete the last node. So I have to disconnect this link, right? So this is my previous. So if I'm writing here previous dot next is equal to none. So my link has been disconnected, and hence this is a deletion of the last node, and that's what we want. Because if you see here, any dot next is already none, and if I disconnect this link, then I've already deleted this node. So this is the basic logic. So here I've done nothing, but I have just created a two variable, and then I have used the while loop. So this is the basic logic of the deletion at the end position. Now let's see the coding part of it. Now what I will do here, I will once again create a function. So I will write here def, and I will write here deletion at end, and I will write here self. Now initially I will write my previous is equal to self dot head, and then I will write here a is equal to self dot head dot next. Then I will create a while loop. So I will write here while a dot next is not none. Then I will change the value. So I will write here a is equal to a dot next, and previous is equal to previous dot next. And once I've done the traversal through each node, so what I will do here, I will write here previous dot next is equal to none. So if I'm writing here previous dot next is equal to none, so that means the link was disconnected from the last node. Now let me execute this. So let me copy and paste, and I have to call it. So I'll write here sll dot deletion at end. So this is a program and on running. So on executing, you can see that I'm getting the error. So why I'm getting here? Because I have to write here self. So now if I'm executing it, you can see that I'm getting the output. Once again I have to write here print. So here you can see that the last node has been deleted. So if you want to understand the logic for deletion and end, then follow the similar approach that I have showed you earlier here, right? So now we will see the deletion of a particular node at any specified position. So after deleting the node at beginning as well as end, we will see how to delete a node at a specified position. So the singly linked list that I'm having as of now looks like this. This is my n1, then after n1 I am having nib, then n2 and n3 and n4. So n1 is connected to nib, that means the link or the reference of n1 will contain the address of nib to n2, n2 to n3, n3 to n4. So after n4 we don't have any other node, so n4 link will contain the address none. So in n1 I am having the data element as 5, nib as 7, then 10, and here I'm having 15, here I'm having 20. And if I want to delete, let's suppose n2 node, so this is my position 3, right? So let me write the position 1, 2, 3, 4 and 5. This is the position 3. So at position 3 I want to delete this n2 node. So what I will do here, once again this is my head. So as usual, this is my head. So I have created a variable previous in which I have assigned self.head. Then I have created one more variable like the last time. A is equal to self.head.next. So self.head is here previous, right? So self.head.next will be assigning to nib. So this will be A, right? So previous is equal to self.head. This is my head, and A will be self.head.next. So now I want to delete this node. So I will be using this time for loop. So I will write here for I in range and then 1 comma position minus 1. So let's suppose that if I want to delete the node at position 3, so what will be happening here? 1 and then 3 minus 1, I will be getting 2. So 2 will be excluded. So iteration will be done only for I is equal to 1. So for I is equal to 1, A is equal to A dot next and previous is equal to previous dot next. So what does that mean? That means simple. Iteration I is equal to 1. My A value will be here now and my previous will be here. Right. Now let's see this logic. So I have written here previous dot next is equal to A dot next. So this is my previous now. So if I'm writing here previous dot next is equal to a dot next. So if you see, this is the previous dot next and this is the a dot next. So that means I am connecting previous dot next with n3, right? And after that I have written a dot next is equal to none. So this is my a dot next. So I have disconnected this link. So you can see that this node has been deleted. So this is the basic logic, just simple. I have done the iteration using for loop, and then after that I have written previous dot next. So this is the previous dot next, which is equal to a dot next. So in previous dot next, now I'm assigning the value a dot next, that is the n3 value. So that means here this link has been disconnected. Now I want to disconnect this link, so I'll write here a dot next is equal to none. Now let's see in the coding part. So let me create the function. I will write here def deletion at particular node. So I will give the function name here deletion at particular node. So here I'll give one more parameter other than self. I'll give here position because I want to delete a node at particular position. So I'll write here position, and inside this I'll write once again previous is equal to self dot head, and then I will write here a is equal to self dot head dot next. Now I will create a loop for I in range 1 comma position -1, and inside this loop I will write here a is equal to a dot next and previous is equal to previous dot next. Now after this, what I will do here, I will write here previous dot next is equal to a dot next. So after writing this logic, there will be a disconnection of the link, and then I will write here a dot next is equal to none. Now let me call this function. So I will write here, let me copy and paste this. And what's the name of this function? Deletion at particular node. At particular node. And let's suppose that position 3 I want to delete. So I will write here 3. So you will see the data element 10 will be removed from here. So now if I'm running it, again I have to write print to get the output in the next line. So if I'm running it, you can see that the 10 data element has been removed because the node has been deleted. So we have seen here the insertion at beginning, end at particular node, same for the deletion, and we have also seen the traversal. So this was all about singly linked list. So now we will be seeing doubly linked list concept. So what is the difference between singly linked list and doubly linked list? So here let's see the node of doubly linked list. So in doubly linked list we are having 2 pointers. So this pointer will contain the address of the previous node, and the another pointer will contain the address of next node. And here this node will contain a data. So let me give the node name as n1, right? So this is the way to create a node in doubly linked list. Now doubly linked list is a collection of nodes in which each node contains a data field and having 2 pointers. As I already explained you that we are having 2 pointers and data field. So one pointer is for previous node and other for the next node. Again, the difference between singly linked list and doubly linked list is that in singly linked list we can traverse only in the forward direction, whereas in doubly linked list we can traverse forward direction as well as backward direction. So here let me create the node. So these are the 3 nodes. Let's suppose I will give the name here n1, here as n2, here is n3. Okay, so n1, n2, n3 are the node. So this will contain the address of previous node, right? So do we have previous node here? No, So I will write here none, right? Similarly, n1 to n2, let's suppose n1 address is 1000, n2 address is 2000, n3 address is 3000. So now coming to the n2 node, this pointer will contain the address of previous node. So what's the address of previous node? 1000. So it will write here 1000. Now coming to the n1 node, so this will contain the address of the previous node, but we don't have any previous node here, so it will contain the address as null or none. Similarly, now if we see the pointer of this n1 node, this will contain the address of next node. So here it will contain the address 2000. Similarly, this will contain the address of next node, that is 3000. Similarly, n3 node, this will contain the address of previous node, that is 2000. And here do we have any node? No. So as we know that this pointer will contain the address of the next node. So we don't have any next node present here. So it will contain the address as null. So this is the basic representation of doubly linked list. And here we can write the data elements, let's suppose 5, 10, 15. And obviously my head will be always pointing to the first node. So this will be my head. So this is the basic representation of doubly linked list. Here the traversal can be done in both the directions. Now let's see the operation in doubly linked list. So like singly linked list, in doubly linked list also we are having three operations: insertion, deletion and traversal. So in insertion we are having beginning at a specified node at end. That means we can insert the node at beginning, at a specified node, or at the end position. Similarly for the deletion also. Now coming to the traversal, here we can go to the forward direction as well as backward direction. So we have already seen the logic of forward direction. So here I will explain you the logic of backward direction also. Now let's see the pseudo code of doubly linked list. Now coming to the pseudo code, the first thing is that you have to create a node. So how to create a node of doubly linked list? So doubly linked list, if I want to create a node, first I will write a class and the class name is node. Then I will create init method, and we know that in a node, let me give the node name is n1. We are having data and two pointers. So here I will give the name as previous, and here I will give the name as next. So how to create a node? I will write here n1 and then node, and I will write here data. So my node will create here, right? So if you will see here, instead of self, n1 will go. So my n1 dot data is equal to data, n1 dot previous is equal to none, and my n1 dot next is equal to none. So next will assign to none here, and previous will assign here to none. So this is my initial condition how to create a node. Here you can see that self dot data is equal to data. That means n1 dot data is equal to data, n1 dot previous is equal to none. So n1 dot previous is equal to none I am getting here, and then n1 dot next is equal to none. So this is the way to create a node. Now coming to how to create a class of doubly linked list. So initially when your head is empty, so we don't have any doubly linked list because head is not pointing to any node, then it will be empty, right? So here I will create a class whose name is doubly linked list, and then I will create an init method, and then I will write self dot head is equal to none. So that means my head is pointing to none. So my linked list is empty as of now. Now we will see the traversal operation in doubly linked list. So here this is the code for the forward traversal that we have already seen in the singly linked list, right? So let me create the node of doubly linked list. Let's say it's a doubly linked list. This is the n1 node, this is the n2 node, this is the n3 node. So here it will contain data as d1, d2, d3. Then it is connected like this. It will be none, and here it will be also none, and the head will be pointing to the n1 node. Now if I want to go for the forward direction, then as we know that my head is fixed, so I will create a temporary variable a is equal to self dot head. Then I will create a loop, right? Because I don't want to change my a value, that's why I have created a temporary variable. So when I am using a loop here a value will be changed, right? So if you see here, I have written here while a is not none. So initially my A is assigning to here, A is equal to self.head. That means it is assigning to n1 node. Now what I will do here, while A is not none, so this is my A, and A is self.head, right? It is not none. Then what I will do, I will traverse it. So I'm writing here a logic while A is not none. So what is my A? A is equal to self.head. So initially I have assigned my head value inside A. So now what I will do, I will write here print A dot data. So it will print the value of D1, right? Now after that, I have assigned here A is equal to A dot next. So what is A dot next? A dot next will contain the address of N2 node, right? So my A will shift here, right? And this is a loop. So this loop will run till my A is not run. Then again the A value will be go up to here. So in this way, whatever the data elements are there, I will write here inside this while loop and I will print it out. So now after forward traversal, we will see the logic of backward traversal. So let me write here backward traversal. Let me create a doubly linked list. So this is my doubly linked list, which will be having 2 pointers. Let me write here the name n1, n2 and n3. So this will be pointing to none. This will contain the address of the next node. This will also contain the address of next node. N2 will contain the address of previous node. N3 will also contain the address of previous node. So what does it mean that N3 will contain the address of previous node? That means N3, this pointer will contain the address of previous node. Now after this, we know that head will be pointing to here, and we don't have any previous node, so the pointer of this n1 node will contain the address as none. Now I want to go for the backward traversal. So we know that in linked list, if you want to go to n3 node, then you have to go to n1, n2, then only you can go to n3, right? So we have to traverse basically from n1 to n2, then only we can get to n3. So here, first what I will do, once again I will create a temporary variable A, and I will assign self.head into this because I don't want to change my head value, and I will be using iteration. So what I will do here, while A dot next is not none, my A is equal to self.head, right? A dot next is this, right? A dot next is pointing to n2. That means A dot next will contain the address of n2 node. So here A dot next is not none. That means A is equal to A dot next. So my value will be A here. Similarly, once again, this while loop will run. A dot next is not none, right? So once again, A value will be here. So you can see that we have traversed from N1 to N2 and now N2 to N3, right? So we know that backward traversal is possible only when we are traversing from N1 to N2, N2 to N3, right? So now what will happen here? Now my A value is here. Now I can do the backward traversal. So what will be the logic? The logic will be the same. I will write here print A dot data, and this time I will assign here A is equal to A dot previous. So we know that this pointer is my previous pointer and this pointer is my next pointer. So this is my A value here. If I'm writing A dot previous, right, then I can go backward. So what I will do, I will put this condition inside a while loop. So I will write here while A is not none. So if you will see here A is not none, then I'm assigning A dot previous into A. Since this is a while loop, so once again my A value will change from here to here. So A is equal to A dot previous, and then I will go here A is equal to A dot previous. If you see here the condition while A is not none, so after coming here, if I'm writing here A dot previous, then it is pointing to none, right? So it will end here. So in this way I can do the backward traversal. So this was the logic for backward traversal. So now let's see the program of doubly linked list. So let me write here doubly linked list. So now what I will do here, since we know that forward traversal will be same as in singly linked list, so I will copy the code from singly linked list. So let me copy the code up to here. And I will also copy the object of class node, that is n1, n2, n3 and n4, and I have linked here, so I will copy it. Okay, let me remove all this thing. So why I'm not writing once again code just to save the time? Because I've already explained you in singly linked list. So let me remove this thing also. Okay, so now let's see the doubly linked list. So first I want to create a node. So this is my class, whose class name is node, and inside this class node I have created a init method. So what will happen in doubly linked list, I will be having two pointers. One pointer name is next and another pointer name is previous. So I will create here one more pointer, self dot previous is equal to none. And inside this class of doubly linked list, once again I will create a init method, and inside this init method I will write self dot head is equal to none. So that means initially if my head is none, then my doubly linked list is empty. So let me remove this thing also, and here I will write forward traversal, right? So we have already seen the logic of forward traversal, right? So let me copy this. So inside this class I will create a backward traversal function name. So I'll write here backward traversal, and here also the same thing will be here. If self dot head is none, then I will write here doubly linked list is empty. Let me change the name here also, right? So initially, now coming to the else condition, yeah, a is equal to self dot head, right? Initially this condition must be there because I don't want to change my head. Now I'll give a condition while a dot next is not none. I will write here a is equal to a dot next. So as we know that for backward traversal, first you have to go through each node, right? So let's suppose if there are n4 nodes, then you have to go from n1 to n2, n3 to n4. So this is the logic to go at the last node, and after that we can perform the backward traversal. So here I will write, instead of a dot next, I will write here a dot previous, right? Let me change the object name here. This is a doubly linked list, and then dll dot head will be is equal to n1, and then again the same thing is there. Here it will be dll dot traversal. So but here the name is forward traversal and backward traversal, right? So I will write here forward, and once again I will write here dll dot backward traversal. So now if I'm executing it, you can see that I'm getting error. Why I'm getting error here? Because I have to put here underscore and underscore. But before that we have connected the node, but it's only for the forward traversal, right? I have to connect the node for the previous one also. So if here I am created n2 node, let's suppose here I have created the n2 node. So after that I will write here n2 dot previous is equal to n1, and after creating n3 node I will also write here n3 dot previous is equal to n2. Now you can see that n2 will be having two pointers, right? So n2 dot previous is connected with n1 and n2 dot next is connected with n3. Now after creating n4, I'll write here n4 dot previous is connected to n3, right? Now if I'm executing it, on executing you can see that I'm getting the output, but in the same line. So let me write here print, and inside print I will not write anything. And now if I'm executing, you can see that I am getting backward traversal through. Now let's understand the logic. How does this backward traversal is working? So if I'm creating a node here, let's suppose n1 is equal to node 5. If you see here, instead of self, n1 will go, and the data that I have given to n1 node is 5, right? So instead of data I will get 5 here. So what will happen here? n1 dot data I will be getting as 5. Similarly, n1 dot next I will be getting none. And then n1 dot previous I will getting as none. So this is my node creation, right? If I'm creating an initial node, then I'm having the data as 5, and the next pointer is pointing to none, and previous pointer is also pointing to none, right? And after that, you can see that I've created an object of doubly linked list, that is a small DLL. So what will happen here? As soon as you are creating the object, the init method inside a class will run. So here, instead of self, DLL will go. So I'll getting here DLL dot head is equal to none. So when my DLL dot head is equal to none, that means my doubly linked list is empty, right? So what I will do here, I will assign here DLL dot head is equal to n1. So now my head is assigning to n1, right? So after this, once again I have created a node n2. You can see that. So here once again the node n2 will be created, and n2 dot data will be is equal to 10 because I have given the data here 10. And then I have written here n2 dot previous is equal to n1. So after taking the data as 10, what will happen here? Let me show you. N2 will be here, and then instead of data 10 will be here, and now my n2 dot data will be is equal to 10. My n2 dot next will be also equal to none, because as of now I didn't connect this node. I have just created this node, right? n2 dot previous will be also is equal to none. So as soon as I have created n2 node, what I will do here, I will write here n2 dot previous is equal to n1. So if you see here, n2 dot previous was none, but right now I will write here n2 dot previous is equal to n1. So that means I am connecting n1 node to n2, right? So the previous pointer of the n2 node will be connected with n1. Similarly, n1 dot next is equal to n2. So initially if you see, my n1 dot next is equal to none, right? But my next pointer will be connected to the n2. That means my next pointer of n1 will contain the address of n2. So this is the logic. I hope you understand. Now I've already shown you the forward traversal. Now coming to the backward traversal, what will happen here? Let me show you. So initially my DLL dot head will be assigned as n1, right? Initially if you see, DLL dot head was none, but I have written here DLL dot head is equal to n1, so it will be the DLL dot head is equal to n1, because in Python the statement will be executed line by line. So whatever the statement you have written here, it will execute first, then it will execute, then it will execute. So that's why. So if you see here, DLL dot head is equal to n1, so the value will be n1. Now let's see the condition. While a dot next is not none, so what is a here? So if you see a here, so a is nothing but n1. So I'll write here n1 dot next. So is my n1 dot next is equal to none? No, n1 dot next is pointing to the n2, right? Because n1 dot next will contain the address of the n2 node. So what will happen here? My new a value will be a is equal to n2. So here you can see that I am going through each node, right? So what will happen here? At last my a value is equal to n4. So now n4 will go here, and n4 dot data is what? If you see here, n4 I have given the data as 20, right? So n4 dot data, so n4 dot data I will be getting as 20. So it will print the data as 20, right? And now after that, what will happen? After printing 20, here a is equal to a dot previous. So n4 dot previous is what? N4 dot previous is nothing but n3. Here you can see that. So once again, now a value is n3. So n3 dot data it will print. n3 dot data is 15. After printing the data of n3, it will go a is equal to a dot previous. That is n3 dot previous. If you see here, n3 dot previous, it's n2. So once again it will go n2. So n2 dot data is 10, so it will print 10. So once again a will take the value as n2 dot previous. So n2 dot previous is nothing but n1. So while n1 is not none, it will print a dot data. So n1 dot data is 5. And after printing the data 5, if you see a is equal to n1 dot previous. What is my n1 dot previous? If you will see here, my n1 dot previous is none. So my a value is none, so this while loop will end. So it will display me 20, 15, 10 and 5. So this is the basic logic of traversal in a doubly linked list. Now let's see the insertion at doubly linked list. So we will see the insertion at beginning first. So this is my doubly linked list. So doubly linked list is having 2 pointers, right? So let's suppose that I'm having 3 nodes here, n1, n2 and n3. So n1 next pointer will contain the address of n2 node. Similarly, n2 previous pointer will contain the address of n1 node. The same goes for n2 and n3. And here n3 next pointer will contain the address as none, because there is no node available after n3. Similarly, here n1 previous will be none. So this is my doubly linked list. Now if I want to insert a node at beginning, so let's suppose this is my node. So how to create a node? We have already seen it. So if I'm writing, let's suppose here nb node at beginning, and if I'm writing a node, and inside that I am passing the parameter data, so this will contain here a data, and this pointer will be nb dot next, right? And this pointer will be nb dot previous. So nb dot next is equal to none and nb dot previous is equal to none initially. Now what will happen here? As we know that initially my head will be pointing to the n1, right? Because this is my doubly linked list. So if I want to insert this node, then my head will be changed, right? Because head will always point to the first node. So what I will do here, so let me connect this node. I will give the name here as nb. So let's suppose this is my nb here. This is by nb, and initially it is not linked. So if it is not linked, then n1 dot previous is initially none, right? Now I want to link it. So let's see. First what I will do, I will create a temporary variable a is equal to self dot head, and I know that my head is pointing to n1 as of now, but I want to change this head and I want a link established between nb and n1. So what I will do here, after creating a temporary variable a, I will assign self dot head into this, and now this is my a, right? So my a is equal to self dot head. So I will write here a dot previous. So if I'm writing here a dot previous is equal to nb, so what is a? A is nothing but head. So if I'm writing a dot previous, this is the previous, right? Initially previous is equal to none. So a dot previous is equal to nb. That means now this previous will contain the address of nb. So now it will not be none. So I have established a link here, right? Now after this, I will write here nb dot next. So this is my nb, this is my next, and this is my previous, right? So here if I'm writing nb dot next is equal to a, that means again I have created a link. So here you can see that nb dot next is equal to a, that means my link has been created. So it means that nb dot next will contain the address of my n1 node. Now after this, this is my head, right? So once the link has been established, my head will change. So for that, what I will write here, I will write here self dot head will be equal to nb. So this head will be changing here and this head will come here. So you can see that now head is pointing to nb dot next contains the address of n1 dot previous will contain the address of nb, and we know that nb dot previous is already none. So this will be none, right, while creating the node. So this is the basic idea about insertion of node at beginning. Now let's see it in coding example. So this is my doubly linked list, and in the doubly linked list class itself I create a function def, and I will write here insertion at beginning. Insertion at beginning. So what I will do here, I'll pass the parameter data, right? Because data value will be given by me. So after this creating function, first I have to create a node. So let me write the node name. Let's suppose node at starting ns is equal to node, and here I am giving data. And after creating a node, I will create a temporary variable a. Inside that I will assign self.head. So initially my self.head is pointing to n1. So after creating a temporary variable a and assigning the self.head value inside a temporary variable, I will write here a dot previous. So what will a dot previous will give me? A dot previous will give me here ns, right? So that means I am linking the n1 node with the ns node at starting. And then I will write here ns dot next. So the node that I've created, right, its next pointer will assign to a. And after that I have to change the head. So I'll write here self dot head is equal to ns, right? Because ns will be my first node, so head must assign to ns. Now after this, once again I will write here the function name. So I will write here dll dot insertion at beginning, and let's suppose I'm inserting a value here 2. And if I want to do the forward reversal, then I will just copy and paste this. So on running, you can see that I am getting the output, but once again I have to write the print to see the output into the next line. So if you see here, you can see that a creation of new node has been done and the data element is 2. Now what if I want to do the backward traversal? You will see that my logic will work for backward traversal also. So if I'm writing here, then you can see that I can do the backward traversal also. So you can see that I can also do the backward traversal with this logic. So this is the basic idea about insertion at the beginning. Now let's see the insertion at end. So let's suppose this is my n1 node, this is my n2 node, and this is my n3 node, and this is the node that I will create. Let me give the name as any here. So how to create a node? So when I'm writing here any is equal to node, and I'm passing data inside this node. So what will happen here? Any node will be created, and any dot next will be none, and any dot previous will be none. Initially when I'm creating this node, I'm not linking this node to any other node. Now after this, let's understand the logic. So before understanding the logic, let me connect these nodes. So initially my n1 dot previous will be none and n3 dot previous will be also none. And this is my any node, right? I'm not connecting this any node with this doubly linked list as of now. So let's see the logic here. So initially once again I will create a temporary variable a, and inside that I will assign self.head. Once again the same logic, because I will use this a for the iteration, so I don't want to change the head value. Now I will use a while loop. So I will write here a dot next is not none. So a dot next is what? This is my head, right? A is equal to self.head. This is my head. So a dot next is pointing to n2, so it's not none. So this is my a dot next. So a dot next is not none, right? So my a is equal to a dot next. So my a will jump here. Similarly, once again this is a while loop. Again a dot next is not none, right? Because a dot next is containing the address of n3 node. So once again this while loop will run a is equal to a dot next. So my new a will be coming here. Now once again if you see a dot next is not none, but here a dot next is none, right? Because as of now this is not linked with any node. So this while loop will end here. So after that what I will do here, a dot next is none my here, right? I will assign any into a dot next. So here instead of none, any will be connected, right? This is my any, right? Now any, now coming to the any dot previous is none, right? So what I will do here, once again I will here write any dot previous is equal to a. When I'm writing here any dot previous is equal to a, that means any dot previous, this is the previous pointer of any, so it is connecting with n3. That means any dot previous will contain the address of n3 node. So this is the basic logic for insertion at end. Now let's see the coding example. So let's see the coding part. So here, just like I have created insertion at the beginning function, once again I will create a function def, and I will write here insertion at end, and I will pass the parameter here data. Now what will happen here? I will create a node any is equal to node, and I will pass data here, right, inside a node. Now after creating node, once again I have to create a temporary variable. So I will create temporary variable a is equal to self dot head. Now since I have to insert at the end, that means I have to traverse through each node, right? So for that I will using a while loop. So I will write here while a dot next is not none, I will assign a value is equal to a dot next. Now after this, once I am traversing through each node, what I will do, I have to connect the last node. So after this, how to connect a last node? So I will write here a dot next is equal to n of e, right? And I will also write here any dot previous is equal to a. So the connection has been done now. Now let me execute this. So for executing, what I will do here, let me copy this and I will paste here. And what's the name here? Insertion at end. So instead of beginning I will write here end, and instead of two value, let's suppose at end I want to do the insertion, right? So let me give the value as 25 here, and if I'm executing it, then you can see that I'm getting the output. Since I have to give the space here to get the output in the next line, so I will use print function. So you can see that a node has been inserted whose data is 25. So this is the logic for insertion at end. Now let's see the insertion at any specified node. So this is my node n1, this is my node n2, and this is my node n3, and this is my node n4, right? So if you see here, then n1 dot previous will be pointing to none, and then n1 dot next will be equal to n2. Similarly, n2 dot previous will be equal to n1. So in this way there will be a connection, and here n4 dot next will be equal to none. So here I want to insert the node. So let's suppose this is the position 1, 2, 3 and 4. So what I will do here, I will insert a node at position 3. So my position is equal to 3. So for inserting a node at particular position, first I have to create a node. So how to create a node? So I'll write here nib is equal to node, and then I will pass data inside this. So my node has been created. This is my node which will be having a data, and here nib dot previous will be equal to none, and nib dot next will be also equal to none initially, right? So this is my creation of node. Now my head will be always pointing to the first node. So this is my head. So I will write here a is equal to self dot head, which will be pointing to n1 initially. So after this, what I have to do, so if I want to insert a node at any particular position, so this is a linked list, I have to traverse, right? If I want to insert a node at position 3, so I have to go through position 1 to 2, then only I can jump to 2 to 3, right? So that's why I have used a for loop here, and I have written here position -1. So position is here 3, so 3 minus 1 will be 2. So for I in range 1 comma 2, so as we know that in Python this 2 will be excluded. That means for I is equal to 1, my value will be a is equal to a dot next. That means iteration will be done only for one time. So what will happen here? So a dot next is this, right? So what will happen here? For I is equal to 1, my a is equal to a dot next. So this will be my a. Now after this, if you see here, I have written here nib dot previous is equal to a. So this is my nib dot previous, which is equal to none initially when I am creating a node, because I didn't link at that time, right? So if you see here, I have written nib dot previous is equal to a. So that means I will connect this nib dot previous with this n2. So after this, I will create a connection between the nodes. So how will we connect? So this is my node whose name is nib, and nib dot next is none, and nib dot previous is also none initially, right? But here if I'm writing nib dot previous is equal to a, so nib dot previous was none initially, but if I'm writing nib dot previous is equal to a, that means what will happen here? This link will be like this. So the link will be generated like this, right? nib dot previous is equal to a. So now this link has been generated with n2, right? So that means nib dot previous will contain the address of n2 node. Let's suppose that address of n2 is 1000, so it will contain the address of 1000. Now coming to the next, nib dot next is equal to a dot next. So my nib dot next is equal to none, right? What is a dot next? My a is here, right? So a dot next is nothing, but it contains the address of n3, right? So if I'm writing here nib dot next is equal to a dot next, that means I'm creating the link here, right? So let's suppose this n3 is containing an address of 2000, then nib dot next will contain address now 2000 here. Got it? Now after this, what will happen here? If I'm writing here a dot next dot previous, so this is my a dot next. So if I'm writing here a dot next dot previous is equal to nib, so that means another link has been generated. Let me remove this. So another link will be generated from here, and it will contain the address of this node. So let's suppose the address of this node is 1500. So this will contain 1500 here. Now if I'm writing here a dot next is equal to nib, so this is my a, right? A dot next will be here. So now what will happen here? If I'm writing here a dot next is equal to nib, so that means a dot next will contain the address of nib, that is 1500. So 1500 will be here. So in this way you can see that I've inserted a specified node in doubly linked list. So this is the basic logic. Now let's see in the practical example. So now we'll see the logic in coding. So I will create one more function here, def, and let's say insertion at a specified node. I will give the name here. And here I will give two parameters. I will also give position, because at which particular position I want to insert the node. So I'll write here self position and then data. Now what will happen here? First I will create a node. So I'll write nib, that means node in between. You can take any node name. So I'll write here node data. Now after creating node, what I will do, once again I will create a temporary variable, a is equal to self dot head, so that my head value shouldn't be changed, because I don't want to change my head value, but I will use it in the iteration. So after creating a, I'll create a loop. So I'll write here for I in range, and then I will write here 1 comma position minus 1, and inside that I will write a is equal to a dot next. So what does this mean? So let's suppose that if I want to insert a node at any specified position, so before that I have to traverse through each node, right? So this is the logic that I've used using for loop. So after that, what I will do here, I will write here nib dot previous is equal to a. So why I'm writing this? Because I want a link connection between the nodes. And after writing this, I will write here nib dot next is equal to a dot next. Then I will write here a dot next dot previous is equal to nib. Since this is a doubly linked list, so we have to connect the previous pointer also and the next pointer also. Now I will write after this a dot next is equal to NIB. So this is my connection. Now once the connection has been done, let me print it out. So what's the name of this function? Insertion at specified node. So I'll write here at specified node, and let's suppose that at position 3 I want to insert, right? So at position 3 what value I want to give? Let's suppose that at position 3 I want to give the value as 7, so I'll write here 7, and I'll write here print so that I can get the output this time in the next line. So let me execute it. So on execution you can see that at position 3 my new node has been created whose data element is 7. So this is the basic logic for the insertion at different positions in doubly linked list. So now let's see the deletion in doubly linked list. So my doubly linked list, let's suppose, look like this. And here I am having 3 nodes, n1, n2, n3, and each node will contain a data and 2 pointers. So this pointer, that is n1 dot previous, will be pointing to none because I don't have any node before this, right? Similarly for n3 dot next, this will be also none. Now this pointer, that is n1 dot next, will contain the address of n2, right? Similarly n2 dot previous will contain the address of n1. So we know all these things and we have already discussed it. Now let's see the logic. If you want to delete this node at beginning, then what will be the logic? So this is my n1 and this is my first node, so head will be assigned here. So what I will write here, I will write here a is equal to self dot head. First I will create a temporary variable a, and inside that I will assign self dot head. Now what will happen here? After that I will write self dot head is equal to a dot next. I know this is my a, so a dot next I am assigning into self dot head, right? So that means now my self dot head will be this, because I am assigning a dot next into self dot head, and my self dot head was initially at here, right? But inside self dot head I am assigning a dot next, and this is my a dot next. So my new self dot head will be here. So I will remove this. Now after this I will write here a dot next is equal to none. So if I'm writing here a dot next is equal to none, so this is my a dot next, right? So if I'm writing my a dot next is equal to none, then this link will disconnect. Yeah, so I will remove this link. Now if you see here, I have written self dot head dot previous is equal to none. So now what is my self dot head? Self dot head is here, right? So if I'm writing here self dot head dot previous, that means I'm talking about this one, right? So self dot head dot previous, if I'm assigning here none, that means there is a disconnection between n1 and n2. So this link will be disconnected. So let me disconnect it. So once the link has been disconnected, so you can see that this is the deletion of a n1 node, that is deletion at the beginning. And here this is my head position, this is my n2 node, and this is pointing to none, right? So this is the basic logic of deletion at the beginning. Now let's see it into the coding part. So now let's start with the deletion at the beginning. So I'll write here def, and then I will write here deletion at beginning, and then I will write here self. I don't have to pass the parameter here as data because I have to delete the node, right? So inside this I'll write first a is equal to self dot head, right? So here I've created a temporary variable in which I've assigned head, right, as self dot head. Now I'll write here self dot head is equal to a dot next. So I'm changing my head value from the first node to the second node, because first node I have to remove it. Then I will write here a dot next is equal to none. That means I'm disconnecting the link between nodes. And then I'll write here self dot head dot previous is equal to none. So let me execute this. I'll copy this thing. So I'll paste here, and then after that I will write here DLL dot deletion at beginning, and after this I will write DLL dot forward traversal. And I want the output to be in the next line, so let me write before itself print. So on executing, you can see that the first node was deleted, and in the first node I was having a data element as 2, so it has already been deleted. Now what if I want to do the backward traversal? So once again I can do it. I'll just copy here and paste here. Let me write here backward, and after running you can see that I'm doing my backward traversal. So this is the basic idea for the deletion at the beginning. Now after deletion at beginning, we will see the deletion at end. So let me create my doubly linked list. So let's say I'm creating a doubly linked list of 4 nodes. So each node will be having 2 pointers, that is previous and the next. So I'm having 4 nodes starting from n1, n2, n3 and n4, and let me connect with the link. So as we know that n1 dot previous will be none initially, and n4 dot next will be none. So here I want to delete the last node. So one thing is clear, if you want to delete the last node, then you have to go through each node. So I have to create a logic. So for that I will be using a loop. Now if you want to delete the last node, then we need 2 variables also. So I will create here 2 variables. So the first variable I will create here is previous is equal to self.head. As we know that head will always point to the first node, so this will be my previous variable. Now I will create one more variable, a is equal to self.head.next. So self.head is this, right? If I'm writing self.head.next, that means I'm coming to here. So this will be my a, right? Now as I told you that if I want to delete the end node, then I have to go through the each node. That means traversing through each node. So for that I will be using a loop, while loop, and I will write while a dot next is not none. So my a is this, right? So a dot next, is it none? No, it's not none. A dot next contains the address of n3 node, so it's not none, right? Let's suppose the address of n3 node is 1000, so it will contain the address 1000 here, so it's not none. So if it's not none, then a is equal to a dot next, then my new a will be here. Similarly, previous equal to previous dot next, so my previous will come here. So once again this loop will work. It will say a dot next is not none, so here a dot next is not none, right? So once again my new a will be here and the previous will be here. Now why I have created 2 variable, you will get to know now. If you see here, I have written here previous dot next is equal to none. This is my previous, right? If I am writing here previous dot next is equal to none, that means I am disconnecting this link, right? And this is my a here, right? So if I'm writing here a dot previous is equal to none, once again the link has been disconnected. That means this node has been deleted. So this is the basic logic of deletion at end in doubly linked list. So let's see the coding part. So once again I will create a here function, and I will write here function name deletion at end, and after this what I will do, let me write print here first so that I can get the output in the next line. Now I will create 2 variable here. First let me create the variable as head, so I'll write here previous is equal to self.head, and then I will create a is equal to self.head.next. Now what I will do, since I have to delete the last node, then I have to go through the each node. So I'll create a while loop here, and I will write while a dot next is not none. I'll assign a is equal to a dot next, and I will also write previous is equal to previous dot next. After this, once the loop is over, what I will do, my previous dot next is none if I'm writing here. That means the link has been disconnected. Now if I'm writing a dot previous, that means the last node. If I'm writing a dot previous is equal to none, then the node has been deleted. Now if I want to execute it, then let me execute this. I will copy this, Control C, and then Control V, and here I will write, instead of beginning, I'll write here deletion at end. Let me check the function name, is it correct? Yeah. Now if I'm executing it, so on executing, if you see that I was having earlier 6 nodes, but now I'm having 5 node, and this 25 data element has been deleted. Why? Because if node has been deleted, then data also inside that node will be deleted. Now here once again I have done the backward traversal. So while backward traversal, I am getting the data values from the last, that is 20, 15, 10, 7 and 5. So this is the logic for deletion at end. Now we will see the logic. If you want to delete any specified node, then how can you delete? So after seeing the deletion at beginning as well as end, we will see the deletion of a node at a specified position. So let me create here a doubly linked list, n1, this is n2, this is n3, and this is n4. So we know that each node is having 2 pointers, that is previous as well as next. So let's suppose 1000 is the address of this node, 2000 of n2, and for n3 I'm having 3000 address, 4000 is the address of n4 node. So we know that n3.next will contain the address of n4, that is 4000, right? Similarly n4.previous will contain the address of n3 node, that is 3000. That's already understandable, none. So n4.next will be none, and n1.previous will be also none. So like the previous case, we have seen deletion at end. Here also we will take 2 variables. The first variable name is a, and the another variable here name will be b. So what I will do here, this will be my b, which is nothing but a head, self.head, right? And my a will be self.head.next. So what is self.head.next? Self.head.next is nothing but this one, right? So that means this is my a, right? And this is my b. So what I will do here, I will use for loop, but previously we have seen the while loop for the deletion at the end, right? But why here we are using for loop? Because let's see the position. This is a position 1, this is a position 2, this is a position 3, and this is the position 4. So if I want to delete the node at third position, right? So I will write here for I in range, and this will be 1 comma position minus 1. So my position is 3, 3 minus 1 will be 2. So here I will be getting 1 comma 2. So as we know that in Python, if 1 comma 2 is there, then 2 will be excluded. That means for I is equal to 1, my loop will run a is equal to a dot next and b is equal to b dot next. So a is here, right? So a dot next is nothing, but a dot next will contain the address of 3000, right? So this will be my a. Similarly, b dot next is nothing, it will contain the address of n2 node, that is 2000. So this will be my b. So for I is equal to 1, my a will be here, my b will be here, right? Now what's the point of doing the iteration here? If you see here, I have written b dot next is equal to a dot next. B dot next is this, right? And inside b dot next I am assigning a dot next, and this is my a dot next, right? So what I will do, so I will remove this and I will connect this b dot next with a dot next. So there is a connection. After that, I have written here a dot next dot previous is equal to b. So what will happen? So a dot next is this, right? So I'm coming here. Now if I'm writing a dot next dot previous, so I'm going backward. So if I'm writing a dot next dot previous, and in that if I'm assigning b, then you will see, so this will be removed and this will be connected to here, right? To n2 node. Now what will happen here? After this, if I'm writing here a dot next is equal to none, so this is my a dot next, right? So if I'm writing a dot next is equal to none, that means inside a dot next I am assigning none. So this link will be disconnected. So I will erase this link. Similarly, if I'm writing here a dot previous is equal to none, this is a dot previous is this, right? So I will remove this. So here you can see that this is a deletion of a node at the position 3. So this is the basic idea about deletion. Now we will see the concept in coding. So now we will see the deletion at any particular node. So what I will write here, I will create a function and I will write function name deletion at particular node. And I will give here a parameter as position because I want to delete a node at particular position. So now what I will do here, once again I will write here print so that I can get the output in the next line. After that I will create a variable. Let's suppose here I am creating a variable a is equal to self dot head dot next. Then I'm creating a variable b which is equal to self dot head. So if I'm creating a variable a, so that means I'm assigning self dot head dot next into the variable a. Similarly, if I'm creating a variable b, so that means I'm assigning self dot head into this. Now after creating this, I'll create a loop. So I'll write here for I in range, and then I will write here 1 comma position minus 1. And after this, what I will do, I will write here a is equal to a dot next and my b is equal to b dot next. Now I will write here b dot next is equal to a dot next. After that I will write a dot next dot previous, and in which I will assign here b. Then I will write here a dot next is equal to none, and then I will write here a dot previous is equal to none. And now I will call this function with function name. So let me write here dll dot, I will paste this function. So let's suppose that if I want to delete at position 3, right? So I'll write here position 3. So we will see that this node will be deleted and the data elements will be also deleted. So my new doubly linked list will be 5, 7, 15, 20. So now let me call here. So for calling it, I will copy this dll dot forward traversal. Let me copy and paste here. And now if I'm running it, you can see that I am getting 5, 7, 15, 20. This 10 has been deleted. Similarly, if you want it for the backward traversal, you can do it. I will just copy this and then I will paste. So you can see that we are getting the node value from backward. So this was the logic of deletion. So next we will see what is circular linked list. So circular linked list is a linked list where last node contains the address of first node. So let's suppose this is the n1 node, this is the n2 node, this is the n3 node, right? This will contain a data 10, let's suppose, and this will contain 20, this is 30. And let me give the address here. So let's suppose the address of this node is 1000, here is 2000, and then here is 3000. So we know that n1 will contain the address of n2 node, that is 2000 here. Similarly, n2 will contain the address of n3, that is 3000. Now this is the last node, n3 is the last node. Now this will contain the address of first node. What is the address of first node? 1000. So this is the basic idea of circular linked list. Now circular linked list can be of two types. Let me write here circular linked list. So in circular linked list I can have singly circular linked list, and then I can have also doubly circular linked list. Now we have seen the operations like insertion, deletion as well as traversal in singly linked list. The same will go for singly circular linked list. Similarly, the same goes for doubly circular linked list. So at insertion, we have seen that we have done the insertion at beginning, then we have done the insertion at end, then we have done the insertion at a specified node. So the same goes for the singly circular linked list as well as for doubly circular linked list, right? So this was all about circular linked list.
Now let's talk about the advantages and disadvantages of linked list. First, let's talk about the advantages. So obviously, as compared to array, right? When we talked about arrays, they were fixed in size, right? We need to specify the size in the subscript. So fixed in size, which is not in the case of arrays. It is dynamic in nature and you can add as many nodes as you want depending upon your requirement, right? So obviously when you have that uh, independency over the size, you will never, there's no chance of wasting any memory, right? So if you require 4 nodes, you will use 4 nodes. If you require 3 nodes, you will add 3 nodes only. So in this way, the size of the linked list is entirely dependent upon your application. What are the things that you require, you make them, that's it. So you will not be wasting your memory and you will be utilizing your memory very efficiently. So this is the reason why this is written over here, the efficient memory allocation. How you are doing efficient memory allocation? Let's suppose you have chunks of memory available here and there. You can link them together and allocate the memory and use those memory location for storing the data, right? So memory can be used efficiently. Memory is not wasted. It is dynamic in size and it is very easy to insert and delete a node in a linked list just by manipulating a single link, as we have seen earlier. Just if you want to delete this, you just manipulate this link and just point this link to the next node, which is after this node. That's it. You are done with the deletion operation just by manipulating a single link. Similarly, when you're talking about insertion, at that point, you just if you want to insert at this location, you remove this link, point it to this, and then remove and point this new node to this node that is there, that was already there. Again, we are manipulating a single link. Okay, just the manipulation of single link here, that is required for insertion, and a single link here that is required for deletion. Now when we talk about disadvantages, one of the major disadvantage is that you cannot lose your head, right? The head node that is pointing always to the first node, either in a singly linked list or a doubly linked list or a circular linked list. This head node cannot be lost. If this head node is lost, or if it is manipulated, right? If the head node is lost or manipulated, the whole linked list will be lost, right? Let's suppose this is your linked list and somehow, right, if this is the head node and somehow you made it traverse to this particular point, right? Now head node is pointing to this in a singly linked list. Now there is no way you can access these nodes and you will get undesired results. Another disadvantage is that you cannot access randomly. So random access is not possible because if you want to go at this particular node, you have to traverse through the first 3 nodes first. Why? Because this node knows the address of this node. This node knows the address of this node. This node knows the address of this node. There is no way you can directly go to this particular node. Random access that was there in the arrays with the help of indexing, you can randomly access the elements. That is not possible in terms of linked list. And the address of the first node is known to the head of the linked list or the root of the linked list. Okay. So that head is pointing to this first node. Okay. So you cannot change or manipulate or lose, or you cannot lose your head because the whole linked list will be lost. Okay. And the random access is not possible in linked list. Binary tree. Now let's talk about what is binary tree. So it is a hierarchical data structure. As we have seen in earlier data structures like arrays, linked lists, stacks, and queues. All of these data structures were linear data structures. But when we talk about tree, is a hierarchical data structure. That means it can have one or more than one children. Doesn't have to be explicitly two children. But when you talk about binary tree, therein you can have at most two children. That means if this is the node, and then it can have at most two children, or if this is a node, it can have either left child or the right child, or it can have no children at all. Okay, so this is a binary tree, and now this is known as the root of the tree. That means the first node is known as the root of the tree, and you cannot access elements or these nodes directly. Okay, so now, this is the whole structure of a binary tree. Now, there are some common traversals, right? How we can traverse through all these nodes. So, one of the common traversal is pre-order, wherein you always, whenever you are on this node, you always print this node first. What is the value of this node? Then you go on to the left side and do the same. Then again you go on to the left side, then do the same. Print, go on the left side, print, go on the left side, and so on. Unless and until there is no left, then what you do is print that thing. Okay. Then after that, you will go on the right side. So pre-order follows print first, then go on to the left, then go on to the right. Similarly, post is saying that whatever is you have, print it at the last. So go on the left, go on the right, print at last. And in order says left, print, and right. So these are all traversals. We will also see one by one how we can implement it, and how we will also see examples based on these traversals. Now let's talk about the applications. If you have seen the file hierarchy system, wherein we have the root folder, and inside that root folder we have subfolders like music, and we have bin, we have files, we have program files, and all those things, right? So it is a kind of a hierarchical data structures, right? And explicitly here we are not talking about binary tree but generalized tree. Now, if you have binary tree, it has multiple variations, right? If you talk about this binary tree, so here you always have either the left child or the right child. When you talk about BST, the childs are inserted in the tree in such a way that on the left side it will be always less than the root, and on the right side it will be always greater than the root. So this is a variation. It is known as BST. So you have aerial tree wherein you don't exceed the height more than 2. So that is one more variation. Then we have red black trees. So these are all variations of binary tree.
So after knowing what is binary tree in theoretical part, let's quickly implement the binary tree in practicality on Google Colab in Python. So before doing that process, so let's learn what are the different functions we are going to perform in a binary tree concept. It's generally by default, everyone will start learning with in-order traversal, pre-order traversal, and post-order traversal. So I'll quickly brief you what is in-order, pre-order, and post-order, and then we shall go to implementation part, right? So let me give you a brief explanation over this. First, we'll start with what is binary tree, right? I'm taking a simple example, nothing related to coding or anything, just a simple example. So binary tree in the sense, it should have at least one node and two different subnodes. I call it as left and right sides, right? It should have one data item. I'm putting it to 1 here, and it should also have left child, and it should have the right child. So again, I'm trying to put 2 here, I'm putting 3 here, and extending with 4. So we'll be working and understanding with this simple example how does binary tree will work. So the first thing you have to know, I'm talking about in order. So what is in order here? There is a simple basic rule which you can remember. When you traverse throughout the nodes which you have in a binary tree, you have to start from the left, visit root, and then right. So I'm writing it here for you. So left first, root next, and then the right node, right side node. Okay. Then we have the next one, pre-order. How does this pre-order will work? It has the same rule, but in a shuffled manner. First you are visiting the root, then you are visiting left side of the tree, and then you are going towards the right side. Hope that's clear, right? And the last one which is left is post order. So what is post order? Again, you have a shuffled way of this three combination only. The first thing is it will go to left. That means left side of the particular diagram or the binary tree which you have taken, and then it will go to the right. After that, it will go to root. So this is the basic things you have to know on these three functions or operations which you do it generally in binary tree. So in order, pre-order and post order. So let's quickly start with in order, right? So in order, it says we have to visit to the left first, then go towards the root and then come back to right. So I'm implementing the same. So here, what is the leftmost node we have for this particular example? Simple example we have taken. So that is 4, if you could see, right? So this is the leftmost and this is the rightmost and this is the root, just for reference, right? So at the left, what do you have? 4. So for in order, I'm writing it here as well. So in order, you will put up 4 as the first element because the rule says you have to go towards the left of the binary tree. Then after 4, what do you have? This direction. You have 2. You have to first complete the left side part, then you have to go to the root. And next, on the way, what do you find? You find root. So what is the number in the root? Is 1. And then after coming back towards right side, so what is the number we have? We have 3. So this is how in order will work. So hope that's clear. We are starting from left. We are going towards the root and we are coming back towards the right side. So again, how do you do it for pre-order? The next one. So what does pre-order say? You have to first visit root, then go to the left and then go to right. So I'm going to root here in the same diagram. I'm drawing one more here for your reference. So this is 2, again this will be 4 and this is 3. Hope that's clear. So we are working for pre-order here. It says we have to go for root first. So what is the element in the node? That is 1. Okay. So next it says you have to go towards the left. So what is there in the left? This side you have 2 first and then 4. So what I'm writing, it's 2 here and 4 next. Then you have to visit right side. So at right side you have 3. So this is how pre-order traversal will work in binary tree. So quickly we shall see the last one, that is post order. Right. Post order, as per the rules, what does it say? We have to go towards the left first, then right, and then root at the last. So, writing down a simple diagram again here for avoiding the confusion. 4, this is 3. Okay? So, we are doing that. Left side, what do you have now? We have 4. Again, continuing, you have towards the right side, 3. Right. After having 3, what do you have? You have to go to root. So what does it say? You have to first complete whatever there in the left. So what we have left out here? We have left the 2 because it is also on the left side. So what we'll do here, right? We'll try to put up this 2 here, finish it off. That is 4, 2, 3 and then you have to go to 1. So first what did I do? I went to the left part, that is 4. So after that, you have 2 and then you have to go to right and then root. So this is the root. We can't go there until unless we finish towards the right side. Towards the right side we had 3 and then we went to root back. So that makes 4, 2, 3, 1 as a post order. Hope this was clear for you. And now let's quickly hop into the coding part and check out the same elements, the same functions. How does that work? So what is happening here is the same example I've taken in a coding format. That is where I'm taking the 4 different nodes, that is 1, 2, 3, 4 and applying all the 3 functions we have. That is in order, post order and pre-order with the same way of working, but in a coding manner. So what has happened here? The first, if you could see, they have put up a class that is node, right? So after creating a class node, we have to initialize the values. Value is val is nothing but root, right and left. So we have to have one single root node, and we have to have left and right for the same root. So then we'll create some functions for traversing towards pre-order, traverser towards in order, traverser towards post order. To make it clear and precise enough, I have kept related name to the functions and classes here. So what happens here is we'll be using the functions called pre-order, post-order, and in-order. So first it will visit the nodes accordingly as I told you. So first for pre-order it will go to root, left, right, and for in-order it will go for left, root, right, and again for post-order it will go for left, right, and root. So let's check out how does this program work in the manner. So here you could see I've used the left and right accordingly. So as per the rules I've told you, that has been used here as well. So let me quickly run the program for you and check out what is the output we get. Right, if you could see here, pre-order, we got it as 1, 2, 4, 3. The reason is because it is going from root, left, and right. And for in order, we are going with left, root, and right. So left side we had 4, 2, and again 1 was the root node and 3 was at the right. So left, root, and right. If you go for post order traversal, then it will start from left, right, and root. So leftmost was 4, 2, and it went to right. Right side was 3, and root is 1. So this is how the traversal will work in binary tree in Python.
Now let's talk about advantages and disadvantages of binary tree. If you talk about advantages, we can represent data with some relationship, right? So this is the root node, or this is the parent node, and this is the child node. So that relationship, parent-child relationship, is always there. And while you are inserting or searching an element or a node in a binary tree, it is much more efficient as compared to other data structures which we have seen. Now, if you talk about disadvantages, if you want to sort this binary tree, it is much more difficult, right? Because we can either go on the left side. This can be a tree. That means this is a left skewed tree, or this can be the scenario wherein we have all the elements on the right side of the node. So this can be another scenario wherein we have this right skewed binary tree. So sorting is difficult and it is not much flexible, right? If you talk about this binary tree, we always have either the 2 children or 1 children or no children. There is no flexibility in terms of how you want to store it. Can we store another node on the with this root node? No, that is not the case, right? And we don't follow any restrictions like, okay, we always find this node. That is, if this is a root node, we always find an element which is less than this node on the left side or on the right side. That is the greater element. So that flexibility is not there. Binary search tree. Now, what is binary search tree? So binary tree is an additional restriction, right? This BST is nothing but the additional restriction on binary tree. Like we have already seen the binary tree wherein at most we can have 2 children, right? It can be on the left side or it can be on the right side. Now, what are the restrictions on this tree? So the restrictions are that the data, that is, let's suppose this is 5 and these are another 2 nodes. Now the restriction is that if this is a root node, then you always will have the element that is less than your root node. So you can have 4, 3, 2, 1 on these sides, but you cannot have 6 on the left side. Similarly, you can have 6, 7, 8, 9, and so on. On the right hand side, you cannot have 1, 2, 3 on the right hand side. So these are the 2 restrictions that are there in binary search tree. Now, if you talk about insertion, deletion, and while you are searching the element in the binary search tree, it is much more efficient as compared to binary tree, because we can obviously, when we are trying to search for an element, we can obviously, if let's suppose we are searching for 8, so will it make sense to go on the left hand side? No, we can easily neglect this part. Similarly, we can do it on the rest of the elements. This is one scenario wherein searching is much more efficient than binary tree, because in binary tree we cannot neglect any elements, or we cannot say, okay, now we cannot find an element on this portion, on that portion. Similarly, when we are inserting, now if the element is greater than 8, so we can easily, in this scenario, right, we can easily go on the right hand side rather than searching where we want to insert it. And similarly, when we are deleting, a little bit of ordering is done in order to get the exact same situation, wherein your root is less than the right hand side elements and wherein your root is greater than the left hand side elements. So that scenario is there in the binary search tree. Now let's talk about the application. It is suitable for applications which require sorted hierarchical data. Let's suppose you have some data and you want to store them in such a way that always you want your elements that are greater than the root on the right hand side, right? You want them on the right hand side, and for the elements which are less than this root, you want them on the right hand side. Okay, so that you can easily neglect. Okay, you can now, let's suppose, not, if you don't want this scenario wherein you are just dealing with the greater than or the less than, you can have a similar kind of a situation wherein you are saying that, okay, on this side I will always have some files that are related to coding. Okay, let's say an example, and in this I will always have files which are related to entertainment. So you can do that so that you can easily neglect these files, because these are always going to be your coding files, and these are always going to be your your entertainment files. So wherever you require sorting, right, or you want your data to be in such a manner that it is easy for you to find, insert, and delete. So therein your binary search tree comes into picture.
After learning what is binary search tree, right, we have to implement that particular topic here in Python on Google Colab. So before that, let's understand what are the different function you'll see in binary search tree. So it is very basic function, that is insert, search, and delete. So before going to these functions, I need to let you know that how do you draw a binary search tree? You have a specific condition to be followed in order to have a binary search tree. So number one, you have to have the root node should be always greater. Whatever the subnodes which is lesser than the root node will be towards the left side, and if it is greater than the root node, it will be on the right side. You have to consider these two conditions before writing binary search tree, right? So I'll just give you a simple example of a binary search tree keeping these conditions in point. The first condition I told you is the root node should be taken into consideration. Whatever the root node is, for example, the root node is 10. Okay, anything below 10, it should come towards the left side of the root node. Anything above 10, 11, 12, 13 and so on, it should come towards the right side. So whatever it is greater should come here towards the right. What is lesser should come towards the left side. So keeping this into consideration, 10 is the root node I'm taking, and anything you want to add on, right? So I'm adding 5. When you are adding lesser than the root node, that should be towards the left side. And if you are adding anything greater than to the root node, that should be towards the right side. So I'm adding 12 here. Then after that, what you have to do is, if you want to continue to the next level, right, you have to follow the same condition. For now, just for reference, 5 is the root node. Anything lesser than 5 should be towards the left side. Anything greater than 5 should be towards the right side, right? Again, if you take 7 into consideration, right, as a root node, anything towards the left side will be having the lesser value. You can keep it as 6. Anything towards the right side will be having the greater value. You can keep it as 8. So this is how particular BST tree will work. So this is a simple example for binary search tree. So let's understand how does the searching will happen with the help of a pseudocode and proceeding with insert and then delete, right? So let's see search operation first. So what happens in search? The first thing is root node should be considered. If root node is equal to null, it is not having any value, then we will be returning null. Okay. If the same thing again, number or the value or the data, I'm taking number here, whatever the user input is, right? If the number which is given is equal to root, the values of root and the input number is same, then you have to return root only. Okay. The next condition, if number is less than root, as I told you, whatever it is less than root value, the number should go to the left side of the tree. So what do you write? And you can write it as return search. Search will traverse towards the left side. Any element you are finding over a tree, right? You are finding, for example, for number 4, right? So in a tree here, like this, anything like this, say you have different values here. I'm not writing values as of now. So the 4 is situated here. So what does it say? It goes in comparison. First, it will search for root value. Is it equal? Is it null? No. Then it will search whether it is lesser. Then the next thing which it has to search is whether it is greater. If the number is greater than the root value, right, then it has to go to the right side of the tree. Here it is left side and it has to go to right side if you want to search anything. So that is how a simple pseudocode presents here. How do you search an element inside a binary search tree? So the next part which you have to keep in consideration is how do you insert element? Again, the searching follows the same manner. Likewise, the insertion will also follow some similar manner. So in order to insert anything inside to BST, that is binary search tree, what do you do? First, you have to check for the condition again. If node is equal to null, right? If node is equal to null, and then it will return whatever the data it is as it is. If, again, whatever the data which is given, right, by the user is lesser than node, then it will go towards the left side of it. If there's one more condition, the data or the value which is given by the user is greater than the node value, then what it will do, it goes towards the right side and we insert element accordingly as per the conditions it is satisfying, right? So this is about search and insertion. So coming back to deletion, right? Let's see how do you delete an element from the binary search tree. Deleting has 3 different cases to be considered. Case 1, okay? Say for example, you have a tree here which is having certain value, right? I'm just giving a simple example. This is 8. Again, it has to be less. Whatever it is less will be here. Whatever it is greater than will be here. So if you're taking this as an example, right? The case 1, if you want to delete 9, okay? What it is, the case 1 states that directly delete. Need not do anything. Go to that node. If you want to delete 9, get it back and delete, right? Case 2. You have one more condition to consider. So we have to replace something. We have to replace the node with its child. We have to replace the node with its child, whatever it is there accordingly. Say for example, if you want to delete 8, you have to replace 8 with 9 or 6. I think you have to use in order method in order to find which one you have to replace, because 8 has 2 children. Coming up to the third case. Particularly, we have to follow in order method, right? So in order traversal should be followed and we have to check accordingly which one to replace and what to delete, right? Without replacement, we cannot delete and leave that particular node empty. So these are the three cases you have in order to delete an element from a binary search tree. So let's quickly see how do you implement this particular code on Google Colab. Now let's implement the same BST functions in Python on Google Colab. So the first thing which you have to do is you have to initialize a class. So I'm initializing a class called node here, and I'm considering three different elements. One is key. Key is nothing but root, and left and right for the particular tree. And next I'm considering one function, because I told you we'll be using in order to delete something or insert an element, right? So in order function will be used. What is the rules of in order? It should be left, root and right side. So first it has to consider the left side, then it has to go to the root, and then it has to go to the right side of the tree. And then again, in order to insert a node inside the tree, what are the different things you have to consider? You have to consider whether it is null or is it equal to the root node. And you should also consider if the node which you have taken or the value which you have taken is greater than or lesser than as well. If it is greater than, it is going to the left side of the tree. If it is lesser than, obviously it is going to right side, which is not mentioned here. Only one particular condition is taken, that is which is lesser than. If it is lesser than, and it is going for left side. If it is greater than, it is going for right side. So then you have again in order successor defined. That means what happens if you want to replace something, right? You have to know the successor of it. You have to know the child node of that particular node. So in order to find that, we'll be using this particular function. And next, in order to know the leftmost node, we'll be using this particular function, that is current, whatever the position is for the node, how it is traveling towards the left side. So current position, from there we'll be considering the left side of the node. If not, we'll not. If it is not having any node towards the left side of that particular node, right? So we'll not consider that as well. Then deleting a node is done. So what do you do? Deletion, as I told you, you had three different types of cases of deletion. So here we are considering with the help of in order, how do you delete an node, right? So it will be compared. First it will be seen whether it is null or not null. If it is not, then it will go inside the next condition, whether it is checking if the key is, that is the value, root is lesser than the node which you have given. So if it is lesser than, then deletion to takes place towards the left side. If it is greater than, it will go towards the right side. So likewise, it will follow the rules until unless it will delete an element by using in order. So these are the different inputs we have for it. So this is the tree generally. So it starts from 9, 4, 2 and so on and ends with 5. So considering the image of what I taught you, right? How do you write it? Considering the root node, anything towards lesser than the root node towards the left side, anything towards greater than the root node towards the right side. So this, considering this factor, we'll give the input to the program. So quickly, if we run this program, let's check out how does it display. So in order traversal, how it happens, it will go from 2 to 4, again 5, 7, 8 and so on up to 15. If you want to delete something, what you want to delete? I have to delete 11. So where is 11? 11 is like 11 is having a successor of 15. So what does it do? 11 eliminates in the place of 11, 15 will be there. So we'll replace with the help of in order method. What is the flow of in order? That is left, root and right. So considering this factor, it will give you the deletion process and replacement for that particular deleted node as well. So that's about binary search tree.
Now let's talk about advantages and disadvantages of binary tree. If you talk about advantages, we can represent data with some relationship, right? So this is the root node, or this is the parent node, and this is the child node. So that relationship, parent-child relationship, is always there. And while you are inserting or searching an element or a node in a binary tree, it is much more efficient as compared to other data structures which we have seen. Now, if you talk about disadvantage, if you want to sort this binary tree, it is much more difficult, right? Because we can either go on the left side. This can be a tree, that means this is a left skew tree, or this can be the scenario wherein we have all the elements on the right side of the node. So this can be another scenario wherein we have this right skewed binary tree. So sorting is difficult and it is not much flexible, right? If you talk about this binary tree, we always have either the two children or one children or no children. There is no flexibility in terms of how you want to store it. Can we store another node on the with this root node? No, that is not the case, right? And we don't follow any restrictions like, okay, we always find this node, that is, if this is a root node, we always find an element which is less than this node on the left side or on the right side, that is the greater element. So that flexibility is not there.
So the next concept is graphs. So graphs are very familiar for us since school days, and we used to do any bar graph or histograms, a pie chart or something like that. But here in data structure also we have graphs which is mathematically oriented, right? It is one of the kind of data structure, so which is always derived from the mathematics concepts. So graph is always a collection of vertices and edges. So vertices will be represented with the help of V, capital V or small v, and edges will be represented with the help of capital E or small e. And it will always define the relationship. We will be having certain connections between the edges or the vertices or the node to node connections. So there are different types of graphs for different types of projects or computer science concepts. So here I'm just giving you a simple example of a graph in order to teach you what is vertices and what is edges, right? So I'll write down a simple graph which is having certain connections. Right. So here what you can consider, vertices are A, B, D and C. So whatever the nodes you have, those are the vertices. How do you count the edges? So here I have just connected it together, so it is forming a loop kind of element. So if you consider some other graph also, you can have a clarity on edges, right? I am cutting down this. So if you want to know what is an edge, so edge forms between A and B. Again, you have an edge from A and D, right? If you want to implement that in this graph as well, you can take it as A to B as one edge and B to C as one more edge and C to D as another edge, right? So edges are calculated between the connection between the two different vertices. This is the basic introduction towards the graph data structure, and we'll be seeing implementation in Python as well. So there is a graph class, and you have to have a constructor in order to know the edges, in order to store the vertices, and you have to store the graph weight as well. So we have to allocate certain memory in the format of list in Python for that, and then we are adding edges to the directed graph. So I told you there are different types of graphs. It is directed, weighted graphs, and it is graph in loop. So everything will be considered, but here I'm considering for directed graph. And then you have the edges where you have sources and destination. That is, if it is A and B, A is a source and B is a destination. So that is how edges are calculated. It is a combination of two different vertices. So then you have a function in order to print the list. Whatever the list is there in graph, we cannot draw as it is, as we draw to understand the graph, but we have to put that in a sequential order or in the form of list. So that particular representation is taken care with the help of print graph function. And then we have the input. So input is already given here. So the edges is being directed. So 0 to 1, 1 to 2 and 2 to 0, 2 to 1, 3 to 2 and 4 to 5 and 5 to 4. So the edges had been connected. It is being directed from which vertex to another vertex. It has been told here with the help of edges. And then what are the different vertices we have? We have the labeling from 0 to 5. That means we have 6 different vertices. And then we have to construct the graph. How do you construct a graph? With the help of this particular statement. That is, graph is combination of edges and the number of vertices we have. And we are finally printing the graph. And it goes like this. So first it will go from 0 to 1, and then 1 to 2, 2 to again 0, again 3 to 2, 4 to 5, 5 to 4. You have one more extension here, that is 2 to 1. So this is how the graph looks like in Python. After knowing what is breadth first search, right, we'll implement that particular BFS algorithm in Python as well. So before that, let's quickly see what is this algorithm all about. In general, breadth first search will always traverse the nodes which is from level 1 to level 2 to level 3. It will not leave any single level. So for example, if you have a node, right, a root node followed by sub nodes, so you will traverse level wise, not node wise. So for example, say you have 10 here and you have 8, 9. This is level 1. Sometimes it is also called as level 0 as well, right? Again you have one more level, 11. This is 12. Again here this is 13 and this is 14, right? You have this graph and it goes level wise. This is level 2, or it can also be level 1. If you start with 0, it comes with 1. If you start with 1, it will go to 2. So first it will start with 10, it will finish 8, it will finish 9, again it will come back to 11 and then 12. Again here it will come back to 3 and then 4. So level wise it will try to finish the traversing in BFS algorithm. So as it is written here, that is, neighboring nodes in a single level are traversed first, and then the next node or next level will be put up into consideration. Else it will not go to the next level until unless it is traversed for every node in that particular level. So let's quickly see how does this BFS algorithm will work in Python. So here you have BFS, graph and route. So route is the main thing where it will start traversal. At least once it will visit each and every node according to the level wise is the thing you have to consider. So visited, how many times it is visited and where it is visited in the queue. Actually, you can't define a graph as we write it as an example. So we put up with the help of numbers. You could see here 0 is the level 1. Again you have next level 2 and 3, right? So it will traverse all the nodes, that is 1, 2, 3. There are only 3 nodes here, that is 3 vertices. It will travel to all the vertex and it will finish. So let me quickly run this program and see how does it. Yeah, that is how it is. Starts from 0, it will go to 1, then it will go to 2, and then it will reach out 3. So it will traverse accordingly one after the other and visits each node one at a time. So breadth first search will visit according to the level of the graph, and it will always have the nodes visited before finishing the traversal, right? So that's about breadth first search in Python. After learning what is depth first search, we have to implement the same algorithm in Python as well. So let's quickly see what is depth first search before implementing the same, right? So this algorithm will always traverse between nodes towards the depth of the tree. That means first node, if it is having 2, 3 and 4 levels, first it will complete the levels according to the depth wise. It will not go towards horizontal manner, it will just work in the vertical manner. For example, I'll just write a tree or a graph to show you how does this work. It is a very general example. So here it has the value 10, and again it has 2 different subtrees, subnodes, that is 8 and 7. So again what it will happen, anything it is there towards the depth, for example here, this manner. First it will go to 10, then 7, then 6. It will backtrack and come back to 8. So it will first always consider the nodes which is towards the vertical side, which is towards the depth of the particular tree or graph. So hope that was clear, and let's quickly hop into IDE to see how does DFS algorithm will work in Python. So here is the program for DFS in Python. So as I told you, it will visit each and every node towards the depth of the particular graph or tree. So it will not go towards neighboring nodes, or it will not go parallelly, it will not traverse. It is only the vertical traverse that will happen. So again, you have a starting position, you have a graph which is declared. You also have to have a count of visiting nodes. So you should not repeatedly visit that particular vertex or the node again and again, right? So visited is none as of now, because we'll be starting to visit the graph, and then visiting nodes is been set to 0 initially. Then we'll start, and then it will proceed one vertex to another vertex in horizontal manner. Say for example, giving graphs in coding is different than we write. It is very easy for us to just write it down accordingly with levels mentioning, and also how was the flow of the tree or the graph. But here you have to mention the nodes, right? In 0, where it is having that particular connection. From 0 you have connection to 1 and 2. Again from 1 you have connection to 0, 3 and 4. Then 2 has connection to 0, 3 has connection to 1, and 4 has connection to 2 and 3. That means it is telling you the flow of the graph, how it is connected, rather than we writing. It's very pictorial and representation which is understandable by everyone. But here you have to give it node wise. All these numbers are the nodes or the vertices. So let me quickly run this and check. Yes, it is going towards the depth of the graph, that is 0 first, and then it is going to 2, then 1, 3 and 4. So the graph is 0, 1, 2, 3, 4. So it is having the vertex which is starting from 0, ending from 4, but the traversal will happen from 0 to 2, then 1, then 3, and then it will go to 4. So this is about depth first search in Python.
Hash tables is our next concept. So, what is hash table? Before learning that, let's see what is hashing, right? So, hashing plays a very important role generally in order to compress data, in order to have encrypted. It's not exact encryption, it is just changing the values into its relevant keys. Okay, so cryptology we say. So that is also there, and database indexing can also be made with the help of hash tables. So let's quickly see what is hashing function and what is hash table and so on, right? Coming up to the first point here. So what they define as hashing is a black box that takes a key as input and provides hash value as output. I'll give you a simple real-time example. You are an employee in an organization, right? So when it is an organization, there are more than 50 people as well. There are more than 500 people as well. There are more than thousands of people as well. What is the guarantee that your name is not repeated with initial? There might be other person who is having name exactly like you. For example, there is a person called Sham R. Okay, there are two different people or three different people in the same name, same initial, everything. So how do you define them? The only key that will give them the unique identity is the employee ID, right? You agree with me? Employee ID is different for different individual. On the basis of that employee key itself, people will recognize in case if they want to do any communication or it is necessary for any documentation. So they use employee ID. So employee ID acts as a real-time example for keying, and this is a hashing technique. For example, the first person, Sham R, is assigned with the employee ID 2. So anywhere, anytime, if they ask for employee 2, that is always Sham R, right? People might be confused listening to the name, but this will be clear. Employee ID will be clear. So it will be one way function generally. So there is no reverse, right? We are creating an employee ID for one single employee. Then employee is not doing anything back to us. So it is a one way function. Generally, a value is converted to its relevant number or integers or a key. That's it. So then a good hashing function has minimalistic collision. So the word collision, what is collision? Having two different numbers with same hash key is called collision, right? So I'll let you know what is collision further. So a hash table is a data structure that uses pair of keys and values. I've already told you every value, for example, Sham is a value and employee ID is a key, right? It is stored in a hash table. Just like database table, we also have hash table. It has the key and value pair. That's it. Say for example, it can be represented this way. So the key is employee ID and the value is the name of the employee. So this forms a hash table. So it will also have a hash key, which is hash indexing. The indexing will also be present. I'll show you with a simple example later. So it will be always one of its kind. That means it is having a unique key. I told you one of its kind is nothing but unique key, which is created by hash function. Now the question is, what is hash function? If you can see the formula here, h of k is equal to k1 modulo m. So what is it? Hk represents the function of hash, that is hash function. And there is a mathematical formula for us in order to solve to get a hash function, to get a hash key generated, that is k1 modulo m. So here m is the size of the list. I'll let you know with an example. K1 is the value we want to store. What we want to store, that is K1, and value we want to calculate the key for is this particular K inside the hash function. So this is a brief introduction towards hashing and hash tables and also hash functions. Let's quickly jump on to the real-time example where I can show you how to implement this particular formula. Now let's implement hashing technique with a simple example. So here I'm taking a list. Okay, it is having it indexes 0, 1, 2, and you want to store, it is a size of 3. Obviously you want to store certain values inside that, right? Say for example you want to store 1, 2, 3. Okay, by using the formula h of k is equal to k1 modulo m. This is the standard formula which we are using. Let's see how do we calculate the hash table contents. So let's quickly have the first one. For the value 1, you want to store 1, 2, 3 inside this particular list which is indexed as 0, 1, 2. Okay, so h of 1, the value which you want to store, then you have to take the value and then modulo by what is the total number we have, the size 3, right? If you do this modulation, then you will get the answer 1. So it says the value 1 to be stored in index 1, right? Then repeating for the value 2, right? 2 modulo 3. The answer is 2. It says 2 should be stored in the index 2. Coming up to the next one, right? So 3 modulo 3 is equal to 0. Indexing 0, the value 3 should be stored. So we have got value 3, the index hash table index 3, and value 1 is hash table index 1, value 2 has hash table index 2. So this is how you implement hashing function with the help of particular mathematical formula, right? So this is the table which is formed. Let's implement this particular example in Python programming with the same concept. It's very simple. Let's quickly switch on to the IDE now. Here you can find this particular program. Whatever I thought as an example is put up into a program. There is no other difference. Okay, so first we have creating a function that is called hashing underscore key. It is having two different parameters, that is key comma m. Okay, the same formula what we used is being implemented here, no change. So next, return key modulo m, right? So modulus operation is performed on the value which you want to store. Then the size of the hash table. The size of the hash table there in the example was 3. Here I'm taking it as 8. So if you apply that formula, you will get an answer where it is stored what. Let's quickly check the output for the same now. Here you can see the hash value 4 is 4 and 3 is 3, 10 is 2, 12 is 4, 8 is 0. So this is how we try to give the values and the key pairs in hashing technique. Hope this was clear.
Algorithms. Let's try to understand what is an algorithm. It is a step-by-step approach to solve a particular problem. If there is a problem, what is the things that you are going to take care of? So the solution that you give should be crisp, right? It should be exactly what is required, right? If a problem is about swapping two numbers, you should be able to swap two numbers and with the most efficient approach. And when you define an algorithm or when you are writing an algorithm, it should be understood by a non-technical person, right? There should be no such language dependency in your algorithm, right? So this is what an algorithm is, a step-by-step approach to solve a particular problem. Your problem can be complex or it can be an easy problem. It is free from programming language. There are multiple possible algorithms to solve a given problem. Let's suppose I told you to swap two numbers, right? Now, one algorithm is wherein you can go ahead and create one temporary variable and then swap them. The another approach is that you're going to use addition and subtraction operators to solve the same. You're going to use these operators and you can solve this problem of swapping two numbers, right? Which one do you think is the efficient approach? Obviously, here you're using an extra variable and here you're not using any extra variable. So this seems to be a better approach. And obviously, it should be understood by a non-technical person. You should not be using language dependency code, like you should not use any language agnostic code, right? So it should be language independent. So let's see what is an algorithm analysis. This is again a step-by-step approach to solve a particular problem. It helps us identify which algorithm is optimal. Okay, this is the analysis part of algorithm, right? Herein, let's suppose I told you to swap. It helps us to understand the trade-off between time and space complexity, right? So there should be always, you should be able to understand the difference between time complexity and space complexity. And depending on that, you should be able to do a trade-off as well. Now, when I mean trade-off, you should be able to depict that are you going to keep your time complexity efficient, or are you going to use your time efficiently, or are you going to save your space? So let's suppose you are given an example, right? Let me give you an example. So you are given an example, you are given an array, and in that array you want to search an element. Now the first approach is that you will go and search one by one, right? You will go here, you will iterate through here and here and here. You try to search an element, right? Let's suppose you are searching for 4. In the worst case, you are traversing a big O of n time, right? And in the best case, you are traversing big O of 1 time. This is the best case and this is the worst case, right? So these are the two cases. But this code in itself, whenever you are traversing in a linear fashion, is inefficient, right? And if you're trying to search for an element using different approach, let's suppose you are using a binary search and then you are trying to search an element, obviously your time complexity will reduce. The best case will again remain big O of 1, but it will reduce to big O of log n. Now there are certain parameters, or depending on these parameters you can define the best, worst and average case of a given problem. So now there are different types of algorithmic analysis. that those are best case, average case, and worst case. Okay, so the best case is obviously when you are searching for an element in an array of, let's suppose, 100 size, right, or 1000 size. The best case is that the first element that you look, if you're talking about what, linear search. Okay, best case scenario is that the element that you're trying to search is the first element, right? Done. This is your best case, and it requires constant amount of time. Now if you talk about average case, it will be somewhere around the middle, right? About 1000 divided by 2, or you can say big O of n divided by 2. Since we are neglecting, we do not take care of these constant terms, or we can negotiate, or we can neglect these constant terms, because as soon as our input is increased, right, let's suppose right now we are talking about million, thousand elements, we are talking about 10 billion elements. At that time, dividing it by 2 still is same. Okay, not same, but it is, it can be ignored, because as soon as we are increasing our n, let's suppose, to 10 crore or more than 10 billion, okay, 10 100 billion is the input size, right? At that time, dividing by 2, still it is greater than what we can do if we have something around log n. Okay, so obviously the average case is still big O of n. Now when you talk about worst case, the element is found at the end, or it is not even found in the array. You're traversing each and every element in the array, and still you were not able to find the element. So this is the worst case. Okay, now the worst case is always taken into consideration, because this is the maximum resource that you require. Okay, when you talk about time complexity or space complexity, right? So time and space, right? So you always talk about worst case scenario, right? And you always deduce your time and space complexities based on worst case. It is computed because the analysis, as it dictates the maximum resource requirements. So worst case helps us to find what are the maximum resources that this is going to take. Okay, so we keep track of those things and we allocate resources in such manner. So we always talk about worst case. Now let me give you an example of linear and binary search. So in linear search, right, we always talk about it, and in binary search, the space complexity of both these algorithms is constant in worst case, right? And if you talk about the best cases of linear and binary search, it is again constant, right? And it is again same. Okay, now when you talk about, we go off on, now when you talk about the worst case scenario, right, and this is what helps us to differentiate between binary and linear search. The worst case scenario. The worst case scenario for linear search is big O of n, wherein for binary search is big O of log n. Now let's suppose there are 8 inputs. You're going to traverse 8 times in it, in this linear search. But if you have this log 8 to the base 2 value, it reduces, or you can reduce it to 3 into log 2 to the base 2, which is 3 times. So in this, you are only iterating 3 times. In this, you are iterating 8 times. Now, as you can see, the input is very low or very less. That means there are only 8 elements. As soon as what our input, our n, or the number of elements in the array grows, this size of these iterations become substantial, and that is for the same reason we always talk about worst case scenario. Okay, now let's talk about time complexity. It determines the total number of unit operations to be undertaken to solve a particular problem. Right? Let's suppose, let me take an example of number of iterations. Like, so if you are able to search an element in a single unit of operation, then it is termed to be a constant operation. And if you're doing the same for number of inputs, that let's suppose there are n elements and you're traversing to find a particular element, you are traversing n times, so it's termed to be a big O of n. So to solve a particular problem, you determine the number of unit operations. Now, unit operation is an operation that is independent and it can be broken down into simpler operations. It is independent of architecture. It is computed on the basis of algorithm itself. You have an algorithm in place, and based on that, you compute the time complexity of each and every step, right? If there is a loop, what will happen? If there's a if condition, what will happen? If there's a while loop, what will happen? It's high priority critical in optimal algorithm selection. Now, depending on this time complexity, you can determine whether you want to go with a particular algorithm or not. Because let's suppose you're trying to search an algorithm, right? You can have two options, right? You can use a binary search or you can use a linear search. Now, depending upon the time complexity, binary search works much more faster as compared to linear search. It works in order n and it works in big of n. So time complexity plays a major role, and there is always a trade-off between the time and space. And in this session, we will be covering both of these things. Okay. So now let's take an example and let's try to determine the time complexity of that particular example. Now let's suppose you are given a for loop, and in that for loop, you are iterating from 0 to n, right? Where n is I is less than n, and then you're doing the plus plus. Now you're doing some work in it, okay? Now since you're traversing from 0 to n, now this is a scenario wherein this will be operated or this will work. The number of unit operations that are present in this for loop is big O of n. Now similarly, there is another for loop in the same program which is operating from 0 to n, okay? And then the same thing, there's a nested for loop in it, and therein what you are doing, you are traversing from 0 to what, let's suppose this is traversed, n is 8, right? N is equal to 8, and in this for loop you are traversing 8 times, and in this while loop you are traversing 3 times, right? Let's suppose you are multiplying every time by 2, okay? So now in this for loop, the nested for loop, the time complexity of the same is n log n. Now, why it is n log n? Because if you observe carefully, number of operations that I told you is 8. So outer loop is working 8 times and the inner loop is working log 2 to the base 8, that is 3 times. So now what is the scenario? What will be the total time complexity? It will be big O of n plus big O of n log n. Okay, this will be the time complexity. Now what is happening over here? This is a scenario wherein what is happening? It is happening m into n. That means you are multiplying big O of n, that is the nest for the nested one. Okay, into big O of log n. So you're multiplying it. Whenever you have a situation wherein you have a for loop inside a for loop, therein you will multiply the time complexities. Now you have a for loop outside and then you have this nested for loop. For this nested for loop, you have n into log n, right? And for this, you have what? Big O of n. Now this is a scenario wherein what happens? M plus n. And in this, you will always take into the consideration the maximum number of resources that are there, so that one for loop will take. So in this you're taking only n resources, or this is the time complexity of this is n, and in this you're taking n log n. So obviously this is greater, right? So you always say that the time complexity of that particular problem will be n log n, because you're neglecting these smaller terms. As soon as our input is increased, these terms will be neglected and they will not be that much significant while you're allocating resources. Now, what about the space complexity? It determines the total space to be allocated in order to solve a particular problem. Now, whenever you are using any extra space in the algorithm, while you are implementing it, that is termed to be as space complexity. It can be in the form of arrays, that extra array that you have used to solve a problem, or an extra linked list that you have used to solve a problem, or a stack or a queue, right? It involves memory of the computer, right? You're involving memory, right? You're taking something extra, right, to solve a particular problem. Let's talk about merge sort. Therein you take extra memory, and in worst case you can take big O of n extra memory. That means the number of elements that are present in the array, you're taking the same array as an auxiliary memory, that extra memory, right? It's low priority critical in optimal algorithm selection. When you talk about space complexity, we try to avoid any extra space. We try to solve it with minimal space, right? so the we don't use any of these auxiliary memories. Okay, now let me take an example of a merge sort, wherein in that merge sort, every time you create a left array for the left side and the right side, every time you create these subarrays and then you calculate and then you divide them into further and further unless there is no possible division, and then you start merging them. So again, this is a condition or this is a scenario wherein you are using extra memory of big O of n. Now if you talk about simpler examples, let's suppose you are trying to uh, change the positions of even and odd numbers, right? So let's suppose you have these indexes right in the array and you have some values, let's suppose 10, 20, 15, 20, 15, and 10. Let's suppose these are the values, right? Now you want to use or you want to find out the frequency of these numbers. So you will be using another array, and in that array what you will be doing, let's suppose you are picking up this 10 and you are storing it in this. Now you'll be checking, okay, if this is already present, pick up the counter and keep track of how many times this 10 occurred. Now this will work only for when you're trying to search 10 throughout the array. I'm taking a naive example, right? So I'm taking this example and I'm trying to search 10 and I'm trying to calculate how many times it has occurred. So you place a 10 in this array, and then what you're doing, you will just iterate through the array and then keep a track of this, how many times this has occurred, and keep incrementing your counter, right? So now you're using an extra space, right? Now even if this example is not understood, let me take another example. Let's suppose you're using a recursion, right? Now you might be thinking, okay, internally, you are not using any extra space, but what happens in recursion? Every time a recursion is there, that means function calling itself, an activation record is created and a stack is used internally, wherein your main function will be there and the number of function calls, right? The function calling itself, function calling itself, function calling itself we will be pushing it on the stack, and once you have returned, then we will be popping it out, right? So internally you are using an extra memory, and it depends on from program to program. Are you using big O of n, or are you using log n space? But internally, recursion uses extra memory. So an auxiliary memory, or you can say that extra memory, is used while you are using recursion. So that is why we try to avoid recursive problems, and we try to solve our problems using iteration. So, which is obviously that we are not using any auxiliary memory, although it is internally, but still recursion uses extra memory, and that thing is taken into consideration. Now, you might be thinking, okay, now should we use or should we save space or should we use less time? Should we go for time efficient algorithm or space efficient algorithm? Now, there is always a trade off between space and time. So, in some problems, they might ask you to save or to write an efficient algorithm, keeping the time into consideration that you don't have to use extra time. But in some, they might say, okay, you can use extra space, but time should be efficient. Or in some cases, they say you use as much time as you want, but space should be less. So that is also there. So there's always a trade-off between both of these things.
Now let's see how we can find the time and space complexity of any given code or algorithm. So basically here I'm going to give you some tips and tricks when it comes to finding the time complexity of any given code, or for that matter even space complexity for any given code. So what happens in any programming language? There are certain constructs or certain programming concepts which we use. Like for example, conditional loops, conditional statements, then no looping constructs. So nested loops. So how does time complexity is found or in these cases? And also the space complexity, like what is the total space being taken while executing that particular code? No space, when I talk about how many variable at a time resides in memory, that decides the space complexity. Okay, and time complexity is again the total time taken, maybe in terms of n we calculate. If suppose n is a number of input, so if n or 2 is a number of input, so for 2 input, what is the total time taken for each code to run or to execute? So we'll assume there are n inputs, and for n given input, how many times the particular code runs, that decides your time complexity. Okay, so I'm going to talk about few small tips and tricks about finding space and time complexity to you, starting from the first aspect, that is your looping constructs. Okay, so if I talk about loop, the very frequently used loop is your for loop. So let's see if int I is equal to 0 and it goes till I less than n and I plus plus, and then there is some statement here, maybe x is equal to y plus z. Let assume that all these variables were declared before in any programming language for that matter. Okay, so what will, if I tell you that, okay, find out the time complexity, what time this complete code is going to take if n is the input. Okay, what you will do is, okay, if I assume there is no the number of input is only one, so the for loop will run only one time and this complete statement will run only one time. So time taken is only 1 unit of time, right? And what will be the space taken that time? Only this variable, these two variables will be stored at a time in the memory, right? So no matter what is the input, every time you need only two variables at a time to be stored there in memory. And when the sum is done, that is discarded, and then only there is only one variable then after that, right? So space complexity is constant here, right? Only 1 unit of space is taken because every time, no matter how much is the input, every time that same two variables occupies the space. So space here complexity will be O of 1, but time complexity will be, for one element, this for loop will run only one time. So time complexity will be also 1 unit of time it is going to take. For two no elements, this for loop will run two times. Similarly, for n elements, this for loop is going to run n times. So the statement will be executed how many times? N times. So we can say that it takes O of n unit of time. Okay, big O of n unit of time it takes to run the code. Okay, now coming to the another thing is your nested loops. Okay, so guys, whenever you find the smaller codes, you can fragment together and find out the overall time complexity for any larger code. So talking about nested loop. So nested loop, how it runs? For is, int, suppose I is equal to 0, I less than n, I plus plus, and then inside this there is one more for loop. Okay, maybe int j of 0 to j less than n, j plus plus, and then this there is a statement, maybe same statement I'm writing, int x is equal to y plus z, and then this closes the bracket. Now, how many times this code will run? Again, space complexity is going to be O of 1, guys, because you can see the actual operation being done is only this, and every time it requires 2 unit of space. So it's constant throughout the execution. It doesn't depend on the number of inputs. So it is O of 1, the constant time, the constant space. Talking about time complexity. So you see here, for each value of I, j runs from 0 to n. So if value of I is 1, or you can say value of I is 0, then this runs from 0 to n, that is n times. If value of I is 1, then also this runs from 0 to n times. If value of I is 2, then also this runs from 0 to n for n times. Similarly, so on. Okay. It means if this goes from 0 to n, this will also go from, for each value of I, it is going to go from 0 to n. 1 to n, because it's less than, not less than, equal to. Or you can say 0 to n minus 1. Right? It means what? For I value as 0, this code runs n times. Then I value of 1, this code runs n times. I value of n, this code will run n into n times. Yes or no? Like, are you getting my point? So this is mathematical concept here. So n into n, that is the time complexity for this will be O of n square. Right? Now, coming to the third type of a concept, if else loop, conditional statement. Okay. So if says if, and there is some statement over here. Okay, then it says else, and then some statement over here. Suppose the time complexity of this is O of n, and time complexity of this is O of n square. Which will be the final time complexity out of this complete if else loop? Final time complexity will be whichever part of either if or else, whichever part has less time complexity, which is taking less time to execute. If this is taking n times to execute, this is taking n square times to execute, definitely n is smaller, n is lesser value than n square. So the overall time complexity for out of this if else loop will be O of n. Is it clear? Right. Okay. So this is your these are the three constructs. Now let's see if there are sequential statements. Like definitely in any given program, there's not only just for loop or just a nested for loop or if else loop. There are other statements also along with these loops. So in that case, how the time complexity or space complexity is taken care. Again, guys, here I'm not told about space complexity in this if else loop. So space complexity again depends on what statement is being over here. Like at a given point of time, how much is the space being occupied in memory to execute that statement? Does that space allotment depends on the number of input? Then how it depends on number of input will be your space complexity. Otherwise, it always remains constant. Fine. Let's see the fourth aspects where there are other statements also along with these looping constructs and conditional statements in a given program or a code. So now the fourth condition which I'm going to see here is that suppose there is a statement, x is equal to y plus z. Okay. Then there is a for loop over here. Then there is maybe do while loop. So it does something and then while loop is there. Okay. Then there is again maybe some statement some statement here, maybe a is equal to a plus plus. Fine. Now let's see so what you'll do is you'll start from the beginning of the code. So first code here takes how much time? Is it dependent on the input? No, every time it's going to be y plus z only. No matter input is 1, 2, 3 or whatever. So it is constant time. Suppose this for loop, whatever is the for loop over here, this takes time complexity of O of n. Okay. Then there is this do while loop, which also takes the time complexity of O of n. Okay. Then there is this a is equal to a plus plus statement, which takes constant time. Okay. Then in this case, what will be the final time complexity? So the final time complexity is going to be the summation of all, that is 1 plus n plus n plus 1. Okay. And this will be your so constants are always removed because it doesn't play much role, because constant is going to be always taking constant time. So that doesn't affect our performance, right, of the code. So we'll remove those n and n. So n plus n will be 2 of n, right? Again, this is a constant which will be eliminated and this will be just n, right? So the total time complexity will be O of n. Suppose out of this, one of the time complexity would have been O of n square. Correct. So the time complexity here, suppose this is, so in that case, it will be 0, 1 plus n square plus 1. Correct. So O constants will be again removed. It will be n square plus n. Right. Again, you see here, no, compared to n square, n is a smaller value. Right. So our main focus should be on the bigger values because this becomes negligible in front of this one. So our total time complexity will be O of n square only. Getting it? So that's how the time and space complexity is calculated for any given code. Basically, time complexity, some tips and tricks I gave you here, which you can use to calculate. Now, simply by just looking at the code, you can make out what is the time complexity for that given code. There are other methods also like Master's theorem, which is properly used for finding the time and space complexity, but that's a time-taking procedure. It's for a full, process or steps which you have to follow. But these tips and tricks will help you quickly find out or verify the time and space complexity of your given code.
Now let's talk about searching algorithms. And the first searching algorithm that we are going to talk about is linear search algorithm. So what is linear search? It helps us to search an element in a linear data structure. Now let's talk about one example wherein we will be searching some element inside the array. So let's suppose this is an array and the elements are 10, 20, 30, 40 and 50. Now if we are trying to search an element that is 50 inside this array, how linear search works is that it checks each and every element that is to be searched, right? That is there in the element array, right? Let's talk about this example here, 50. Now 50 will be compared, right? We'll check, is this 10 equal to 50? No. Is this 20 equal to 50? No. Is this 50 equal to 30? Is this equal to 40? Is this equal to 50? Yes. So here we were able to do a linear search, right? We were searching for this element inside this array one by one. We compared first with 10, then 20, then 30, and then 40, and finally then with 50. At the end, we were able to find this element in the array in a linear fashion. Now, this is what is termed as linear search. Now, let's talk about linear search algorithm. Since it is a very straightforward, or you can say a brute force algorithm, right? It's a brute force algorithm of finding the element in the array. So this is how it works, right? We have one for loop wherein we will be what iterating through all the elements, that is from 0 to n, and inside that what are we doing? We are looking for the item, that is that element that we want to search, right? Let's suppose this is 50, right? This 50 will be, we were checking if this 50 is equal to the element, that is ARR of I, right? And then if that is the case, if we find out the element in the entire array, we will return its index, right? That is index, right? That I we will return this I. Now there might be the case as well if we are at the end of the array and we have exhausted the last element as well and we were not able to find this 50, right? Let's suppose this is 10, 20, 30, and 40. Now this 50 is not present in the entire array. At that time, what we are going to return is -1. So we will say that, okay, we were not able to find this element whenever we are returning this -1 in this array. And this -1 indicates that we were not able to find that element.
Now we shall see how to implement linear search in Python. So linear search will work with the help of an array here. So what we are doing is we are searching one single element in throughout an array in sequential manner. So this is how linear search will work. So here if you could see, we have array, we have number which one you have to search for, and you have the starting position variable. So in iterations, array will move on and on by searching from one place to another place. The first place to second, second to third, and so on. In total, we have 5 different elements in an array. That means 4 different places, because array starts from 0, 0, 1, 2, 3, 4. So index is of 4 and the elements are of 5. So we have to first take that key search element and we have to compare that particular element to all the elements inside the array, right? So if it is not matching, the array is not matching with the number you are searching, it will throw up an error called element not found. If it is found, it will show you index value where it is, which place of an array it is there. So let me quickly run the program for you. So I am trying to search the element 1, right? So the element 1 is in index position 3, 0, 1, 2, and 3. So x is the variable which is used in order to find which number it will just act as a key. X will act as a key. You can change this and check if you want to search for 8, for example. It is not at all there in the array. So it will say element not found. If you want to search 2, for example, the answer should be 0, right? Let's check. Right. So index value is 0. It is situated in the first place of an array. If you want to search for 9, it is at the last place. So it's at 4, right? So this is how the value which you want to search is always compared with all the elements sequentially one after the other. So for example, 9 is compared with 2, it's not matching, then it will go to the next one. 9 is compared with 4, it is not matching, and 0 again compared with 1, not matching, it will go to the ninth place where it is situated, right? It will compare the elements sequentially. So this is about linear search in Python.
Now let's talk about the time complexity of linear search. Now, if you observe carefully, let's try to understand this best case, right? So now if you are looking for the element, and let's suppose these are the elements in the array. Now, let's suppose in best case, what can happen? You're looking for 10 and 10 is the first element in the array. Now, how many iteration did it require to find you the 10? None, right? The constant time, right? Only one single unit operation was done and you were able to find this 10. So this is the best case time complexity where the element that you're trying to find is the first element that you search, right? In this case, you were looking for 10 and 10 is the first element. So this is your best case. Now, what about the average case and the worst case? Now, let's suppose average case is that you were looking for an element which is at the middle point, right? Let me just see. 0, 1, 2, 3, 4. Now, or you can put another and you're looking for 60. Now, in this case, or you can just skip it, okay? No need to add one more. Okay, so now you're looking for an element which is somewhere around in the middle. Okay, in this case, you're looking for 30. Okay, so now if you observe, you are only iterating half of the elements, that is 5 by 2, which is nothing by n by 2, since constants doesn't play in do not play any role when you're talking about time complexity. So that is why average case still boils down to big O of n. Now, what happens in worst case? You're looking for an element that is 50 and which is present at the end of the array. Or in the worst case, you're looking for something that is not present in the array, that is 60, let's suppose. And in that case, you will still iterate through the entire array. And that is why the worst case time complexity in that case will be big O of n, because you are iterating through the entire array and that element was not found. You're looking for 60 and that is not present there. So you're iterating through the entire array, that is n operations are done. So that is why it boils down to big O of n. Now let's talk about the space complexity of linear search. When we are trying to find the element in the array, that is 10, 20, 30, and 40 and 50, we were not using any extra memory, right? We were not using any auxiliary memory, that is what we mean by auxiliary memory or extra memory, in order to find that element. We were just looping around these elements one by one, and we were doing it on the same array that we were given, right? Since we are not using any auxiliary memory, that can be in the form of what? A stack, a linked list, or an array, or a string, or a queue. We are not using these auxiliary memories because they are not required, right? We are searching for an element in this particular array that was given to us, right? So the space complexity of linear search is constant, right? We were able to find it in a constant amount of space. Okay, we are not using any extra space. Now let's try to understand binary search algorithm. What is binary search? So binary search is one of the searching techniques, right? Like we saw in linear search, wherein the time complexity of linear search was big O of n, right? We were iterating through all the elements, and now this is a much more efficient algorithm as compared to linear search. Now again, why do we need searching is the thing that, let's suppose if you have a given set of elements and you want to search if that element is present in your array or not, that time, right, we can use either linear search or binary search. Now binary search is much more efficient and it is used on a sorted array, or it can be used on an array wherein some order is maintained, because based on that order we will divide our array, right? It is a searching algorithm is which follows the divide and conquer strategy, right? Let's suppose this is our array, and now since it will be divided in such a way that we can neglect one part of it, right? We will be dividing and then conquering. That means we will be then searching for our element. Now, let's suppose we are looking for something that is, now let's take an example wherein this array is written, or the elements contained in this array are in such a way that we if we skip this part, or left hand side will be skipped or the right hand sides can be skipped in such a way that they don't affect our output. So every time in linear search, our search space is reduced unless and until we find that element or the array is exhausted. Okay, so our search space is reduced to half in every iteration. So this is what a binary search is. We'll look for an element in such a way that every time we are neglecting half portion of the array. And let's take an example when we have this entire array. So first half, that means if four elements, eight, if there are eight elements, four on this side, four on this side, these four will be neglected. Then we have two on this side, two on this side, these two will be neglected. Then one on this side, one on this side, then this one will be neglected until unless and until we find that element or the entire array is exhausted, right? So this is how your binary search works. Now let's try to understand binary search algorithm. So first we are going to understand the iterative approach and then we are going to understand the recursive approach. So iterative, as the name suggests, we are going to use for loops, right? We will start with a for loop and it will iterate and we will iterate unless and until the beginning is less than the end, right? So because we will be updating our both beginning in some cases and in some cases we'll update our end. Now, what happens? Now, since we know that in this iterative approach or in this binary search, it doesn't depend whether we are using iterative approach or recursive approach, the logic will remain same, right? So we will be having this array and it will be in some order so that we can neglect some part of it. It doesn't have to be sorted always. We can still apply binary search even if the array is not sorted, but still some order is there so that we can neglect some part of it, because again, keeping this thing in mind that it follows the paradigm of divide and conquer. So now we have this beginning and end at place and we will always iterate when beginning is less than end, right? So now what happens after that? Now we have this array and now what we will do, let me take new pointers. So this is your beginning and this is your end. So this is your beginning and this is your end. Now you will be taking a new middle index, right? M, let's call it M. And now let's name these things 0, 1, 2, 3, 4. So you will do what? Beginning plus end divided by 2 so that some part of it can be neglected, right? So it will be 2. So your mid is at this position. Now you will see, okay, the element that I'm looking for is, let's suppose, is 50. And the element that I am currently at is 30. So obviously, it will be never from this side. There is no chance that we will be able to find 50 from this side, that is the left hand side, right? First, we will check, okay, is this 30 equal to 50? No. So this will never be executed, right? Then we will check, is my item that is there, is this 30 less than or greater than 50? If it is greater than 50, right? If the element that is, if item that is 50 is greater than 30, right? Which is in this case, our 50, that is the element that we are looking for, the item is this point, is greater than 30. So there is no point that it will be on this side. So we will skip or we will neglect this half portion of the array. So that is why our new beginning is updated. It will be new, it will be middle index plus 1, that is middle index was 2 plus 1, that is this will be our new beginning. So we have smartly skipped the half portion of the array. So now let's rub all of these things and now let's see what happens in the next iteration. Now we'll keep this thing in mind that we are not looping or we are not exceeding this limit, that is beginning should be always less than, or it should be always less than or equal to end. Okay, so this condition should be maintained. And similarly we'll again divide our array and then look for the same things, right? First we will look for the element, then we'll skip some part of it. So this is the iterative approach for binary search, right? Now let's look at the recursive approach or recursive algorithm for the same. So again, beginning, the ground rule will remain same. We'll always iterate, or we will always recursively call binary search unless and until this beginning is less than end. Done. Now what happens? We'll again find middle index, that is beginning plus end divided by 2. Then we will look for the element. These three steps will remain same even if you're using recursive approaches. Now what happens in recursion, right? We again call the function again and again. That is what is recursion. So in this entire tutorial, we will be covering recursion as well, but in the later part of the course. Here you can get a good intuition, or let me give you a brief intuition about how recursion works. So let's suppose this is your activation record. Every time when a recursion is there, an activation record is called. So let's suppose you have these three statements. And let's suppose in your algorithm, you have statement P1, P2, and P3, right? And at P2, you're calling the function again, right? You're calling this function again. So now what happens? An activation record is called. He will check, okay, is this statement executed? Yes. So one will be executed. Is second executed? Yes. So second is executed. But at second, you're calling this function again. So at that time, again, a new activation record is created. Now this third step is left behind, right? Now this will be covered when we come back or return from this function call that we called here. So let's suppose this function was here. Now in here you are returning, right? This function called, let's suppose this is not less than beginning. Beginning is not less than end. So this will be somewhat, this case is relatable, right? This is similar to what we are looking for, right? Let's suppose there is some similar situation wherein beginning is not less than end. At that time you will be returning from this. Right now, once you have returned, you will be then calling this function again, but this time around for this. And let's suppose this time around you are calling this one is executed, step one is executed. Now again, this activation record is called, this activation record is one, and then again this is called, right? This is executed again, this two is called again, a new activation record will be created, and these three steps, the step third will be still left for execution. So now here you return, right? Then it will go back to this step, right? And then once you are done with this, now there are two positions or two possible scenarios where you can return. Either you are returning from this function, just like we have executed this condition and we return, right? Another is that once you are done with this entire activation record, at that time you will also return. Okay, so these are two scenarios. Now you have executed this, there is no step to be executed, it will return. Now this was left behind, this will be executed. Now nothing is to be executed, it will go to the caller, which was this, and finally it will go to the main method wherein we call this at the first place, this function. Okay, so this is how an activation record is created. A stack is maintained. Okay, even if you might be thinking we are not using any extra space, but whenever recursion is there, an extra space that is in the form of stack, that stack is maintained. So you need to keep this thing in mind while you are playing around with space complexity at the time when you're using recursion. Okay, so now with that being said, let's clear our screen and let's see how recursion is called here. So again, now recursively what we will doing, if now we have this mid, right? And let's take an example of an array 0, 1, 2, 3, and 4, 10, 20, 30, 40, and 50. So middle index will be 0 plus 4 divided by 2, that is 2. So this is our middle index, right? So this is 0, this is our beginning, and this is our end, right? So now we are hit here, right? So we again check the 50 that we are looking, this is our item that we are looking for. Okay, so is 50, and this is our middle index, is 30 greater than 50? No, it is not in this case, so this will never be executed. This is not executed as well, right? Now, what about this condition, the else part? Now, what we will be doing, we'll be skipping, since this 30 is less than, we'll be skipping this part and we will focus on middle index plus 1, which is nothing but this. So this will be our new beginning and our process will start moving, right? So now again, then the same thing will happen unless and until this condition is false. Okay, so this is how your binary search works when you're using recursion. So now let's try to understand binary search and let's see its demonstration. Okay, So we are looking for 20, and this is our array, right? 10, 11, 16, 20, and 23. Now this array is sorted, right? So we can apply binary search, okay? Since we can neglect some part of the array based on some conditions, okay? So now our beginning in the first iteration, what is happening? Our beginning is 0, our end is 4, and our middle is this element. Now what we will be looking for is 16 equal to 20. No, it is not. But 16 is less than 20, so we will skip this part. In the next iteration, what happens, we'll be focusing on these three elements, right? That is 20, we will be focusing on this part rather, if we say. We'll focus on this part, right? Focus on this part, okay? So now in the second iteration, what will be happening? Our beginning is updated. Now our new beginning is this point. Our end will remain at its own position. Now we'll find the middle index. So it will be 4 plus 3, that is 3, that is 7, right? And divided by 2, it is 3.5, right? So since this will be truncated, right, the truncation will happen, and the integer that is there, the middle index will be 3. So this is our middle index, right? So you can see middle index is 3. Now, is this element that we're looking for? Yes. So we'll return the index. So we found our element at index 3, and hence we return 3. Because if you observe carefully, it is returning, if the element is found, it is returning the index. So this will be returned, okay? So this is how binary search works.
After knowing what is binary search, we'll implement the same in Python, quickly switching up to the IDE. So, the binary search has 4 different elements and important. The first one is array, the second one is which is the element to search for, which is stored in X, and low and high. Why? Because every array, in order to have the binary search, will be divided into 2 parts, right? It will go accordingly if the key, that means whatever the element you are searching is matching the middle element, it will exit the binary search immediately. If not, it will try to proceed with the search of that particular element in halves of the array. Like it will divide the array into sub arrays, the right and left part, it will try to see and search for that element accordingly as per the key element is, right? So mid is equal to low plus high minus low by 2. So this is the basic formula which we'll be using in order to split the binary array in order to have the search, right? So if array of middle, that means middle element is equal to, that means it is equal to the key element which you are searching, then it will immediately give you the middle element as the searched element. So if else, what happens? If the middle element is lesser than X, what it will do? It will go to the right side of an array. If it is greater than X, it will go to the left side of an array, right? So it will try to search in halves, like sub arrays. Here, if you could see the array, that is 3, 4, 5, 6, 7, and 8 and 9. You have all these elements inside the array. What you have to search is 4. So 4 is the second element. Immediately you can see, but accordingly you have to search as per the binary search rules. What it will do, it will first cut this particular array into 2 halves by using this formula, and then it will compare the key element which you are trying to search with the elements which is already present in an array in order to find. So let me quickly run this. Okay, it is telling the element which you are searching is present in index number 1. That means it is having the count of array index, not on the element. So 0, 1, 2, 3 and so on. So 4 is present in index value 1. So this is how binary search will work in Python.
Now let's talk about the time complexity of binary search. Now, in the best case, now what is the best case? Now let's take an array, and in that array 1, 2, 3, 4 and 5. These are the elements. Now, the best case is that not that if the element, like we saw in linear search, this element, when we are looking to search for this same element, At that time, that was the best case scenario for linear search, right? But in this binary search, the best case scenario is when your middle index is at this location and you're searching 3 in the entire array. So at that time, this will take a constant amount of time, and this is the best case time complexity in that case. Okay. Now, in average case, what happens, right? If you talk about this algorithm, let me just clear out my screen. So it follows a paradigm of divide and conquer. So let's suppose you have 8 elements first in the array. It will be divided into 4 because these 4, or either it can be on the left side or on the right side, will be neglected. And then we deal about these, then we focus on these things, okay? These 4 elements. Again, it will be divided into 2 and 2. Then we will neglect 2 elements. Then 1 and 1. Then again, there will be one of the element can be neglected. So there are 1 and 1. So we focus on this element. So the entire operation will be done, or entire searching will be done in 3 steps, right? Now, if you I take an example, and if I do a log 8 to the base 2, what should be the value of this? Obviously, when I do this can be written as 2 raised power 3, right? And this can be written as 3 into log 2 to the base 2. Now this is 1, and now you get the answer as 3. So this 3 and this 3 are equal. That means if I talk about the worst case time complexity of binary search, it will be somewhere around log n. As we saw in 3 steps, we were able to find the element, and the log n, that means log 8, is the answer of that is also 3. So you get the point, right? So the worst case time complexity of binary search is log n, and same goes for the average case, wherein it will be somewhere around log n divided by 2, neglecting log n divided by 2, neglecting the constant terms. It will be again, or it boils down to big O of log n. Okay. Now let's talk about space complexity of binary search. Now, when you talk about space complexity, right, we only think of auxiliary memories, or you can say that what any extra memory that you guys have used. Since we did not use any extra memory, that can be in the form of array, or it can be in the form of stack, or it can be in the form of queue, or linked list, or even strings, right? Since we never use these extra memories in our implementation, so the space complexity of binary search is big O of 1. That is, it takes a constant amount of space. What is insertion sort? So the question is that what is sorting? So you might be thinking, why do we need these sorting algorithms? So if I told you that you have a bunch of students, right? You have a bunch of students and they each have their roll number. They are not present in a numerical order, or you can say they are not present in some order. I want that order to be maintained. Let's suppose you have 1 to 10 students in those bunch of students, and each are having roll numbers from this range, from 1 to 10. Now some of them are absent, and some of the roll numbers have left the school, but the roll numbers are not changed yet. Now, what I told you, please sort them or arrange them in such a manner so that I can easily understand which roll number is after which, either in ascending or in descending order. Let's suppose 1 is there, 2 is there, then 6 is there, then 8 is there, then 10 is there. So rest of the roll numbers I can easily depict, okay, these are the ones which either are not there or are absent. So in order to do so, we have these sorting algorithms in picture. And one of those sorting algorithms is insertion sort. Now, it is the simplest, easiest, and a brute force sorting algorithm. Now, what do you mean by brute force? Brute force means straightforward, right? In a naive way, it means straightforward. That means you're not considering any efficiency, or you don't care about time complexity or space complexity. You just straight away sort it with the most simpler and naive approach. Okay, in this brute force algorithm, what happens that, let me give you an example, right? Obviously we can sort with the help of this insertion sort algorithm. You can obviously sort either in ascending or in descending order, right? Let's take one example. We all know about the card game right? Wherein you have a bunch of cards, right? Suppose you have a single card that is in your hand, right? And you have a bunch of cards available on the table. Now you start picking those cards one by one. Obviously, the one that is in your hand is sorted, because if I told you to sort a number one, obviously there is only one element in the array or anything, right? In the linked list, I told you to sort it. But if you're having only one element, that is itself sorted, right? You don't need to sort that. Similarly, what happens now, this card is in your hand, right? It's just like playing cards, right? Now you have this one card in your hand and it is obviously sorted. Now what you will do in the next turn, you start picking up one by one from these set of cards that are available on the table. Now let's suppose this is 0, okay? I'm considering these numerical values so that you can understand and you can just connect the dots, right? So what happens, you have the 0 and now you start comparing it. Now we are considering the scenario where you are trying to sort in ascending order, okay? So now let's try to erase these things so that it's easier for you to understand things, okay? So now you have these two elements, right? And now we are considering the case wherein you are trying to sort in ascending. So you check, okay, if 0 is less than 1, yes it is. Now you swap them, okay? Now you have 0 and 1. Now these are the two cards that are present and both of these are sorted. So now insertion sort works in such a manner that you will always have two parts, right? One is the sorted part, obviously, which is in your hand, and one is the unsorted part, which is on this deck, right? So similarly, you will start picking elements, or you can start picking these cards one by one and keep sorting them. Okay. Now this is one simple scenario wherein you can apply what insertion sort. Right. This is the most simpler way one can explain or one can understand you this insertion sort algorithm. Now it is simple, right? Now you start picking these elements and you keep sorting them, and at the end, when all of these elements are exhausted, you will get your sorted array. Now let's try to understand insertion sort algorithm. So in this algorithm, what happens? Obviously, now we know that we will have two parts, right? One is the sorted part and another is the unsorted part, right? So obviously, the one element that is present in your hand, or the element or the card that is in your hand, and there's only one element there, right? The one element in your hand, obviously, that is sorted, right? So we will not consider that first element, and we will start our iteration from the second element, right? Now we understand why we are doing this, that we are starting from 2 to n minus 1 or 2 to n, depending upon the array that we are starting from. Either we can start from 0 index or we can start from 1 index, right? So we always start from element number 2, right? And then what we will do, we'll just store this value inside some temporary variable, and then we will check if that element is less than the element that we have in this sorted part. If that is the case, then we will shift their positions, right? And we will get both. Now we will have two elements in the picture, that is 0 and 1, and both of these will be sorted in ascending order. And then what we will do, we'll consider the rest of the cases, that is starting from 3 to so on to n. Okay, now you might be thinking, okay, how does this thing happen? Let me take an example and let me show you how. Let's consider this array that we have over here, that is index 0. These are all the indexes that we have, and this is our array, that is 23, 10, 16, 11, and 20. So in the first step, we are making partitions. Now this is our sorted part, that is the first element, and this is our unsorted part. Now what we will do in the first iteration, this is our iteration number 1, because this is the case wherein we will start moving from second index, that is first index, if we consider from 0, right? So we consider from second element and so on to n, right? So now in the first iteration, what we will do, we'll compare these two values. Okay, let me just erase everything so that it's easier for you guys. So now we will compare these two. Now obviously 10 is less than 23. What we will do, we'll shift their positions. Now this is your sorted part and this is your unsorted part. Again we will do the same thing, right? So in second iteration, what we will do, here comes 16. Now what we will do, we'll compare it first with 23. Okay, we know now, okay, 16 is less than 23. So now what we will do, we'll swap their positions. So this is 16 and this is 23. Now what will happen? Now 16 will be compared with 10. Obviously, it is not less than 10, so it will remain as at its own position, that is its new position at index 1, right? So this is the second iteration, and after second iteration, this will be your sorted part. As you can see that I have bolded this text, right? Bolded the borders of these two elements and bolded the same for these three elements, because this is the sorted part that we have over here and this is the unsorted part. Now what will happen in the third iteration? That it will check for this number that was there. It is 11. So for 11, what we will do, we'll compare it with what, read this thing. Now we'll take 11 into consideration, and now we'll check it. We'll swap them. Then 11 is here, 23 is here. We'll check them. We'll swap them. 16 is here, 11 is here. We check them. So since 10 is less than 11, so nothing will happen. So in the third iteration, what will happen? We will have 10, 11, 16, and 23. These are all sorted, and we are only left with one element which is unsorted, right? Now in the final iteration, what will happen? That 23, now this 20 will be at its original position, that is here, and rest of the elements will be sorted. Now since we have exhausted all the elements have been exhausted, and we at the final step, that is in iteration 4, we will have this array that is sorted.
After learning what is insertion sort, let's quickly implement the same in Python language. So I'm using Google Colab, whether it is easy for everybody to access Google Colab. So need not install anything. It's right available in the online. So let's quickly switch to that Google Colab IDE for Python. So here you can find insertion sort, the name for the file in Python extension. So with that, we already have this particular program, which is easy for me to explain to you. So here, so we are considering a function called insertion sort, right? So the function is called whenever the data is being passed in order to sort the elements inside the data in ascending order, right? So in order to do that, we have to write a proper function accordingly as insertion sort will work. So how does that work? You have already learned about it. So in order to implement, you have to use a for loop. So for loop has a range. So it will be always checking for the elements inside the array one by one for comparison with the key element, right? So whenever it is finding the key element, it will which is greater than the key element or which is lesser than, it will swap accordingly, right? So we are using while loop in order to do that same work. So we are swapping from the current position where it has been found, which is greater or which is smaller, accordingly we'll swap it, right? So then we have the data which has been given here. So the data is present, that is 52178. So what happens in this particular data is when it passes through this function, every element will be sorted with the help of insertion sort function which we have written here. So first it will compare the elements and it will try to sort in ascending order. Say for example, if you want to do descending order, then you have to change just one single element, that is this key should be greater than array element. That's about it, nothing else, no change. So after that, insertion sort is the function is having the data which is present here. So all these functions will be completed, then we'll be printing the final output. How do you print? Once the function has completed sorting, immediately it will be stored in the variable data itself. So that particular data is being printed after sort elements will be viewed, right? So this is just a print statement, sorted array in ascending order. So if you're doing for descending, you can make it a sorted array in descending order. So let's quickly check how this output look like. So here you have sorted array in ascending order. So that is 1, 2, 5, 7, 8, right? From smaller to the higher number. So let's quickly make a small change here so that it will give us the descending order. Let's try to work on it. Right, if you could see here, key is greater than array element, then you will be getting the descending order, that is 8, 7, 5, 2, 1. So you can change it Likewise. Okay, I didn't change the printing statement, so I'm just changing descending order, right? Run the same. That's been declared. So this is how insertion sort will work in Python. And the code, if you could see, it is very small and quickly it is eliminating all the variable initializations we make, anything and everything. You just want to have the function, pass the data, get it sorted, and the output is done. So this is all about insertion sort in Python.
Now let's talk about insertion sort time complexity. So in the worst case, when all the elements are in haphazard manner and we need to sort them one by one. So obviously we are talking about first the outer loop which runs from 1 to n, and then the inner loop which runs backwards, and in the last first we consider in the first iteration we only consider the zeroth element. Then as we move along, it will be running from n to zeroth element, right? We will be considering the whole n elements. So in that case, the time complexity in the worst case will be order of n squares, because we have two nested loops. That is, one is for loop, and inside that for loop we have that while loop, right? So this is the in the worst case, and it happens also in the average case, where some part or the sorted part is already there, and it is, let's suppose we have 5 4 5 6 7 8, and then we have the unsorted part. So half of the elements are sorted and half of the elements are not sorted, so it will be n square by 2. So we are not considering the case where we talk about constants and we are negotiating the constants, and in that case the average time complexity will be n square, right? But the most important thing that is there in this time complexity is the best case. That means when your elements, that is 5, 6, 7, 8, 9, and 10, when the elements in the array are already sorted, what happens in this case? If you observe, the for loop that runs from 1 to n will be always there. So n is always there. The time complexity, the big O notation, big O of n will be always there. But in this while loop, wherein we were checking for if j is greater than or equal to 0 and if AR of j is less than 10, right? In that case, this will never be executed, because this AR of j less than will always be greater than 10. Why? Because we are talking about this element and we are checking if this 6 is less than 5. No, it is not. If this 7 is less than 6. No, it is not. So this condition will always be false for all the elements. So in nutshell, we are just checking these steps only once in every iteration. So that is for the reason that the whole time complexity in the best case will be big O of n and not big O of n square in the best case. Okay. Now let's talk about insertion sort space complexity. If you have observed in algorithms and in implementation, we never talked about any auxiliary memory, right? We were not using any extra space either in the form of array, linked list, stack, queue, or anything, right? So that is for the reason the space complexity of insertion sort is big O of 1, that is constant amount of space. Now let's talk about insertion sort analysis, wherein we will be analyzing comparisons, number of swaps, stable or unstable, in place or out place. So first let's talk about number of comparisons required. In this we will talk about two scenarios, wherein we will talk about worst case and average case. In worst case, the number of comparisons required is n square by 2. Now, if you talk about average case scenario, it is n square by 4, which is twice as much as this, right? It is 2 times. If you talk about number of swaps that are required in insertion sort, in again we will talk about two scenarios, average and worst case. In average case, it is n square by 8, and in worst case it is n square by 4. These are the number of swaps required. And if you want to check those, if these statements hold or not, if these equations hold or not, you can always take an example wherein you will be considering both the cases, even as well as odd. So take an example and run through it. Now, if you talk about stability of insertion sort, it is a stable algorithm. What do you mean by stable? So if you have an array which contains 1, 3, 1 dash, and 5, in this array, the relative position of these two ones, that is this one and this one, let me change the color and let me show you. The relative positions of this one and this one will remain intact. What do you mean by this thing? That whenever you are sorting it, you can sort it in two different ways, right? This is also sorted and this is also sorted. That means you can either have 1 dash 3 and 5, or you can have 1 dash 1 and 3 and 5. This is obviously that this number is repeated, but this is the first number. This occurred here the first time, and here it is the second occurrence. Now you want to keep their relative positions intact, right? So both of these are sorted, right? But if you talk about stability, this is known as stable and this is unstable. Okay. Now, insertion sort, whenever you are trying to implement insertion sort, it is stable. That means the relative positions of both these ones will be intact. Okay. So if someone asks you if insertion sort is stable or not, you will say yes. Why? Because the relative positions of the numbers that are repeated remains intact. Now, what about this in place or out place? Since we are not using any auxiliary memory, right? We didn't use any stack, queue, linked list, or array. That is the reason that whenever you are not using any extra memory, it is supposed to be in place algorithm. So if an algorithm is sorted within the array that was there earlier, that means you're not using any extra space, that algorithm is known as in place algorithm, which is evident now in insertion sort as we are not using any extra memory. So insertion sort is an in place algorithm. Now let's look at the example wherein we will implement insertion sort. If you can see, we have this example over here wherein we have 6, 5, 3, 2, 8, 10, 9, and 11. And we have been given this k. What this k signifies that the maximum swaps or comparisons needed for this 3, either on the left side or on the right side, right? The number of positions that this 3 needs to get to its original position is 3. So this is a question that is known as nearly sorted array or k sorted array. We do not need to sort all the elements in the array, but we are specifically looking for those elements which are not at its original position. And if we want to get them to their original position, the maximum comparisons or swaps that we require is 3. So if you see this 3, the original position of this 3 is this 5. That means in the sorted array, it will be here. Similarly, if you talk about this 2, the number of swaps that it should do is 1, 2, and then it will be at its original position. Or you can say that 1, 2, and 3. So max it can go to 3 positions. Okay. So similarly, it will be the same for all the elements. So at most 3. Okay. And at least it can be that it doesn't need to move at any location, that it will have its own original position. Just like in 11, you see 11 is at its own position in the original array as well as in the swapped array. So at most you have 3 positions. Selection sort algorithm. Now let's talk about what is selection sort. Now before we move to this sorting algorithm, let's try to understand what is sorting. So if you have a bunch of students, and out of those bunch of students, let's suppose some of them have either left the college or school, or they are absent. Right now you want to arrange the remaining students either in ascending order or in descending order. So for that reason, you might require sorting. So this is one of such sorting algorithm which helps us to sort elements or number of students. It can be any object, right? So it is a simple sort algorithm that revolves around the comparison. So now this is different from if you talk about bubble sort, insertion sort, and selection sort. this sorting algorithm is predominantly based on comparison, right? The comparisons are done more as compared to swapping. In each iteration, one element gets placed, right? If you think about bubble, how it worked like a bubble, and at the end you had your element fixed at its original position, which was at the end when we are trying to sort our array in the ascending order. Now, in the same fashion, right? In this sorting algorithm, one element that can be either the largest element or the smallest element. So we are going to put in the case wherein we will be dealing with the smallest element. In each iteration, the smallest element get its placed fixed in the original array. That means when we sort the array wherein this element belongs, that is the least element that is on the first index, right? So this element will have its position after one iteration. We will be choosing a minimum index in this sorting algorithm. We have one minimum index, and that can be named as minimum, right? Since we are dealing with the smallest element. So now that minimum element in the array is placed at the beginning, right? Beginning of the array. And later on, we will compare it with all the elements and find out the minimum and then swap it with the first index. Okay. Similarly, we are going to do for all the rest of the elements. Okay. Now, the selection sort is basically selecting an element, that is the minimum element, in each iteration and placing it at the appropriate position. So that is the basic logic behind what selection sort. Now let's talk about selection sort algorithm. Now in this algorithm, our main objective is to find the minimum index, right? So let's suppose if we have one array. Now, in this array, there is one minimum index. Let's suppose that it is the first. It is at the first index, right? Since we are keeping in mind, right? I told you at when we talked about what is selection sort at that time, I told you that we can have two cases. Either you can pick up the largest element and fix its position at the end, or you can pick the minimum element, that is the smallest element. Okay, so in this case we will be dealing it with the smallest element, right? Now this is our minimum index, right? This is the 0th index. Now this outer loop will work from 0 to n minus 1. Now why n minus 1? Okay, I will tell you why. Because then what we will do, the next step is that we will have this minimum index, right? And it is pointing to 0 in this case. And our iterator, that is I, will start from this position. Then in the nested for loop, that is, again, this is condition where we have one for loop and inside that we have another for loop. That is what you mean by nested for loop. Now, since it is a comparison algorithm, what we are going to do inside this sorted part, or inside this unsorted part that is there, what you can say, the rest of the elements. Okay, so we have this j iterator which is pointing to I plus 1. That means we will not compare. It doesn't make sense, right? If I and j are at the same position and we are comparing them, it doesn't make sense, right? So we have this j placed at this iterator at this index, right? 1. This j iterator is at index 1. Now what we will be doing, we'll be comparing it because it's a comparison algorithm and number of swaps are less. That means if there are n elements, there will be n or n minus 1 swaps. Okay, so the swapping is reduced as compared to bubble sort. Okay, so now what happens, we will be comparing them. Okay, and we will be trying to find the minimum index. Let's suppose this is 3 and this is 1. So since 3 is greater than 1, that means our minimum index will be updated. So now our new minimum index is what? At index is the 1, right? This is the minimum index. Okay, done. Now once this comparison is done, right? So again we will check if 4 is less than 1, no. If 5 is less than 1, no. If 6 is less than 1, no. If 0 is less than 1, yes, 0 is less than 1. That means we are again comparing it, right? And we are not swapping them. We will wait once this entire iteration is done. So I will update my minimum index to what? 5, because that is the minimum index. Then we have, let's suppose we have 8. Okay, done. So now once this entire for loop is exhausted, right? Now what we will do, we will swap this minimum indexed element with the this with the minimum index that was earlier there, that is the zeroth index. Okay, now we'll swap it with the zeroth index. Okay, so now what happened, this we will get here 0 and we will get here 3, so only one swapping is done. So now after first iteration, all the elements will be at its own position, because since we didn't swap any elements, we swapped only a single element, that is these two indexes, that is 5th and 0. Okay, so now what we will have 0 1 4 5 6 and 3, and at the end we have 8. Okay, done. And then we will iterate through again. So now our iterator will be here and our j will be here, and this time around minimum index will be, right, earlier it was 0. Now since we will not take care of this, or will not think about this index now, because this is already at its original position, the element is at its appropriate position. That means when we sort the array, 0 will be at 0th index, so we will not think about it, and it doesn't matter to us now because it is at its original position. So minimum index will be now 1. Okay, so now let's try to see an example wherein we get the better understanding of this algorithm. So if you observe carefully, this is our input array, right? So we have 23, 10, 16, 11 and 20. Now what happens, we'll make this our first step, and this is our iteration number 1. Okay, so now what happens in this, we have our minimum index that is at c, this is our I and this is our j. Now we'll compare, right? Is 10 greater than 23? No, it is not, so still we have minimum index as 0. Is 10 greater than 60? No. Is 10 greater than 11? No. Okay, now this is the first step. Okay, just a minute guys, so let me erase this. So our I will be here and j will be here, and minimum index is at 0. Okay, because that is the first index. Okay, so since we are taking into consideration the smallest element, so now we'll compare. Is 23 greater than 10? Yes. What we will do, we'll update our minimum. That means this is now index 1. Now what we will do, we'll have our index updated as 1, and then what we will do, we'll compare 10 with 16, 10 with 11 and 10 with 20. Since this is our minimum index after first iteration, now what we will do, we'll swap it with the first index, that is this, and this element will be swapped. So that is why we have 10 here and 23. Rest of the elements are same. Done. So this is our first step, and our I was at 0. Now our I is at 1, so this is our minimum index, right? This is our minimum index in this case. Now 11, in this case, what is our minimum index? That is 21, right? So min is here, and 23. Now 23 will be compared. It is greater than 16, so this will be our min. Again 11 will be compared, so this is our min. Now 11 will be compared with 20, so this is not our minimum element. Now this is our minimum element, and it will be swapped with 23. So 23 and 11 will be swapped. So that is what you see here. So 10, 11 and 23 is swapped with this. So 23 here and 11 here, right? So 23 will be here and rest of the elements will be as it is. So this is after iteration number 2. Now what happens in iteration number 3? So we have 0, 11 at its original position, right? Now let's swap back and let's erase this. So now what happens? So this is our minimum index, right? And now 16 will be compared with 23, nothing will happen. 23 will become 16 will be compared with 20, nothing will happen. So this is our minimum index, and this is the ith index wherein we will be swapping it. So 16 will be swapped with itself, and rest of the elements will be as it is. So you will see 16 and then 23 as it is and 20 as it is, considering this iteration number 1. Okay, so after iteration number 3, this is our input array. So similarly, after third iteration, this thing will happen as 23 is greater than 20, so these elements will be swapped, and in the fourth iteration is required as last element is already sorted. Okay, so no fourth iteration is required as the last element that is there which is already sorted. Okay, so this is the whole demonstration of this selection sort algorithm.
After learning what is selection sort, let's quickly hop into the implementation part. We are implementing selection sort in Python on Google Colab. So let's quickly switch to Google Colab IDE. So here, as you can see, I've just briefed with a simple steps, which is easy for people to understand. So step one, what we are doing in this particular coding is we are declaring a variable called min. So that is minimum. That is always located in the location 0 of an array, right? So that first particular element in the array is considered as a minimum element. That particular element is compared with all the other elements left over in the array, right? Any element which is found which is lesser than the minimum element, then we swap the places of and the values of minimum with the found element, right? So we always consider the array should have the first place should have the smallest value. So this is how generally selection sort will work, right? So after doing this process one swap, in order to continue the iteration, we'll always put min value plus 1. That means the variable minimum will be added by 1. That transfers the place of 0 to 1 in the index of the array, right? So the second element will be considered as minimum. That second element will be compared with all the other leftover elements in the array except the first one, which is already considered as a smallest number. So once it is done, the same iteration will be proceeding until unless all the elements in the array is been sorted, right? This is how selection sort will work. So the same thing is implemented with the help of Python. If you quickly see this particular program, so here selection sort is the name of the function which is being given in order to keep it relevant. Then you have an array and size of the array. What happens is minimum number, that is minimum variable, will be compared with the other elements of the array with the help of the for loop. Every step it will jump, every index it will jump. Array 0, array 1, array 2, array 3 up to the elements. Here if you could see, the data is having 5 elements. That means the array value starts from 0 up to 4 we have, right? That particular iterations will be done at the first part. If it is not finding any element which is minimum, then it will consider the first element itself as a minimum. Then what happens? We will just put the minimum value iteration plus 1. That means it is going to the next one and checking for the same kinds of in similar way, and it is also considering whether the minimum element is smaller than any other element or it is greater than. So accordingly it will try to find out, and then it will quickly swap again and continue with the third element. So these things will happen with the help of this particular function having two fors, and it will always, I told you, compare with the help of if condition here. If you want that in descending order, you should just change the value here, that is lesser than, you can make it as greater than, it will sort it in a descending order as well, right? So this particular step you have to notice. So why do we use this is because in order to swap the minimum number to the correct position, right? So whatever the position is being found to be the correct, it is swapped with the help of this particular line of code. After that, you could find you have a set of data with 5 elements, including the minus value as well, and it will try to find the length of the data. What is the length? Is nothing but size, how many elements are there. Accordingly it will sort. Size is very important in order to compare between all the elements. It should have an end value, it cannot be infinity, right? So immediately let's check out how do we sort using selection sort. So here you could see sorted array using selection sort is done in ascending order, starting from minus 20, 12, 19, 22, 45. So this is how the ascending order sorting by using selection sort is done. So let's quickly have a check for descending order immediately now. Just have to change this if condition, it is greater than, you will get descending order. I'm just changing here as well. Right. So the change is being made here, and let's quickly run the program now. Right. See, it is sorting in descending order. That means greatest number first and the followed by the smaller numbers, right? Greatest to smaller. So this is how selection sort will work in Python.
Now let's see the time complexity of selection sort. Now, if you talk about worst case, that is, if the array is unsorted or it is, uh, we are trying to sort an array which is reversed in nature. Okay, so let's suppose we are trying to sort the array in ascending order and we get the array in ascending order or descending order. Okay, so that is 10, 9, 8, 7, and 6. So this is the worst case, right? And now what happens in this case? Every index, the minimum index will be updated for every element. Okay, so 10 will be compared with the 9, so minimum index will change from 0 to 1, then 0 to 2, 3, and so on. Okay, to find the minimum index, that is this element. So this is the worst case. Now what happens? We have the outer loop that is working from 0 to n minus 1 and the inner loop that is working from 0 from j plus 1 to the size. So in any case, whether we have this unsorted array that is here, we will still be traversing big O of n square times because we have these two for nested for loops which are working up to the size of the array. Done. And same thing happens in the average case as well. Whether we have some elements in the sorted format, let's suppose we have half of the array in this way, and then the rest of the elements are unsorted, still we will not update our minimum index, but rest of the elements will change for the not for these three, but for the rest our minimum index will keep on updating. Okay, so it doesn't matter. So average case type, if you talk about average time complexity, it will also be n square. But what happens if our array is still sorted, right? Or if our array, that is the array given, is already in sorted format, will there be, if we modify our bubble sort, we can get this down to big O of n. But this is not the case in selection sort. Still we will be comparing in the outer loop from 0 to n minus 1 or size minus 1, and in the loop will be again going from j plus 1 to less than size, without, even if we are not going in this for, in this if condition, that is the comparison condition will not be executed and the minimum index will be as it is, still we are going through this for loop. Okay, whether we are not, even if we are not executing this if block, okay, it doesn't matter, still we are going, the n square time complexity will be there even in the best case as well. Okay, so this is all about the time complexity of selection sort. Now let's talk about the space complexity of selection sort. Since we are not using any auxiliary memory, so auxiliary memory can be in the form of arrays, linked list, stack, queues, or even strings. Since we are not using any of these extra memories in order to sort our array, so the reason for that is because we are doing this within the array that is provided to us, right? So the space complexity is constant. That means big O of 1, as we are not using any auxiliary memory. Now let's talk about selection sort analysis. If you observe carefully in this array, let's take an example first: 10, 9, 8, 7, 6. Okay, let me put a 6 here. So this is our array, right? And in this array, what we are trying to do, we are trying to arrange it in an ascending order. So now, if you remember the algorithm, the outer loop worked from 0 to n minus 1, and then inner loop worked from, that means 0 plus 1. That is, let's suppose if this is an I iterator, if we use in outer loop, we used I, and then in inner loop, we use j, then j work from I plus 1 to size, that is n, right? Now, and then inside this we used to compare. So now in worst case, every element was compared, right? J was compared with I plus 1, right? Or I was compared with j plus 1. So it was compared with this, and this. And we were selecting the minimum element in the array, the minimum index rather. We were selecting the minimum index in the entire array. So this was working for n times, and this worked from big O of n times, right? And in worst case, the number of comparisons required will be big O of n square, because we are trying to find the minimum index in the entire array, right? And once we have that minimum index, and later on we'll swap them, right? In worst case, it will go from 0 to n, that means big O of n, and the inner loop will also go from big O of n, that means 0 to n. So in worst case, since these are nested for loops, so the worst case will be big O of n square. And for comparing them, well, I'll always compare all the elements, and it will be again, it will boil down to what? Big O of n square when we talk about number of comparisons. And what happens when we are trying to swap them? Since we have this minimum index that is there, only one swap was required, that was outside this inner for loop, right? So we have this inner for loop, and here we were doing the swapping. In worst case, the number of swaps that are required is big O of n. Okay, in worst case, that means we were swapping only single time, and it will be the case, right, that in worst case that all the elements right at the end will be swapped. So we will have at the end what? 5, 6, 7, 8, and 9, right? And we will swap them only once in the entire array, that is once for every element. So in worst case it will be big of n square. Now, what about stability? If you talk about stable algorithm, it means that if you have this array, let's take an example, it is 10, 8, 9, and 10 again, and then 6. If you talk about this, the stability will boil down to two things: the relative position of these two elements, 10 and 10 dash. Now, if we sort this, it will be 6, 8, 9, 10, and 10 dash, right? So it will be 10 and 10, but just to separate these two tens, we are taking as an example, we are taking this, assuming this 10 to be 10 and this 10 to be 10 dash. And it can also be that it will be 8, 9, and then 10 and 10 dash and 10. So both of these are sorted, right? But if you talk about stability, this is a stable algorithm. Why? Because the relative position of this 10 and this 10 is intact, and this is an unstable algorithm. Now, when we compare or when we do the swapping in selection sort, it is not guaranteed that it will be stable, right? And the elements can be unstable. That means the resultant array will be in this format, that 10 dash may be at first and then we have 10. So it is not guaranteed that it will be always stable, but yes, we can make it stable by modifying our selection sort. But if you talk about traditional selection sort, it is an unstable algorithm, right? Now, what about the in place? That means, are we using any extra memory or extra space? No, we are not using any extra space, right? Extra space can be a linked list, it can be an array, it can be a stack, it can be a queue, right? We are not using any of these extra spaces. So that is for the same reason this selection sort algorithm is an in place algorithm, right? Because we are swapping our elements and we are comparing them within the given array, right? We are not using any extra memory, right? So for that reason, this is an in place algorithm. Let's try to reiterate what we learned so far. So if we talk about number of comparisons, in worst case, it can go to big O of n square. In terms of number of swaps, it is big O of n. It is an unstable algorithm, and it is an in place algorithm. Now, before we understand what is quicksort, let's try to understand what is sorting and why do we require sorting. So sorting is a mechanism wherein we will be sorting or arranging our data either in ascending order or in descending order, right? So let's suppose you have 10 students, and all those students have roll numbers allocated from 1 to 100, and you want to know which roll numbers are present and which are absent and which have left the college or school, right? So in that scenario you can easily implement sorting, right? And you can understand, when you have that sorting arrangement in place, you can easily detect which elements or which students are absent or not, right? So herein you can use sorting. So in this tutorial we are going to understand quicksort algorithm. It is one of the most widely used algorithm. It follows a paradigm of divide and conquer, What do you mean by divide and conquer? Basically, we will be dividing our array in such a way that every time we will be dividing, let's suppose this is an array and now we will be dividing into two. Then further we will divide it into two. Then further we will divide it into two, and so on, right? So we'll see in the algorithm part how we can implement this divide and conquer paradigm. And in this tutorial, we will be implementing this quick sort using recursion. We'll see how we will recursively call those functions based on some pivot element. Now in this recursive call, we'll choose a pivot element. Let's suppose you have this array and we were choosing this element as pivot. Obviously you can choose any element as pivot, right? So it can be first element, it can be last element, it can be any random element. But once we have chosen that pivot, now what we will do in each iteration, right? In quicksort, what happens in each iteration, this pivot will have its original position. That means this will be the position in the original array as well. Let's suppose this is our pivot. Now this pivot will have its original position after one iteration. After that iteration is over, and all the elements that are less than this pivot are on the left hand side, and all the elements that are greater than will be on the right hand side. Now then we will be choosing another pivot. Now what are those pivots? We'll see in the algorithm more extensively how we can choose that pivot. Now let's suppose we chose this pivot, and this pivot is here, and after the second iteration, what happens? This pivot, this will be our next pivot, and this will be our next pivot. Now we will be having two pivots. So this is how we induce that we are implementing divide and conquer approach. Okay, with each step our problem gets reduced to two, which leads to quick sort, right? Or quick sorting algorithm. Okay, so now we'll be dealing with this subarray and we'll be dealing with this subarray, and now we'll be implementing the same procedure on this subarray. That means this is the pivot and this is the pivot, right? Now let's try to understand the algorithm of quicksort. So now we have this first of the method that is there, that is known as quicksort, in which we will be calling this quicksort recursively again and again. But first time around, what happens, we will check, okay, now we have this array, always we will check beginning should be less than end, because that way we can keep the track of things, that okay, this is a part that is already sorted and this is the part that is unsorted, right? And now we will be checking, and after checking that, we will be calling this method. We will see what this method is, we will see the algorithm, and we will see how this partition happens, and we will get the index of the, let's suppose we pick this element as pivot, and after partition, what happens, this pivot has its original position at index 3, right? And that will be returned, and that will be contained in this pivot index, right? And now what happens, now we know that this is its original position in the original array wherein we will get the sorted array. This will be its original position. That means this element, let's suppose is 8 will be at index 3, and this will have its original position after each iteration. Now first time around, what happens, this partition is called. Next time around, what happens, this quick sort algorithm is called again recursively, first time on the left hand side. That means this portion. Now in this portion, this will be your pivot. Okay, you see beginning is we are sending the arguments as beginning and pivot index -1. That means we are not including this element because this has been already sorted. We are not including this element, and we are calling this function on this subarray again, and this time around this will be our pivot, and same thing happens. Similarly, when we are done on the left with the left hand side, now we'll be moving to the right hand side. That is, we will be implementing it on pivot index +1. That means this element from this element that is there to the end of the array, and this time around this will be our pivot. Okay, now with that being said, this is what happens when we are implementing quicksort. But now what about this partition method? Let's see how that happens. So in partition, what happens, we will be setting up the pivot element, that is setting up the element which is our pivot. Obviously you can choose any element, but in this tutorial what I am going to use, and what you should try first, that we should try to pick pivot as the last element. Obviously you can pick any element, and its time complexity, and depends on which pivot you will be choosing. We'll see that in the time complexity part. Okay, now we have set this pivot as the last element, and now what we are doing, we are saying that okay, the pivot index, this step refers to what? This is the index from, let's suppose this is the pivot index, and what happens, this will be our pivot. Okay, what happens, this pivot index maintains that order. Okay, from this index everything on the left hand side is less than the pivot, and everything on the right hand side is greater than the pivot. So we'll see when we will see an example, and therein I will show you how this pivot index is very important. Okay, now what we will do, obviously at start it is at this position. That means we have no such scenario wherein we have some elements that are less than pivot and we have some elements that are greater than pivot. Okay, so now let's suppose this is our array and this is our pivot, right? And this is our p index, that is the index, pivot index, and it is -1 right now. Okay, now these two steps are done. Now what happens in the third step, now we will iterate from beginning, that is this point, and we will check if any element is less than pivot. If that is the case, then what we will do, we will increment this and swap those elements, that is the era and the first element and the index that is present at, that means now if you see this step, now we have incremented it first, right? Now let's suppose if any element that is less than pivot, we first increment the pivot index. That means that pivot index will be here, and we will be swapping it with arr of I, and arr of I is also at this location, so this element will be swapped with itself. Now you might be thinking, okay, so why we are doing this, right? Why we are swapping this with its own position? You won't get the intuition in this step, but in the next step you will definitely get the intuition. Now let's suppose this is the thing that happens in the for loop. Now let's try to reiterate this. Now if an element is not less than pivot, let's suppose there was, here we had 5 and here we had 3, so it was less than and we swapped it with itself. Now let's suppose we have this element 6 and it is not less than pivot, right? And what happens over here, so we will not execute this if block, right? And then we'll have this arr of I. Now I will be here, now I will be incremented, and this time around we have 2 and p index is still here, right? Now this time around it is less than 2, right? And now what we will do, we'll increment first the p index, it will be pointing here, and then what we will do, we'll swap these two elements, right? These two elements will be swapped. So now you have 2 here and you have 6 over here, right? So you see, this is the reason why we have this pivot index in place and why we are swapping them. So in the first step it was that it happened due to the fact that the element was less than pivot, and if the element wouldn't have been less than the pivot, then we have incremented the I pointer and p index would have remained on -1. Now finally what happens, now once the entire iteration is complete, and let's suppose we have 8 over here and we have then 10. Now once the iteration is completed, now what we will do, we'll swap these two elements. That means 5 and 6 will be swapped, and we have 5 here, we have 6 here, we have 8 here, we have 10 here, and we have 3 here, and we have 2 here. So you see, after one iteration, all the elements that are less than pivot will be on the left hand side, and all the elements that are greater than will be on the right hand side. And finally we will return pivot index, that is p index plus 1. That means we will be returning this index, so that this element is not considered or will not participate in any further iterations or any further recursive calls. Because you see, if you observe carefully, that we were sending pivot index -1, that is without 5, all the elements on the left hand side, and +1, that means without this index, all the elements on the right hand side. Okay, this is how partition works. Now you might be confused a little bit. Now let's try to demonstrate this with the help of example. So you see, we have an example over here, right? We have 5, 10, 9, 6 and 7. These are the elements in the array, and we have this pivot here, the last element. We have chosen last element to be the pivot, and after that what we are doing, we have this end pointer and we have this beginning pointer. Also we have that pivot index, which will be somewhere around here, right? That pivot index, which will be -1. Now this 7 will be checked. Okay, is 5 less than 7? Yes, 5 is less than 7. So it will be swapped with itself, and pivot index will be incremented first and then swapped with itself. Now pivot index will be here. Next time around, our I pointer will be here. First it will be here, then what, it will be incremented. Now we will again check. Okay, is 7 less than 10? No, it is not. So our I will be incremented. I will be now here at this position, right? Now again it will be checked. No. Again it will be checked. Yes. So now what happens? 7 and 6, this 6 will be replaced with what, 10. So you have this 6 in here. Obviously pivot index will be incremented first, and then we have the 6 over here, and it will be swapped with 10. So 10 will be here, right? Done. And finally, when we are at the end, once the entire iteration, this is the step 1, once the entire iteration is completed, we have 5, 6, and then 7 will be the last swapping that we did, the last swap that we did. If you observe here carefully, this swap that we are doing, this is the one that is responsible for swapping this 7 with the pivot index, that is pivot index plus 1, that is this location, and we have this 7 over here, and it will be replaced with 9. So that is why we have 9 over here, and 10 was here, and this is the array after first iteration. Now you might be thinking, okay, now this element is fixed. Now we will not never talk about this element because this has its original position in the sorted array as well. Now what we will be dealing with, we'll be dealing with this left part and with the dealing with this right part. So now what happens in this part, right? And what happens in this part? You see, now we have new, this is our beginning and this is our pivot because this is the last element that we will be picking, and this is our end. Similarly, this is our beginning, this will be our pivot, the last element in this subarray, and the end will be here. Now we'll be again doing the same step, and this time around we'll be checking, okay, pivot is less than, no, nothing will happen, and then we will be swapping this thing with itself, right? And now once this entire subarray is completed, we'll not go any further because this time around beginning is not less than end. Both elements are at 0 and 0 is not less than 0. And now if you observe carefully, this is the condition that we were setting at the start of the function, that is the quicksort function, and we were checking if beginning is less than end, right? So this is the importance of that. Similarly, the same thing will happen over from this side, and again beginning will not be less than end part, and we will not go any further. So after 2 iterations, our entire array is sorted, right? So this is the step 1. After step 2, our entire array is sorted.
After learning what is quicksort, let's quickly implement the same in Python. So here we are using Python IDE, that is Google Colab, one of the IDE mean to say, and then we'll implement that particular program there. So let's quickly hop into the IDE now. So here is the program for quicksort in Python. So let's understand how this program works, right? The first part, we need partition to be made, right? Any array in quicksort to be broken into 2 halves, and we will start sorting in that particular different pieces. So partition positioning will be done with the help of array, low and high variables. So at the rightmost, always we'll consider the element as pivot element. Rightmost element of the array is a pivot element. That is the consideration. So in order to do that, we'll use pivot is equal to ARR of H, right? So then pointer for greater element. So whatever the element is greater, in order to compare, we'll be using this pointer. In order to traverse from all the elements inside an array, keeping one pivot element in consideration with comparing with that particular element, we use this for loop system, right? If smaller than element is present, which is smaller than pivot, we'll use this I is equal to I plus 1, and immediately we'll swap the element in the position which is there in I with J, right? That will be done with the help of ARR of I, and J is equal to J and I. We'll exchange. If you could see here, J is been changed to J and I. So we're exchanging the elements if it is smaller than the pivot element. Then swap pivot with I if it's greater than pivot, right? If any element which is greater than pivot element, wherever the I is pointing to, that element will be swapped between the element and pivot, right? In order to do that, we'll be using this particular condition. Then we'll get back to the initial position where we started the partitioning, right? Where we broke that array into two parts, the partitioning is done. There we'll go back and we'll try to start initial position. Then the quicksort function will come, right? So here in quicksort, again we need three different elements: array, low, and high. If low is less than high, that is smaller element than pivot is present, it will all go towards the left side. If there is greater element than pivot is present, it will go to right side. So partitioning is done accordingly. So this is a recursive call which we follow for quicksort, right? We'll be having again array low pi minus 1. Pi is pivot minus 1. So again for the right of the pivot, we have a recursive call function which is declared here. Once all these things are done, we have to give data in order to sort something, right? We are here presently concentrating on sorting the array which is given in the ascending order, right? So the data set here is mentioned and it has been assigned as D, right? So the set has been assigned as D, 9, 8, 7, 2, 10, 20, and 1. So these are the elements which we are trying to sort, right? We are printing the unsorted array. That means however the input is present here, that is printed as it is. Unsorted is array is equal to so and so, which is already there, which we are not performing any functions. Then we have print D. That means immediately it will print. Then size is equal to length of D. We'll consider in order to print, while we are printing, right, we have to print element wise. So again we have to print it 9 first, 8 next, 7 next, and then 2 followed by up to 1. So after that is done, we will send this particular data, raw data, which is unsorted data, to the function called quicksort, which we have created here, right? So that is being sent. Once that is sent, it will follow all the procedures which is mentioned here. All the functions will be passed with the data, and then finally we will print sorted array in ascending order, which is sorted using quicksort, right? So let's quickly run this program and check out what is the output. So it will take some time in order to take the output. So let's quickly see. Okay, so that is what I mentioned. Unsorted array is nothing but the array which has been given by the user. And sorted array is also given after performing all the functions assigned for the quicksort. So if you could see, it is in ascending order, starting from 1 and ending at 20. So this is all about quicksort in Python.
Now let's try to understand the time complexity of quicksort algorithm. In quicksort algorithm, we have now seen that partitioning of elements takes place, and we are partitioning all the elements. That means all the n elements. If there are 8 elements, all the 8 elements will be, we iterate through all the 8 elements, right? So partitioning them takes n time, that is order of n time, and then quicksort problem divides it into the factor by the factor of 2, right? Every time we are dividing it by 2. So the entire process or the time complexity of quicksort in best case and in average case takes order of n time, that is big O of log n. And same thing happens when we are talking about the average case as well. But why this is n square in worst case, that is the question, right? So let me clear it out. So the question is that why this thing happens if you are picking either the smallest element in the array or the largest element in the array as pivot. In that case, you are traversing through all the elements again. That means this n is already there for partitioning them. That means you will be iterating through the array. But the extra n, and that means inside that n, you're again traversing through all the elements and swapping them, because you have picked your pivot. In worst case, you can either pick it as smallest or the largest element in the array. In both these cases, you will be swapping all those elements with itself. That this element will be swapped, right? This is the largest element, right? This is, let's suppose this is 8, so nothing will happen, right? So this is smallest, then it will be swapped with itself. This is smallest, this will be swapped with itself, this will be swapped with itself, this will be swapped with itself. So all the elements will be swapped, and finally this element will have its original position at the end, right? So this thing will happen if you are picking your pivot as the smallest element or as the largest element in the array. Okay, so in these two cases, this is not the case. You are picking your pivots as random. You are picking your pivots randomly. Okay, in nutshell, when you are picking your element, that is your pivot element, as smallest or the largest element in the array, in that case that will be your worst case time complexity, and it will be big O of n square. Now let's talk about the space complexity of quicksort. Now you might be thinking, okay, we are not using any extra space, right? We are not using any auxiliary memory like in the form of array, stack, queue, linked list, or anything, right? But for calling this function, that is the quicksort function, we are using recursion, right? We are calling this quicksort again and again, right? Two quicksort calls are there. For maintaining the call stack, we require order of n space, that is the time complexity will be big of n when we are using this approach. And in the worst case, this will be the scenario that all the elements will be on the call stack. Okay, so in worst case the space complexity will be big of n, but if we modify this approach of storing the elements and calling the call stack and maintaining the call stack, we can reduce it to big O of log n. Now let's try to analyze quicksort algorithm. Let's first try to understand the stability. So let's suppose if you have this array 1, 3, 1 dash and 4. Now an algorithm is said to be stable if both these 1 and this one, both these in the sorted array will maintain their relative positions. Now you have this sorted array, right? And both this one and this one are maintaining their relative positions which were earlier in the unsorted array, right? So if that thing is maintained, right, that thing is maintained, the algorithm is stable, else it is not stable. Obviously you can have another way with which this is also sorted, but this is not a stable, this is unstable algorithm. And if you are sorting in such a manner and you have these things placed, this algorithm is unstable. So if you talk about quicksort algorithm is an unstable algorithm, although we can do some modifications and we can stabilize it, or we can make this algorithm as stable. But as of now, if you talk about quicksort algorithm, it is an unstable algorithm. What about in place and out place? Since we are not using any auxiliary memory, right, we are not using any extra space explicitly, right, in the form of array or linked list or stack, right, or even queue, we're not using any extra memory, right? So this algorithm, quicksort algorithm, although we are maintaining a call stack wherein we are maintaining a call stack and we have a space complexity of big O of n, but since we are not explicitly mentioning these auxiliary memories, this algorithm is an in-place algorithm. And these are the two analyses that can be done on quicksort. So in nutshell, if you talk about quicksort, right, it is unstable algorithm and it is in place algorithm.
Now we'll be learning regarding divide and conquer approach to programming. So every complex program can be divided into subprograms and solved to make it more simple and precise enough. So let's quickly see what is divide and conquer approach. So as the name suggests, divide and conquer. Any complex program, for example, right? I'm writing complex program which is having so many applications in that. So what do we prefer? We prefer breaking that particular complex program into the sub problems or sub programs and solving together, right? So here in sub program 1 we'll be getting one answer, in sub program 2 we'll get one more answer, in sub program 3 we get another answer. Combining all these answers we get the final result, right? So this is what divide and conquer approach is, right? So Why do we use this particular divide and conquer approach? Generally, the first thing is the problem solving becomes easy, right? For everybody, it is easy to understand and easy to look at the branching. Say, for example, if in this simple example which I gave you, people can figure out one complex program was divided into three different subprograms. We got three different answers. Combining all these answers, we ended up with the final result. So this is simple and it is less time consuming because parallelly people will be working. Say one big project you have got in order to work with. You can divide amongst three people, right? All the three people simultaneously will work. Say, for example, after 2 hours, you'll be getting answer 1 also, answer 2 also, answer 3 also. Then quickly you can just combine all these answers, get the final result, right? So, hope this is clear. So, this is why we use divide and conquer approach, and it is very easy. Then coming up to the applications, where do we apply these approaches? In data structures, we'll be applying that majorly in merge sort, quick sort, binary search, and many more places. So let me quickly give you a crisp knowledge how do we solve this divide and conquer approach with an example. So I'm taking merge sort. Let's quickly switch to the IDE and see how does this particular divide and conquer approach help us in order to solve merge sort or sort the elements inside the array, right?
What is merge sort? If we talk about merge sort, let's try to understand first sorting. So sorting is a mechanism of giving order to your values, right? So let's suppose you have some values, random values, 10, 30, and then you have 5, 2, 1, and so on, right? You have these values, and now you want to maintain some order. So in order to visualize this data, let's suppose you want to see the ascending order of it or the descending order of it. That is what you mean by sorting. So let's suppose you have a class, and in that class you have several roll numbers, and some of the roll numbers are not present, and then you want to sort those roll numbers in terms of ascending or descending order. That is when you require sorting. So this is the basic intuition behind sorting, trying to give order to some kind of values or some kind of a data set, right? So in this particular tutorial, we are going to talk about merge sort. So merge sort is a classical sorting algorithm. In this sorting, every time your problem is divided into sub problems so that your problem set is reduced, and then you will be focusing on that sub problem. Similarly, every time when you're dividing your sub problems, you will keep on dividing it unless and until there is only one element left, right? If you compare it with simpler sorting algorithms like bubble is there, insertion is there, selection is there, quick is there, when you talk about its time complexity as compared to these algorithms, this is very much efficient. Now, it follows a paradigm of divide and conquer. What does this mean? This means that first you keep on dividing your sub problems, and then you will conquer those problems, and then you will combine those things. Okay. So herein we will see when you are trying to divide your sub problems, and then when you have your problem set and those problem sets are conquered, that means those problems are further, when you talk about in this example, those sub problems are sorted in this case, and then you have conquered them, and then you will combine them. That is your merge phase, wherein you will be combining your problem again, and then for forming again a single sub problem. So every time you will be dividing that sub problem, you will be conquering it and combining it. So this is how this divide and conquer paradigm works. So basically, when you're dealing with merge sort, you are focusing on two functions, that is your merge function and your merge sort function. So now let's talk about this divide. That means you're dividing your subproblems, which continues unless and until there is only one element left, because one element in itself is sorted, right? Now this is your divide phase. What about conquer? Basically, you are conquering those individual sets and then merging those two subproblems into a single problem.
and finally you will be doing it on each step, and finally you have your original array which is sorted. Now let's talk about merge sort algorithm. So first let's talk about merge sort method. So in this method, what we are doing, we are dividing our array into further sub arrays. How we are going to do that? We are basically, if we have this array, right? And this array, let's suppose this contains 8 elements, right? This is our array. And let's suppose this is our left pointer and this is our right pointer. And now what we are doing, we are dividing it. So we need some kind of in iterator wherein we will store the sum of, and we try to calculate the mid value. How would you do it? In simple words, we calculate left plus right divided by 2. That's it, right? So we have this division, and then we will divide this part because we are calling this function again, right, on the left hand side. So this is going to call on this side. That is, we will be talking about now only 3 elements. So this is let's suppose, or let's take 4 elements on this side and 4 elements on this side. So our mid will be 3.5. So we'll be talking about elements from 0 to 3. So we will be talking about 4 elements, and then further these 2 steps are remain. Why? Because we are implementing this in recursive fashion. So now let's suppose this is our first function call, and you have these 3 steps. One, let's name it 1, 2, and 3. Okay. So in the first function call, 1, 2, and 3. So this is the first function call, and in this we'll calling again. This is the second function call, and we are calling again these 2 remaining, right? And we are calling again 1, 2, and 3. Right? So in this case, again, we are calling it on these 4 elements, and it will be divided into further 2 elements, 0 and 1, right? And in this case, again, this will be called on these 2 elements, right? Here we are talking about only 2 elements. So this is the third function call, and again, we will be dividing it. These 2 and 3 steps are still remaining. So in the fourth step, what we are dealing with only single element, right? And in this case, we are talking about only this element, right? And further, we will not be able to divide it. And in that case, our left will be greater than or equal to right. And in this case, it will be equal to. So we will return. So now it will be returned, right? And then whatever was the left over, right? Now we talk about this single element, the other element that was left behind. We'll talk about that. So again, that will be divided into 1, right? And again, this second option, I'll just erase it because it looks a little bit messy. So now what happens? Let me just put it again in red. So here we call this 4th time, and this time it returned, right? So in this case, now we will be on the second step. Now again, it will be called on that single element, and again, left will be greater than or equal to. In this case, it will be equal to, and then we return. So again, we are returning. So we have these 2 elements, 1 and 1. That means not 1 and 1 element, but there is only a single element in both these arrays, right? Why I'm saying that in these 2 arrays, we will check when we talk about merge. Okay, we'll see how that is implemented. Okay, so now these 2 function calls are done, and then we deal with merge. Now before going into the merge, let me show you a demonstration of how things look. So you have these elements, and here you have how many elements? You have 5 elements, right? And now you're dividing it into 3 and 2. Now this is your first step. The second step will be this. So now will you go ahead and create this as your third step? That means you will move on to this? No, because we saw unless and until there is no left, right? We will not go to the right. So this is your second step. Then this will be your third step. This will be your fourth step. Now you will move on to your fifth step, right? And now once you don't have anything on the left, nothing on the right, then what happens? Will this be your sixth step? No, your sixth step will be merge. So let's move on to merge now. So in the merge function, if you see, the algorithm for that is simple, that you create 2 sub arrays. That is, the one is your left array and another is your right sub array. Now in this, you have obviously in the last case, if you have seen, we have a single element here and a single element here. Now once we have deduced out the length of these arrays, what should be the length of these sub arrays, and we have declared the length or declared these arrays, and then we have initialized these arrays. Once these three steps are done with, then what we are going to do, we are going to create three iterators, I, j, and k, and those iterators deal with, I iterator will deal with the left array, j iterator deal with right array, and k with the original array, which helps us to insert the elements. So once we have everything in place, what we are going to do, the next step is comparing the values, right? If this element, that is the element in left array, is less than the element in the right array, we are going to insert that in the original array. So now let's suppose you have 10 here and 23 here. So 10 is less than, so we are going to insert this, and we increment the k pointer. And now also our I pointer will be incremented. It was earlier, it was 0, and it will go to 1, right? And now what happens, now our I is pointing to 1, and our length is also 1. So now that in that case, when one of the array is exhausted, the next array, whichever is left, right? It can be either the left array or the right array. Those elements will be directly inserted in the original array, because we know for the fact that both of these left as well as right arrays will be sorted in itself. Okay, so let's see what is the next step in the demonstration. So here we had our steps, right? And this will be the sixth step, wherein we are going to merge this thing. Now, will this be your seventh step? No, your seventh step will not be this. Your seventh step will be here. This will be your seventh step. Now sixth step is done. Now you will be dividing it, and you will be creating all those arrays. Now once you have your right array, and there is no right because this left is already done, and now you had your right left, now this is also done. Now your eighth step will be this, that you will be merging it. This will be your eighth step, then you will be merging it. Now will this be your ninth step? No, you have your this array, that is your left array, in place, but what about the right array? Is this in place? No, it is not. So now let's try to calculate that. Now what will be your ninth step? This left is done. This is your ninth step. Then what will be your 10th step? This is your 10th step. Well, now there is no left, right? Now we'll move on to this right. So this is your 11th step, because this is the right side of it, right? And now when you don't have anything on the right, now you will be merging these two steps, and this will be your 12th step, which is over here. So this is your 12th step. That means you will be merging these two, and the final sorted array is this array, and you will get this array in the 12th step. So you see 10, 11, 16, 20, and 13. Now if you observe carefully, you have these individual arrays 1 and 1. So now while you are merging them, you are also sorting them. So the left array is sorted, and same thing happens on the right hand side as well. If you see 3 and 4, these two elements are sorted in this left array. So this is the reason in the right array, right? Not the left array. So now when you are merging them, you will get again an array which is sorted in itself. You see 10, 16, and 23. So if one of the array is exhausted, the next array elements can be directly inserted in your original array. Let me erase this, and you see you have your left array which is sorted, and then you are merging it with the right array which is also sorted. Now if one of the arrays is exhausted, the next array, either it can be left array or the right array, the elements from that array can be directly inserted in the original array, because we know the elements itself in either of the arrays, either the left or the right, are sorted. Okay, so this is how you execute your merge function.
So here is the program for merge sort in Python. So how does this merge sort work? Generally, one single array will be broken into two different pieces. Again, those two different sub arrays will be broken into sub arrays. So after that, whatever the answers we get at the last will be combined together in order to finish the sorting of that particular array. So we are merging all the answers which we got from the subarrays to make a final result. So quickly, let's see what do we do in order to have a merge sort in Python. So first we want an array which has been passed through this merge sort function. So what happens inside this function? First, the length of the array is being calculated. Once that is calculated, it has been divided by 2. So it gets left and right parts of an array, right? So after sorting the array into two different halves, we have merge sorting left side of an array, merge sorting right side of an array, right? Then we'll perform the while operation here with the help of the looping systems. So we'll first try to check out whether we have the right array less than the length of an array of the left, and then again left array it is less than length of the right array. So we'll try to merge and we try to solve the elements then and there itself. So later we'll go back to the left and right parts of while loop. Here we have length of an array towards the left side. We are checking whether it is lesser than or greater than, and accordingly we are deciding where we have to merge the answers what we have got from the subarrays, right? So then we'll always have a printing option of this particular arrays. We'll do that in the last. Before that, in order to merge all the answers we have got from all the subarrays, we'll be using for loop here, right? So all the array answers will be submerged and we'll get the final sorted array which is of so many elements which is there in the input given by the user. Say for example 5 different elements were there in an array. So after combining all the subarrays answers, we'll get the 5 sorted ascending order elements in the array by using merge sort. So let's quickly have a look at it. How does this particular merge sort will work? So this is set of an array with 8 different elements inside that which is not sorted. We have to sort that. Once this array is been passed through the merge sorting function, it will perform all the operations. Finally, it will merge all the sorted arrays and it will display in the print list, right? So let's quickly run this program and check out. Even though if it is, we are mentioning the words array, but we are using list here in Python in order to store it, right? So this is the sorted array which we get. So here we could see we don't have a sorted array, but here it is sorted in ascending order. That is smallest to the highest. So this is all about the merge sort. Now let's quickly check out what is greedy approach in programming, right? So greedy approach is nothing but a simple solution for the problem which will give you exact correct solution. It is a step-by-step approach. It is finding the answer in step-by-step way and minimal time, right? So efficiency plus minimal time is equal to greedy approach. So that is what I can let you know. Apart from that, we have a benefit here. So we can get a simple solution very quick manner and we can also trace out very well. So some of the applications of greedy approach are Prim's spanning tree algorithm, travel salesman problem, etc. So in order to have a connect, let me quickly give you an introduction to Prim's spanning tree algorithm. So what is this all about, the spanning tree algorithm? So generally a tree is one of the kind of graph which is having vertices and edges, and mention there is no cycle especially. One vertex has not been joined to another vertex forming the cycle, right? So a spanning tree, next word. So what is a spanning tree? It is having all the vertices connected in a constructed format, right? When you have a connections of vertices constructively forming a graph, then that particular graph can make spanning trees. It can be multiple spanning trees. Say for example, so this is one spanning tree and you have one more spanning tree which is like this. So connects between the vertices forms a spanning tree, right? So next, what is minimal spanning tree? So that means every node to node connection, vertex to vertex connection will be having certain values, say v1, v2, v3 and so on, vn, right? So reaching a source to destination, or visiting the every node in the tree or the graph at least once using a minimal value for the edges given, then that particular tree is known as minimal spanning tree. So whose sum of weights of edges is minimum. So from the source to the destination, if you calculate the sum of the edges was always minimum, then we let that particular tree known as minimal spanning tree. So this is a brief introduction towards Prim's minimal spanning tree algorithm. So let me quickly see with an example, let you know how does this work, right? Now, this particular example is a spanning tree. It is not having anything mentioned minimum or maximum. We are here in order to find minimal spanning tree. So what we have to consider? We have to consider any one node and we have to start traveling from one node to another node in a minimal possible way. The edges is having values. Edge value should be minimum always because we call it as weight, right? Edge weight should be minimum. When you add all the edges, you have to get the minimum number, not the highest number. So in order to give a clear picture, let me quickly take one node here. So I'm taking node B. So you have to see this is iteration 1, right? So node B is taken into consideration. If you could see, node B has two different ways, two different sub nodes. It is there. So one we have D, one we have C. What is the rules? We should have the value, edge value as minimum as possible. So 11 or 5. Minimum 11 is greater, 5 is smaller. So I am traveling from B to D. Okay. B to D is 5. Then coming to D, what are the different subnodes you have or the connections you have, edges you have for D? D has the connection from that node to C, again D to E. If you compare both, D to E is having the value 2, D to C is having the value 3. We are having the minimum value in the path D to E. The edge is having the minimum value. So what do you do? From D, you are going to E. Okay. So with the edge value 2. Hope this is clear. So from E, if you take, how you can travel? You have only one single path to travel from E to C or further, right? You don't have any other probability in order to reach C, right? So also you can go back and check. So it forms 5 again. So without that we can also have the connections. So E to C is having 7, right? So when you have 7 and if you add 2 plus 3 it is 5. So think how you will proceed. So from E to D back again and then C, or E to C. So you have to have a minimum value, and the thing is you should not repeat the nodes again. So here there is no possibility way. You have to go to C with 7 only. You can't think the way I taught you now. So it was just a leading you into a thought that can you go back, add together, like 2 plus 3 is 5, right? 5 is lesser than 7. How I can go back and just go to C? No, you cannot do that, right? You should visit once, at least once it is visited, you cannot go back. So it is 7 done. So next from C to A, you have one connection. So C to A, only one connection. So again you are going to A with the help of 4. So you don't have any other nodes which is connected to C in order to think how to reach A, right? So if you add all together, you will get a minimum spanning tree. Say for example, 7 plus 4 plus 2, again you will have 5, right? So this is 7, so you have 11, so the answer is 18, right? So this is how the minimum spanning tree will work, right? Prim's minimum spanning tree. So let's quickly implement this particular problem or algorithm into a Python programming code. So let's implement and check out on Google Colab how does this Prim's spanning tree will work. So here is an IDE, that is Google Colab, where we have Prim's algorithm program in Python. So let's understand how this program flow works. So first we'll be considering the infinity term. So we are mentioning infinity to so many 9 together in order to have as many as combinations as possible. So next we are considering the number of vertices for the graphs. So we have 5 vertices for the graph. So V is always indicating the vertices of the graph. So number of vertices is 5. After that, we'll always form an adjacency matrix of rows versus column 2D. That is, rows versus columns 5 cross 5 matrix will be present. So here I've formed a graph with adjacency matrix, which is represented. What is adjacency? I'll just quickly tell you. We are having zeros in the diagonal and the parallel elements are same. So if you fold this particular square paper, for example, into exact diagonally from left top corner to right bottom corner, all the elements will match to each other. So this kind of a matrix is known as adjacency matrix. So after that, what do? We need to have an array in order to track the vertex which we select. So whatever the vertex we select, we have to have the track of it, whether is it matching, whether it is having the minimal edge, how it is doing, what it is doing. So in order to track, we have to have an vertex selected array where it is having vertices which we have selected. Then selected will be true, else it will be false. Whatever you select will be true first initially, and then it will make the comparisons, and accordingly it will change the values. So the empty selected array will be having 5 zeros inside that. So after that, we should always set the number of edges to 0. It is not mentioned how many edges it is there. We have to keep it 0 because always edges will be vertex minus 1. We have 5 vertex and edges will be 4. So that is the logic it will work with. So that is in minimal spanning tree especially. So we have to choose 0th vertex and make it true. Always we have to choose the vertex 0 and we have to consider that as a true. It is an assumption in order to start the working. After that, we have to check. How do we check? We have to check the complete elements inside the matrix accordingly, row wise, column wise, and we have to find the edge which is having the minimal number in order to traverse, right? So after finishing all these things, if it is not selected, if there is no edge, then it will consider the neighboring vertex. So if it is not forming, if it is not getting any weighted edge which is having minimal weight, then it will try to correspondently see the neighbor elements inside the matrix, right? So then after doing that, we'll be printing the edge and how it is traversing, what is the minimal value at the end, right? So let's quickly print this particular output, execute and see how it will work. So here we have edge and weight. So at 0, the weight you can go from 2 to 5. Again from 2 you can go to 3 to 1. Again for 3 you can go for 4 to 1. And for 4 you can go to 1 to 2. So these are the traversal of minimum spanning tree that you can make in Python. Now we'll be learning regarding dynamic programming. So dynamic programming is an approach in order to solve a problem in data structures. So what does this particular dynamic programming will do? It will give you the best and the most optimal solution to the problem. How it will give you? It will give you by recursively working on the problem, comparing the solution one to another and finding the best and ultimate solution for you at the end. So this is how dynamic programming will work. It is not letting you with only one single solution. It will always give you multiple solution, which is comparatively common and which is most efficient. It will give you, amongst that, it will consider to be the best one. So applications of this dynamic programming. So where do we apply this particular programming approach? So matrix chain multiplication is there, and one famous element, that is Tower of Hanoi. So people would have heard about Tower of Hanoi. It is a very simple mathematical problem statement. Generally, we use dynamic programming in order to have a best result out of this particular program. So let's quickly check out what is Tower of Hanoi as an example for dynamic programming. So as I mentioned, Tower of Hanoi is a mathematical puzzle, right? So it is having pegs and discs. Pegs in the sense, people who are listening to the first time. So I'm just drawing a picture here. So you're having a stand here and you have three different rods, stick like things. There will be discs which is arranged on this. Usually the children who play, small children, will be having this particular stack in this triangle format, which is having the biggest ring. Upon that there's the smallest one. At the end you'll find the very smallest ring. So like that we have pegs and disc arrangement for Tower of Hanoi. So there are three different pegs which we could consider, which I wrote here. Name it as X, Y, and Z. Okay, three different pegs and three different discs. You are only having pegs 3 and discs 3 here in Tower of Hanoi. And you can increase this how much ever you want. It is always in the format N. Okay, you have a famous formula for Towers of Hanoi, that is 2 to the power minus 1. So in order to find from the source to the destination, if you want to put all the rings without merging, without putting the largest on the smallest, or without repeating or any other mistakes, without breaking the rules, you can find how many moves you want to do that. Say for example, 2 to the power of 3, you have three different discs. N is always the discs, how many discs you use in this particular problem. So I'm considering 3 here. So 2 to the power of 3 is 8, right? So when you minus 1 from that, the answer is 7. So in order to traverse 3 disks from X to Z, from source to destination, you need 7 different moves. So this is how you will calculate the moves, the movements you have to make. Okay, moves is nothing but movements you have to make, all the 3 disks, in order to transfer from source to the destination. Hope that's clear. So next you have to consider what are the different rules you have in order to solve this game or puzzle or problem, anything. So the first thing is only one disk can be removed at a time. From a stand, from a peg, you can remove only one disk at a time. That is the first rule. The second rule is the larger disk cannot stand on the smaller disks. Say for example, you have a smaller disk, that is disk 1 here. You can't put a larger disk on the smaller disk. So this is a second rule for this particular problem statement. So considering all this, let's see how do we implement Tower of Hanoi problem. Let's quickly hop into the IDE now. Here we are on the IDE. So let's quickly check out what is source, named as what is auxiliary, is nothing but temporary, which is used in order to transfer all the 3 disks from the source to the destination. You want to have a place where you can keep all the disks at least for a iteration or for a moment, right? So source is named as X. I'm talking about the pegs, right? The stands, 3 different stands you have. The first stand, that is source, is X, and the temporary stand that is in the middle, the second one is Y, that is auxiliary, and the target destination is Z. Okay, so you have all these 3 peg arrangements and you are considering 3 disks, for example. Okay, let's see how this particular program works in Python. So first we are creating a function called Hanoi. Okay, and you are having disks, source, auxiliary, target, that is X, Y, and Z. And then you are considering all the disk, we are equating that to 1. After that, we are printing the moments from which disk 1 is going to, from which peg to which peg, from source to destination, or source to auxiliary, or auxiliary to destination. So XYZ, the program completely deals with the combinations of XYZ. Once I show you the output, you will get to know. So you are having a common formula here: disk minus 1 comma source comma target comma auxiliary. So this is what we use generally. Again, you have one more formula which is considered. So again, disk minus 1, auxiliary first, source next, and then target. It is very easy to remember and also easy to work with. So at the end, what you will do, you will just type the user input, right? You have to ask the user how many disks he or she wants to enter, and how you will shuffle that from source to the destination. How do you make that disk which is given by the user travel from the source to the destination? Then we will be calling the function. So disks will be having the name and the disk itself, and then we'll be using XYZ instead of source, auxiliary, and target. The objects are created. So let's quickly check on this particular program what will be the output. Right. It is asking the number of disks you want to enter. So I'm writing 3 for now. So I'm giving enter. So these are the different moves. So you could count here, you will be having 7 moves for this 3 disks. I told you the formula 2 to the power n minus 1 is used in order to calculate how many moves this particular disk will make in order to travel from source to destination, or source to target, from X to Z, right? So this is about the Towers of Hanoi implementation. So let's quickly check manually how does this particular movement will happen in the PPT again. The same outputs which we got on the Google Colab has been listed here. So let's quickly see how we can put that particular output into reality. How does it look, right? So I'll consider 3 different pegs: X, Y, and Z. Okay, they say we have 3 different disks. D1 will be first, D2, then D3. So this is small, this is larger than that, this is the largest of all the 3. So this is the current condition. So checking for the first move, what does the first move say? Disk 1 should be moved from peg X to the peg Z. So peg X is nothing but source, this is auxiliary, this is target or destination. So I'm starting with the first move. So here it says the disk should be moved to X to Z. Which one? The D1. Okay. D3. Right? This will be moved to Z. So D1 will be here. It will be removed. Right? So the next one. It says move disk 2 to X to Y. So it is in X, this is in Y, this is in Z. What it says, move the disk 2 to Y. So disk 2 will come here, disk 1 is already existing there, and disk 3 will be here. So this is the current situation when it is at the move 2. When it is at the move 3, how it will look? Say, for example, we are creating the same 3 pegs here. So X, Y, Z. Fine. It says move disk 1 from Z to Y. So while you do that, disk 2 can have disk 1 on top, but it cannot be vice versa. We cannot place in this format, right? This is breaking rules. You can do this. D2 is larger than D1, so it can take D1 on the top. So XYZ is here. So here I'm just putting this D1 on the D2 which is already existing, and D3 is as it is. So step 3, that is move 3 is done. If we go to move 4, what it says, right? It will say move disk 3 from X to Z again. So Z is empty, X, Y, Z. So currently we have D1, D2 here. It says move D3 which is there in X to Z. So D3 will be here. Coming to the fifth move, what it says, disk 1 from Y to X. So according to the situation, now we have to make this D1 move to X, D2, D3. If you could see here, it is getting settled. Obviously, the next move will be, without thinking logically, we can say without going to this part, D3 is here, D2 is here, then D2 will be on this. So D2 will be present here. D1 remains as it is. In the seventh move, what happens? All the pegs, that is, Y is also empty, X is having D1. So this D1 will be shifted on to this particular stack, right? D1. So it is there. Now all the source which was there, D1, D2, D3 at the initial position, is shifted to the destination. Again, if you could see here, D1, D2, D3 with the help of 7 moves. So this is how Tower of Hanoi will work.
With Python data structures covered, we have established a solid foundation. Now, let's move forward and explore how generative AI is implemented and integrated with Python. Before getting started, let me ask you, how familiar are you with Gen AI? Share in the comments below. Understanding Gen AI is important because it helps you build advanced AI applications and harness Python's full potential in the latest technology. Let's get started.
When you hear the name Python, you know the various applications of it. First and foremost thing, it is a high-level programming language which is very unique compared to other high-level programming language. Why? Almost it will use English-like statements in order to execute the code. It's very easy to learn as a beginner this particular Python language. Now, why do we use Python in generative AI? It's not about generative AI. It's about Python is already having a well-supported set of libraries which is already in use since years with respect to domains like data science, machine learning, natural language processing, deep learning, etc. Now, artificial intelligence and generative AI is grabbing the libraries which we have already in Python. Other programming languages are also used, but I could say Python is a versatile programming language which makes life easy for the people working in this technological domain. After understanding an overview of Python, let's quickly hop on to the next topic, Introduction to Generative AI Applications, which is the core concept which we have to learn. Generative AI refers to algorithms which enables machines to produce content that is not only new and original but also includes a reflective data, and it will be always trained according to the requirement. Right? Generative AI deals with a lot of models. What does these models include? GANs, that is Generative Adversarial Networks, VAEs, Variational Autoencoders, and Transformer-based models such as ChatGPT. Right? What do we do with this generative AI applications? It's very important in order to train the algorithm or the machine in order to keep it updated. The more you interact with this, the more it gets trained. That's how simple it will work. And generative AI helps you to generate your own models. How you want to train that particular model, you can train it accordingly. Just like simple example, how does the scientist train the robots? Each robot will do its own different work, right? Hope you would have seen the requirements are different. The catering of requirements is different. Hence, the models will be trained accordingly with the help of generative AI. Yes, it includes a lot of other technologies, deep learning, neural networks, etc. but still generative AI is also a base of it. What is the significance? Creativity boost. It creates enhances processes by providing very good content ideas, new content ideas, the new way to approach the problem. Efficiency. It is giving a helping hand to human beings in order to be more efficient. The more good you use, the more productive you will be. Automates the content creation or saving time is very much important. It's an important resource now. It aids to this particular saving time resource. Then personalization. It generates particular personalized content as per your requirement, as per the prompts you give to ChatGPT. That's how it works, right? So it will cater various applications for the same. This is the overall picture of generative AI applications. Now, let's talk about the next concept, development environment setup. How do we do this? What is it all about? You have to have a platform in order to work with. You need to have a basement in order to build a building, right? So let's learn how do we build this particular basement. So what does this thing consist? It consists of few steps in order to set up a particular environment. It is not dealing with much higher softwares or something from moon and stars. It's very simple. You have to go to Python official website and download the latest version. For now, it is 3.12. You can download that Python into your local system and you can execute this via command prompt, right? First step, we have to open command prompt, which we have in our local system. And then we'll have to navigate to the location where the Python is installed. Hope everyone are having a clear idea of how do you work with Linux and Unix. At least basic commands like cd, change directory, mk, make directory. So only these two commands are mostly used in this complete session. I'm not going deep into advanced level of Unix, Linux and all. If you want to work with a command prompt, you have to just use cd and mk command. And you can make directory or change directory. Simple as that. If you're using Windows, you can use command prompt or PowerShell. For Mac OS or Linux, you can use terminal. This is the platform you need in order to work with. After navigating to the location where the Python has been installed, you can install all the libraries using pip command, right? So, pip install is a basic command and you can change the libraries you want accordingly. First, we will talk about NumPy. NumPy is very well known amongst the domain called data science. Why? The first thing is NumPy will always cater in order to help the mathematical calculations, also working with high-level data structures and give you the complete access to the functionalities and arithmetic and logics. That is why data science is dealt with lot of data, numbers and other elements. We use NumPy for the same. Then we talk about Flask. When you hear the word Flask, it is a library which is related to Python where it is web-based framework. You can create web application using this particular Flask framework. That is the major help of using Flask. The next one is Streamlit or Streamlit. This particular library deals with visualizing the models created. Then you have Torch, Torch Vision and Torch Audio. Basically, this library caters computer vision models. You can work with the model creation. You can view the model and also you can add certain multimedia to the model created, right? You have this Torch library in order to cater computer vision projects, models, etc. You have Transformers next. Transformers will always help you in classification, text summarization, many other aspects, again dealing with data. And majorly, we use all these libraries in machine learning, artificial intelligence, NLP, natural language processing, and deep learning, also computer vision. This is the applications of where this particular library will be used. Using pip install, we are always installing all this library single-handedly, not in mass library installation. every library will be installed along with the execution output command stating it has been installed. It will show you it is installed. Now, still you don't trust. How do you check it? Verification of the installation is very important because since we are working with machines, sometimes it might help you to have a better vision when you verify. If you don't verify, if the installation is crashed, you never know. It will affect your project. So better verify once you install. It's very simple. In order to verify as well, you can open command prompt and type Python _version. It will ensure it returns the installed Python version. What is this particular version you are working with? Next, you verify the installation of the libraries. For that, you have to just go open Python interactive shell, type Python, and then import every library which you have already installed. If it is imported properly without any error, then it is installed properly, right? So this is the overall development environment setup idea which you have to have and which you have to create in order to do coding, in order to create certain applications or work with a project. Now, we are in the command prompt. In theoretical aspect, we have known about various libraries in Python, that is NumPy, Flask, Streamlit, Tot, Transformers. Let's install the same libraries with the help of command prompt. First, if you could see, it's in a general path. It's in my personal path, but yeah, it is in C drive. Now, in my personal laptop, the location of the Python is being fetched. For that, I have to use cd command, change directory, paste the location where your Python has been installed, and then press enter. When you do this, the command prompt goes to this particular folder. Let's start with the first command, pip install NumPy. Now, since I've already been working with Python a lot many times for many projects, you will get an output. Just wait and watch. I'll click on enter. It might take some time. It will try to analyze what's happening, what they are trying to install, and requirement already satisfied. This is what you'll get the output. That means NumPy is already installed in your particular system because we were already working. And there is a warning message you could notice. If you want to upgrade the particular library which you are using, you can go for the version mentioned. I am currently using 21.2.3. It is suggesting upgrade for 24.1.2. Then what is the command for the same is also been mentioned here. You can use that command. We have now installed NumPy, which was already existing. It is given the message. If in case it's a new installation of library, how it will display? Let's try with other libraries as well. Pip install Flask. I'm giving enter. Let's wait for the results. Again, if you could see, it states Flask is already present, that is satisfied. Again, you have a warning regards to the version. I have almost installed all the libraries, but let me check for the next one. Streamlit. If you could see how it is downloading the Streamlit library. If you are trying to install the library which is not in the current local system in your Python, this is how it will start loading. If it is already existing, this is the message which you got for NumPy and Flask. When you try to install Streamlit library which is not present in your Python, this is how it starts downloading, and it takes 5 to 10 minutes at least to complete the download depending upon your system configuration. Likewise, you can install all the libraries required for you into your system, right? So, I have given two examples. One, how it will download the library which is not in your system. If you already have downloaded the library, how the message will pop up. That is, requirement is already satisfied. That means it is already installed, right? So this is how you import your libraries in Python. Now, in order to verify is your particular library is installed or not, first it will try to prompt you that it is already existing. If it is not, it will start downloading as mentioned. Now again, in order to verify that, you have to go to Python interpreter. So I'll click onto the same particular location, type Python here. When you click enter, it will go to the Python interface where you can execute your code. Now what you do is you try to import NumPy. When you try to give this particular instruction to the Python prompt inside the command prompt which we have logged in, it will try to enter or import this NumPy library which is already existing. When you type the statement import NumPy, if your NumPy is present, it will not throw up any error. It will look just like this. This indicates your NumPy is there in the Python library folder. This is how you verify the libraries which is already installed before using it. Or else if you mention in your code as well, it will throw up an error if it is not installed before. Make sure you install the libraries, then use it in your code. This was a simple demonstration of how you install and verify if the library is present in your Python with the help of command prompt. Now let's understand introduction to OpenAI GPT API. How this particular thing works and what is OpenAI first of all. What is OpenAI? It's a company where it will cater in order to work with chatbots, generative AI applications, different kinds of models, LLMs, etc. Basically, it is dealing complete artificial intelligence domain which is booming nowadays. OpenAI has a platform where you can generate the API keys and you can integrate those into your applications. API features. What are the features it will cater for? Text generation, completion, and conversation capabilities. So, talking about text generation, it is always dealing with providing a new text which is not in your imagination with one small question. Say, I want a poetry on so and so. It will give you a complete poetry where it is not plagiarized. It has been trained in that level. It can think about writing poetry. It has lots and lots of data behind how it is dealing with that, what is to be categorized. There comes classification, summarization, and many other machine learning and data science models, artificial intelligence models, which is giving you the answer pre-op. Next, completion. If you give a prompt in an incomplete way, it will try to complete that. If you give with a spelling mistake, it will correct your spelling and ask you back, was this your idea? Do you want to search so and so thing? It will question you back in an interactive conversational way. What we do with ChatGPT? It's the conversation. How it will answer us with the help of already available data. It has been trained on and it is updated every time you talk to it. That's how the model works with. So these are the few features we have. Next comes to fine-tuning and customization for specific task. Say you are building certain module which has been integrated to your application. You are using OpenAI platform. You can generate your own model. It can cater to your own set of questions. Say for example, chatbots in some or the other shopping websites or jewelry shop websites. It will try to ask you what you want. There are lots of chatbots which will address and also will help certain percentage of customer care services without human intervention, which can be done with the help of machine. 100% it will be solved. Other aspects it cannot. A very good example for this is Swiggy, right? You can give a set of questions which is already present. Where is my order? Delivery guy is not moving. So when you put this, my order is getting delayed. It will give a set of answer which is already there. What is the current status? Still, if you are not convinced by the bot answer, you can go for a agent talk. You can talk to a human being where they'll interact, they'll call the delivery guy and ask what is the situation and update you. Something like that might happen. Before introducing your particular chat directly to the agent, they'll try to solve with the help of bot. That means we are trying to reduce the work which is put upon humans. We are using the technology in order to address the same. This is the best example for the feature which is currently in use in the apps which we use in our day-to-day life. How do we get start with this API? We have to just log on to OpenAI website, create your account, sign up, or if you already have an account, sign in, log in, generate a API key and keep it. Why you have to generate a API key? I'll let you. After $5 of content, you have to pay in order to improvise your API key. In order to improvise your API key usage, right? You want to know more about what is OpenAI, how does it help for GPT API, everything, you can just go to the official API documentation and understand more about this. Now, let's understand how do we generate a OpenAI API key. For that, you have to go to Google, type OpenAI login. Once you click on login, if you have already logged in, you will get two options. One is to go to ChatGPT, another one is for API. You click on API. Once you click on the API, this is how your OpenAPI platform look like. You could see a menu here towards your left stating API keys. If you click on that, it will launch API keys. Before that, I would like to tell you, I was talking about the GPT models, right? So these are the models available for now. GPT 3.5, Turbo 0125, 1106 and 16K. These are the models. You can select the model and you can work on. Let's come back to API keys. I'll click on the API keys. This is how the API keys generation look like. And if you want to create a new API key, click on create new secret key and you can name that particular one. I'm naming it as demo. You can also give the restrictions if you have to control certain things. It can be a read-only, restricted or all, just like the share option you have in your Google Drive for your Google content, right? So create a secret key and it will generate and display the secret key there. You can copy and paste it in one particular notepad so that you can use it again and again. It is taking certain time to generate the key. Once it is done, it will display and you will also have an option called copy for it. Here we are. It states API key is generated and you can copy the key. You can press as done. See, you have to save the secret key somewhere because it won't be viewed again due to security reasons. That's why you have to keep it discreet and noted in a notepad separately. You cannot get it back again. If you want to, again you have to create a new API. You cannot copy this complete API key again. The created API key is listed in the list here. Again, you have the options to edit the key. You can just change the name and permission, nothing else. You don't have access to again copy the complete key and you can also delete the existing key. This is how your API key page look like in OpenAI platform. Hope you are clear how to generate these and save it in a place and use it for your coding. Now let's talk about Flask ChatGPT App. We are integrating OpenAI source to our application. That is the main agenda of it. Let's understand more about this application. How do we work with this and also look at the demo for the same. What is the basic setup we need is as simple as that, which is mentioned before. You have to have Python installed in your system. and all the libraries mentioned to be installed in your system. That's the basic ideology for all the demonstration which is carried in this session hereafter. The components we need is Flask for web framework. As I mentioned, we use Flask of Python library for web framework. And then OpenAI GPT API for generating responses. A simple logic, we are taking a API key of OpenAPI, putting that in your Python code, and then we are trying to execute the same. First, we will check how this particular code look like and what are the in detail step in our Google Colab. Note, I am not executing this in Google Colab, I am executing this in command prompt. But for a better clarity, I am using the online coding platform, that is Google Colab, in order to have a good interactive and bifurcation between the text and the code, right? Google Colab is a very good place in order to work, in order to have a good Python content on. Let's check out the code and understand what all does it do in order to create ChatGPT app using Flask library in Python. Now, here we are on the Google Colab. First step we have to is set up the environment. As I told, we will activate the virtual environment of Python. What is this Python MVENV? Let's understand one by one. Python invokes the Python interpreter, which is already installed in your system. Then MVENV. This option always tells Python to run VENV module as a script. This module is used in order to create virtual environments on that. That is why we try to invoke this. Next, again you have VENV. This is the name of the directory where the virtual environment will be created, and it is not mandatory that you have to keep the second VENV as it is. You can change this to be ABCD also, or you can also put it as virtual environment. It is not mandatory that you have to use the same name, but with M you have to use VENV. This is mandatory, and the second VENV is optional. You can change the name accordingly. Naming convention can be changed according to the requirements. Next, after doing that setup, we create the Flask application. As I told you, we are using only 2 commands of Unix since we are working in command prompt. First is make directory, mkdir. That is, we are creating a folder with the help of command prompt. That's it. There is nothing great that's happening. Creating a new folder. The folder name is GPT Chat App, and you are trying to change the path, change directory CD to that particular location. And remember, wherever you have installed your Python software, that folder itself, these things to be created. We have to first navigate to that particular Python location. Then only we can create a new folder. Else there will be an execution problem and path issues. After doing the folder creation, we will have to create code file. First is a Python code file, which I would like to name it as app.py, application.py. Again, this is not mandatory. You have to have app. You can name it accordingly, but you have to remember what you have named. While you are executing this, you have to remember the exact Python file name, including the cases. It is case sensitive. Okay. First, we will import the Flask elements. First is Flask library. Next, request, JSONify, and render template. Then we will import the requests and also import time. These are the libraries we'll try to import, which is available in Python to our particular code. We will try to use request and render template, also the timing, in order to have the conversation between the system, that is ChatGPT, which we are trying to create, and our questions. Then we will initialize the Flask application. This is the Flask application initialization syntax. We will try to give a open API key. This is a secured key which you should not share with anybody else, or else they can utilize and you have to pay the bill for the same. better you keep the API keys very discreet. This is a random API key. It's a sample API key, or else you can just put in your code, enter your API key here. This is far better rather than giving people your original API. Once you put this API key, you will next define the root of the home page, where it has to interact from. Obviously, you cannot show this backend code to the user. You have to have a front end. You have a front end that is called index.html. There comes the second code file. First one is having app.py core Python file. Next, it has to be integrated to the front end, that is index.html. Right? We will render the particular HTML template. That is why we'll be using render template library. Okay? We have usage of these libraries everywhere. Then we'll define the root for chat endpoint, which accepts the post request. Post request is nothing but what message you put to the GPT and what it has to respond back. And this complete thing will happen with the help of JSON. Then you get the response from GPT-3. And remember, there's lots of GPT models. Which one you are using, you have to have the knowledge about it. You have GPT 3.5 Turbo 16K. You also have just GPT 3.5 Turbo. You have many kinds of model. The current model which we use, you have to mention it here. And you also have to carry the input given by the user from the front end to the back end with the help of this messages. The data should be transferred from the front end to back end. What is the maximum limit of the response? Is 150 letters, characters. It's not words. Okay, it is very minimal. If you want to make it more, obviously you can make it 300. Again, it is according to the requirement you are catering for. Then you have to attempt to get a response from API, which tries in case if it fails. Now comes the word of error handling. The code which is not having error handling capacity is not a worthy code. Simple as that. If something goes wrong, first you have to let the system give you the message that something is wrong, not directly land to a error page. It should be interactive and it should tell the user whatever you have entered is wrong or something has happened. What has happened? This particular responses should always be there. For example, I'm giving you possibilities. It's not that every coder will be knowing everything what they have to do, right? But still, there are few standard error handling techniques when you work. You have status code 200. When this particular 200 status code comes, 404 error comes, 429 comes, right? How do you handle that? What is the error? What is the particular response you give? For example, if it is for 200, we can return the message to the user. Rather than going to a random wrong page, you have to give a message. An error occurred while processing the response from OpenAPI. That means if your GPT is not connected properly, it is not able to give response, then you have to just not push that particular code to a error page. You have to send an error message. You have to tell this. Next, you have 429. Here, we are trying to request OpenAI if failed status. Again, we are trying to re-attempt. How many times? Back off, retrying attempts are 2. We will try to do 2 time attempts and then we will go for sleep. That means we are putting this particular system into sleep that it is not able to solve. The more you work with it, the more limit exceeding will happen. And 429 also deals with if your particular OpenAI is out of limits. It is not having any limits left. It is exceeded. You have to buy new. You have to put your billing again. It will say you have exceeded your current quota. Please check your plan and billing details. So that's how you have to try to give error message to the user so that they understand something is happening. We have to go and address, because nobody will go to backend and debug what is the error, right? In the front end itself, you have to show what is happening. So this is sample example of error handling. Then if any other error comes more than this, there are 2 errors which I have listed. If anything else comes up, you have to just give the status code directly. 404 error or internet disconnectivity error, anything might come. An error occurred while communicating with OpenAI is a standard default error message you can send. If you don't know what you have to do, just put there is an error, please decode. Then comes run the Flask application. This is the main method which we create for this code, and the code execution starts from the main method here. Now comes the second part of it, the front end, which we had discussed already there, and what are the complete content of that. We'll have a quick overview. That is index.html. Here you can see people who know HTML will always know this. Doctype HTML, you have head, you have HTML, lang, English, and meta character set is always there. You have style for your particular page, and you also have the body. Here you have a chat box, you have a text box, you want a button. It's a simple thing. You have to have a text box where the user will put their input, click on send button so that it will interact with the ChatGPT. In order to display the ChatGPT message, you have to have a label or again a text box. So that's how it will work. It's a simple JavaScript which is being used in order to have this interactivity, that is fetching the information from the input and putting that to GPT and taking the response from the GPT and putting back on the front end to view for user. So this is the simple fundamental function that happens in this script section. How do you run this? Just you have to be in the location where you have created the folder, that is GPT chat app, right? I'll just go back and just give you an overview. GPT chat app, that is the location where the command prompt should be pointing out. Then you can execute python app.py. When you do this, you will be able to access a browser where it is loading in this particular address. What is this address? Why only 5000? Why not 4000? You might question. As you all know, HTTP 127.0.0.1 will always deal with local hosting. When you do this local hosting, you have separate ports for every library or every kind of execution you do. 5000 is the port number which is allocated in every local system for Flask library of Python. Any Flask web framework code execution you do, it will launch on the Chrome with this particular address. Hope you had a complete detailed view of how this particular application will work. A quick recap, you have to install Python and necessary libraries. Then you have to create a main Python code file, that is app.py. Then client side, that is front end interface, you have to make it index.html. Again, this is as per your requirement. This is a common name which we keep. That's why I've used the same. You can create a simple HTML interface to interact with the ChatGPT. Then you can run the application and check for the output, right? So now that we have understood what is the code at the back end, front end and every aspect, let's execute this code and check for the output. Before going to the demonstration of Flask ChatGPT app, let's understand the folder structure. I am here in the location where my Python is being installed. Since we've already worked on, you could see many folders here. We are trying to create GPT chat app, right? According to our steps, we've already done it. So if you go to this particular folder, you can find two different elements. One is templates, another one is app. What is template? Template is actually the index file which we had discussed, the HTML file. App is a main program. Once you execute this, the back file will be created. If the execution is successful or not successful, doesn't matter. Once you run this through interpreter, it will generate automatically. That's why it is present. If you're executing for the first time, this will not be there. Okay. Now, let's hop on to the command prompt and check how does we work with this. Here we are in the command prompt and in the location where our file is. Am I right? No, I'm actually wrong. We are in the location where Python is. Now we have to enter to the folder created. What is the folder we created? We have to change directory to that particular folder. GPT underscore chat underscore app. This is the folder name which we generated, right? Let me enter to that. See, now we are in that folder. How do we execute the steps which I mentioned? We have to type Python and we have to mention the app.py or the name which you have given to your main Python file. You have to mention that and click on enter. Once you click enter, after executing this app.py file, this is how the output looks like. Are we in the right output screen? No, it is just indicating that it has been executing, it is running. The location is we have to go to http 127.0.0.1 5000, the port number. Let's quickly hop on to that location on our search engine. Any browser you can use, you can go to this particular port number. Let's hop on to that. Once you go, click on http, the same ID where it has been launched across, you will find the interface. Now, what you have to do? You have to communicate with the GPT. So, I'll press hi and click on send button. It will say, hello, how can I assist you today? The next question which I ask is, how are you? When you do this, you send this and just a computer program, so I don't have any feelings, but thanks for asking, how can I help you? So this is how it is trying to interact with the human being. If you try to give something which is not existing, still your chat GPT is not trained to that level. It is a normal basic model. I'll say, where do you live? I'll click on the send button. You have exceeded your current quota. Please check your plan and billing details. It will not throw up this errors. Really, if your limits are exceeded, right, that is when it will show this error. It will try to do that error handling which I have already mentioned. So, for the third conversation itself, how did we get this message? You might be having this particular doubt. The thing is, OpenAPI API key is not very much free to everything. You only have access for $5 worth of conversation that can happen, API key that can generate. That is how you can converse. After it exceeds $5, it will try to ask you to fill up and select the plan and do the billing, right? The payment should be done for the same. So, this is just a simple example. You can enhance, create, you can buy a paid version and start building the projects and help your small scale business if you own any in order to have a private chatbot so customers can interact without any actual agent service required. Customer service, you need not take it. You can use the bots there on your website, right? This is a simple idea. This is how the execution looks like. By now, we have understood how does ChatGPT while using Flask, how we can execute, what are the code required and how the outputs look like. Now that we have understood and also saw the demonstration, how does a ChatGPT app work when you create with the help of Flask library using Python?
All the topics we have covered on Python data structures and generative AI are more than just theory. They are essential tools for real-life scenarios from job interviews to practical projects once you are in the field. To get more insights about the applications of GenAI, don't forget to subscribe and stay updated with our latest tutorials. Now let's explore some of the most popular and challenging interview questions related to Python data structures and algorithms.
What is the most memory efficient way to add elements to a tuple? Well, what is the most memory efficient way? Now, you might be thinking about 2 or 3 different ways, but do not fall for the question because this is a trick question, ladies and gentlemen. tuples in Python are absolutely immutable. When I say immutable, you cannot add data to an existing tuple. If you want to add new data, what do? It's simple and straightforward. Create a new tuple for it. If you already have a tuple, and if someone asks you how do you add, how do you modify or something like that, understand that it's a trick question, right? Be very careful with questions like this. They get thrown right in the middle of the conversation and they'll try to catch you off guard. Now, if you were to answer these, then the interviewer is going to be confused, saying, hey, does this person know Python to a good amount of detail, right? Be very, very, very careful. And I have a lot of trick questions that we're going to be covering, but this is an important one. And talking to a lot of professionals, this is a question which again is super popular in the year 2021. It's moving around the interviews a lot, right? Fantastic. Now coming on to question number 21. Question number 21 states, what is a dictionary in Python? Okay, so what is a dictionary in Python? We've already used dictionaries, right? Dictionary is a fantastic data type in Python where we can have collections of items without having any sort of order. So it's an unordered collection of items. That is literally what a dictionary means. But when you're answering the question, make sure to give a little more details about it. For example, you're going to be using curly braces and there's going to be two elements for a dictionary, right? One is going to be the key value and the other one will be the value itself. Now, the value gets mapped on to each different key. So there's multiple keys for multiple values out there. One key, one value, another key, another value, right? That you have to answer. And of course, it is always efficient if you guys give one example as well, right? Now, if you don't have an access to a laptop while you're giving your interview or anything as such, take a piece of paper and just write down an example such as this, right? Now, here you can see the key values specifically, right? We have two keys and we have two values, key, value, key, value. It is as simple and as straightforward as this, guys. Don't just say it's a collection of unordered element. Make sure you're breaking it modularly down into these 3 or 4 important points and mention that as well. How can you insert an element at a given index in Python? Well, it's a very simple question. It's a straightforward question, yet it seems like it's such a complex one. But of course, when you're in the interview, when you ask a question such as this, it is very easy to get confused, right? That is the entire point of this. Now, how can we go on to add an element at any given index? Well, it's as simple as using another function. This time, the name of the function to do this job is called as the insert function, right? It can be used to insert any element that you want at any particular index location of your choice. Now, to just state this out might not give you complete clarity. So, of course, we're going to take a look at this practically as well. Look at this. Can you insert an element at the given index, right? Now, this is the list 0, 1, 2, 3 all the way up to 7. Now what I want to do is I'm going to use the insert function. Now if I just say insert 10, the question that's going to be asked is insert 10 where? Right now I have to give the index position at which I have to insert a value. Now all that this is stating is insert the value at the 6th index. The question is, okay, what is the value? Well, the value is 10, right? 6th index, put the value 10 there, and as soon as we go on to print it, you will see that it's pretty simple, right? Now look at this particular gap. Here we have 5, 6, and here we have 5, 10, 6. So 10 was inserted at the 6th index position, right? 0, 1, 2, 3, 4, 5, 6. Python came here and it was like, okay, I have to add it here, but there's already 6. So 6 moves to the right and it gets wedged in between 5 and 6. That's the reason we have 5, 10 and 6. Now what if I want to have it as 15, right? Now let me just change the comment as well so that you guys don't get confused. As soon as I run this, well, the value 15 gets added to the 6th index location. Pretty simple. How do we remove duplicate elements from a list? Do we have a function? Do we have a method? In fact, there's multiple different ways of how you can remove duplicate elements, right? The easiest way in my opinion is to take a list and convert it into a set by, of course, using the set function and eventually using the list function to convert it back to a list if it's required, right? Now, you might be wondering, hey, we're trying to remove duplicate elements. Why do we have to convert it to a set? How does a set work? A set literally states it is a collection of unique elements. There is no repeated elements in a set. So if you have any repeat elements that you need to get rid of, convert it to a set. Set will automatically throw out all the extra values for you and you can convert it back to a list and eventually you are done. How simple is this? Let me show it to you again. It's 2 or 3 lines of code, right? Okay, first of all, I'm going to be deleting the list here because we've been using lists of the concept multiple times, so you can ignore this line as of now. Your heart of the logic, the one line you should be concerned about, is this one. First of all, we have a list. The next thing is we're taking a list and converting it into a dictionary or a set or anything that works. And in this particular case, you can also use from keys. From keys also works fantastically well. As soon as I run this, now what are the duplicate element that we have here? X, Y, Z, Z and S. So Z is the repeated guy we need to get rid of. And as you can see, once we run dictionary.from keys, or eventually you can use multiple ways to do this, as I told you. Now I want you guys to head to the comment section and tell me another way. I told you one way to do it, and I showed you using another way as well. Right now, how do you convert it to a set and convert it back? Guys, head to the comment section and give me the logic for this. Right? Superb. Now let's get back to our deck. It's a very important one because here we're talking about a concept called as recursion, and recursion seems to be the most famous concept, the most asked concept in an interview, right? Be it data structures or Python. So what is recursion? Well, recursion is nothing but a function calling itself to have multiple functionalities over the same piece of code. If you have a function that calls itself, you can actually pass any different value that you want and get the function to have its behavior, but use different attributes to give you different results, right? But one thing you have to mention if the talk is about recursion is, please don't fail to mention that you really have to terminate a recursion statement by either giving a condition or manually terminating it. Now, if you do not terminate a recursion, it's like the function calling itself. It just keeps going back and forth. And how long is it going to go for? It's going to go on for infinite times. It's going to create an infinite loop if you're not very careful about this. So if you're asked about recursion, make sure you're specifically mentioning about its usage and its termination as well, because it's very easy to use recursions and it is very easy to miss the termination and send your entire program into an infinite. Explain Python list comprehension. What is list comprehension in Python, right? We know lists, but what is comprehension that we're talking about? Well, list comprehension basically talks about the operations of how we can convert one list into another. Basically, instead of convert, the better word to be used here is transform, right? Elements that are basically that you can conditionally transform are present in the new list, and each of these statements that you want to pick, right? There are 10 statements. You want 8 to be transferred into another list, or you want this to be transformed and create another list just from a substring, just from an element that is present here. Is it possible? Will be the first question, the answer to which is yes. The second question is how, and here is how. Right? Look at this. We have a list here, but instead of me manually specifying 1 to 1000 elements, 1, 2, 3, 4, all the way to 1000, I just ran a for loop there. And as soon as I hit print, it's basically going to actually print 1000 elements, 0 to 999, right? I'm scrolling left to right. Look at this. It did all of that, but this is comprehension. We're transforming a list. Right now, if I had to do this manually, again 1, 2 all the way to 1000 would be the way to go, but we are intelligent programmers and we made sure we understand comprehension as well. Right? What is the use of the bytes function in Python? Now, what would be the use of bytes function in Python, right? Well, it's very straightforward, ladies and gentlemen. The bytes function in Python just returns a simple byte object, right? If you have any object that needs to be converted into a byte object, or let's just say you want to create an empty byte object of the specified size that you want, you would just go on to use this function, right? It's extremely straightforward. It is simple. So when you ask this question, make sure your answer is straight as an arrow here, right? What is a map function in Python? Map function. Have we ever used a map function? Well, the map function basically is used for applying functions to an element which has a specific iterable in its case. Now, you might be a person here right now saying, hey, what are you talking about? I've never used the map function. I don't know what elements you put in. I don't know the syntax. I don't know what an iterable is, right? Well, let me tell you this. Map function is a very simple function that you try to apply function on not just one element, but all the elements. Now, there are certain parameters you have to pass to this. There are two parameters. One is the function itself, and of course the iterable that talks to the function, right? Let's quickly take a look at this practically so you have better understanding of what it is that I am saying right now, right? Look at this. First of all, you can ignore this line again. We're trying to delete the list there. We have a function here. Now, what the function is doing is basically try to, no matter what input you give, a numerical input is going to multiply it by 3 and give it back to us, right? Look at this. We have 1, 2, 3, 4, 5, 6 here. Result equal to map. Look at this map function, and I said function comma iterable. This is the function that I want applied on every single element of the iterable. Get it? Now the logic, what's going to happen is in the first place we're going to get 1 into 3, second place 2 into 3, third place 3 into 3, 4 into 3, 5 into 3, 6 into 3, and at the end we're just converting it back to a list and printing the result of it, which just states this, right? We gave 1, 2, 3, 4, 5, 6, but we got 3, 6, 9, 12, 15 and 18. What's the logic? The logic is here. We multiplied it with 3. But did we just do it for one element? No, we're trying to apply a function across all elements over an iterable. What is the iterable? It's tuple. Well, what are we doing here? We have 6 elements. Multiply each with 3 and you're good to go. Right? Given the sample dictionary, how would you update the value of apple from 10 to 100? Well, given the sample dictionary, how would you go on to update the value of apple? Right now, the apple value is 10. Apple 10, orange 20, banana 30, guava 40. Now what they want to do is take out this 10 and input 100. Right? It's a very simple thing. All you have to do is this. But no, you already have an input that you have to work with, right? It's pretty simple, guys. It's very straightforward at this moment of time. They will try to confuse you by maybe giving you a lot of these values or maybe changing the structure of how they have denoted this as well, right? It's only to make sure that you get tricked and you don't know the logic. You cannot figure out the logic, but fret not. All you have to do is fruit of apple. What's the column that you're trying to access the data of? It's 10. We don't want 10. What do we want? We want 100, right? Just one line of code will eventually go on to change that. Now, as soon as I run this, you can see that even though input is apple of 10, the output is apple of 100. This seems like a very easy question, but there are n number of chances where either you're a beginner who can mess up the logic and not understand, okay, how can we do this? Because again, if you just wanted it in real time, all you would do is change the input itself, but the input is fixed, the output is changing. So make sure you guys are paying attention there. Right? Fantastic. Coming on to the third tricky question. It states, how do you find the common elements that are present in two given sets? Okay, we're talking about sets. What is the most important thing that you have to understand about a set? Every single element is basically unique, right? Now, if I give 1, 2, 3, 4, 5, 6, and if I have another 6, S1 is a set which just has 6 unique values. Even though you see 7 right now, it doesn't care about any repeated values. You can have any number of repeated values, they're all ignored, right? So we have two sets, 1, 2, 3, 4, 5, 6. We have a second set, 5, 6, 7, 8, 9. Take special attention here. It says 5, 6. These are already repeated here, right? Now, as soon as you go on to intersect using the S1.intersection, what are we trying to find out? The common elements that are present here. The common elements that are present here are what? 5, 6 and 5, 6. Do not get confused of how a set works because that's what I just mentioned here. But the question is asking the common elements in two sets, not a single set, right? In that case, the intersection function works beautifully well and you will see the common elements. I'm sure we would have learned all of this back in our school or in our college, right? Intersection, union, all of these functions. All right, guys, super. If you have a dictionary like this, they have already given you the dictionary. This is K1 of 10, K2 is 20, K3 is 30. Okay, this is a dictionary. What do I do with the dictionary? The question is, how would you increment the values of all the keys? We're not trying to use the replace function to replace one value, nor can we use the replace function 100 times to do this manually. So how do we increment all of these, right? So it's a very simple thing. Just take the same dictionary, make sure you are running a loop, because a looping operation, since it's a common operation that's going for all the values that we're trying to increment. Now, what are we trying to increment? They're asking increment the values of the keys, right? Of the keys. We want to make sure our key value will go up once. So all I'm trying to do is I'm trying to take d1.keys in a function. For every I that is present there, just add one more. Now as soon as I go on to print d1.values, you'll see that it should say 11, 21 and 31 instead of 10, 20 and 30. What if I want to add a 10 to it instead of 1? It's a simple change of logic there. Just run it again and you can see 10 got added, right? Instead of 10 it's 20, instead of 20 it's 30, instead of 40, instead of 30 it is 40, right? Simple, guys. It's a very simple piece of code, but whenever you ask this in the interview at that moment of time, there's a good chance you might stumble upon something in this logic is not right. You're not able to figure out how to print it, or you're not figuring out how to work with the looping statement as well, right? Now I'm sure this will give you a good amount of clarity to go about doing that. What is the output of this operation on a list? List multiplied by 2. Now, this is a super tricky question. This is where a lot of people go wrong, that I have seen personally as well. Now, I have a list with 5 elements, 1, 2, 3, 4, 5. As soon as I multiply it with 2, what do you think is going to happen? 1 becomes 2, 2 becomes 4, 3 becomes 6, 4 becomes what? 8, 5 becomes 10. Correct? Answer is absolutely not, because the asterisk operation will copy the element into another. So instead of you guys getting 2, 4, 6, 8, 10, you're going to get 1, 2, 3, 4, 5, but twice this time, right? Now this is a very confusing output even to someone who has worked with Python previously. At the heat of the moment, if you're asked this question, you will just want to say that all the elements will get doubled. If it is into 3, there is a very good chance you can say, hey, we are just tripling it, right? Because this is a multiplication operation that we usually use. But do not be confused, guys. If you use this operation with respect to a list, all you're trying to do is replicate the elements once again. So if it is 1, 2, 3 instead of 1, 2, 3, 4, 5, what do you think is going to be the output? It's going to be 1, 2, 3, 1, 2, 3, right? Look at that. Fantastic, right? It's very simple, very confusing, a fantastic a chance for the interviewers to trick you. Write a program to find out the second largest number in a list. Absolutely fantastic. If you have ever given an SQL interview or a database interview, there's a very good chance this will be asked. There is a very easy way to find the maximum value. Just use the aggregation function max. It's going to give you the last value. But what they want here is not the max value, but the second largest value. Not the largest, the second largest, as in one previous from that. So if I have an input, let me just go on to type this out for you guys. If I have an input 1, 2, 3. Now what is the largest number here? 2. What is the second largest number here? What is the largest number? 3. What is the second largest number? 2. In fact, let me take a different example. 4, 5, 6, 7, 1000, right? What is the largest number? 1000. But what is the number that is less than 1000 but greater than 6? It has to be 7. Right? So this is how we try to find out the second largest one. Now quickly taking a look at the logic. First of all, we have a for loop. We're trying to find the range from 1 to the digit, including the last digit as well. Here we're trying to get an input from the user. All we're trying to do is attach whatever input we got to our list and sort it out. Once you attach the number that you get in a list and start sorting it out from the last element and just print the last but one element, this again is where all your logic is happening, right? So you're inputting the element, you're attaching whatever it is that you just inputted into the list as well. And not just that, you're also basically printing it out. While printing out the logic of the list is where the magic lies. Now, as soon as I run this, it'll say, how many elements do you want? Well, I just want to input 4 elements, let's just say. So I want to input 10, I want to input 20, I want to input 4000, I'm going to input like 6 lakhs or 60 lakhs or whatever that is, 60 lakhs, right? Now, 60 lakhs is the most maximum one. One before 60 lakhs is 4000. So I have 4000. Very simple logic. It's very easy to print the last one, but you're going to have to work on printing this last but one element, right? Guys, it's very straightforward. At the same time, it is very vital that all of you all know about this. Right, superb. Coming on to the 26th question, it says, what is the logic to quickly swap the first and the last element in a list? Okay, wonderful. We know how to work with the list. We know how to reverse the list. We know how to find out the index of the last element, which is -1. We know the index of the first position, which is again 0. Python index is from 0. But what they are asking for is saying, find the first one, find the last one, change it out. Right? So this is where the swap logic, the heart of the swap logic is. First of all, we try to create a temporary list and just put the original list there. So it's the simple logic, guys. A equal to B, B equal to C, C equal to A. Right? You're eventually swapping the first and the last values, but the name here is just, instead of the characters that I just said, it's the list. As soon as I go on to print it, you'll see that this is our input list, our sample list, right? The input is 11, 20, 30, 40, 50, but the output is 50 and 11. You can see that these first digit and the last digit got swapped, right? In fact, there's a meme, there's a sticker on WhatsApp with Ajay Devgan or someone doing this, right? So that's what I can think of as soon as I saw this. Okay, guys, again, all you have to do is input a sample list, write the logic to copy it. A equal to B, B equal to C, C equal to A, and you are good to go. But here what we want to find out is to find out the maximum size, and 1 minus that. Well, instead of size, why are we doing size minus 1 is the question you're supposed to be asking right now. The answer to that is Python indexes everything from 0 instead of 1. So if you have a programming language which indexes from 1 rather than 0, you'll just say temp equal to sample list of 0, 0 equal to size equal to temp. We're saying size minus 1 because we're starting from 0 with respect to the index, right? It's all simple, straightforward questions as soon as you look at the answer. But as soon as the answer is hidden and just the question is shown to you, you can stumble upon it and take some time to think as well, right? So make sure that you guys are figuring this out easily as well. Fantastic. Now that we know how to swap the first and the last element, let's take a look at the 27th program, which states write a program to count the number of vowels present in an input string. First of all, what is the input string? The input string, since we're talking about vowels and consonant, it has to be characters, right? Now, Anirudh Rao is my name. This is the input string. But to make Python understand what the vowels are, we have to specify it, right? Capital A to capital E, A, E, I, O, U should be in the lowercase, should also be in the uppercase, right? Because if you just put it in caps, Python is of course treating lower cases very much differently to upper cases, because you saw the ASCII values are fundamentally different. So when I say that check for these, I am giving both the lower case and the upper case as well, right? And eventually we're just sending these both functions. In fact, this has to be input underscore string, right? We're just sending the string value, we're sending the vowel list into this to go on to compare and see if it works or not. Now, as soon as I hit enter, all the output that I should get is, first of all, it should tell me the length of number of vowels. So it's giving me the number of vowels that are present in Anirudh Rao, right? So it's A, 1, 2, 3, 4, 5. Correct? 5 different vowels. Now, what are the vowels that it caught? A from the capital I, capital A, I, U, A, O. A, O is from Rao and A, I, U is from Anirudh, right? And again, the heart of the logic is this one particular line, just to traverse with each and every single element, and you just being very careful about giving both lowercase and uppercase. It's just passing these values to a function, having it in a structured modular way to print it out, right, guys? It's fairly simple, at the same time fairly easy to get confused as well. So make sure you're paying a lot of attention there. Superb. Coming on to the 28th question. The 28th question states, how do you break a list into n chunks using Python? Now, n can be any number that I want. If I want to break this list into 10 chunks, I can do it. If I want to break it into 5 chunks, I can do it. Now, when I say chunks, let's see the output first and then work on the logic. You can see that this is the input, right? 1 to 13. Now, I want to break it into how many pieces? N is basically that, how many pieces that I want to break it into. I want to break it into 4 pieces. You can see this, 1 piece, second, third, fourth. Even though it does not have enough elements to complete the last one, it still breaks it, right? Now let's make Python a little happy. Let's just put in 13, 14, 15 and 16 as well, right? Now, if I'm breaking this into 4 lists, it's going to be equal elements in every single entity. Look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is 1, 13, 14, 15, 16 is 1 as well, right? Again, the logic is basically this, guys. All we're trying to do is find the input list. Now, what is this particular logic, right? We already learned this. Take a second to remember what this is. Once we create a simple nameless function for our logic, all we're trying to do is use the for loop and just traverse from 0 to the length of the input list and eventually break it down into what? Into n pieces for us, right? Pretty simple, guys. It's just a simple list operation that will tell you what is supposed to be done. What's the input? How many pieces do you want to break it? How do you break it? Print the broken output. That is it, right? 4 lines, four different things that these lines do.
In this video, we have covered the essentials of data structures and algorithms using Python, laying a solid foundation for both beginners and those looking to enhance their coding skills. From fundamental data structures like arrays and trees to critical algorithms like sorting and searching, we have broken down complex concepts into easy to understand lessons. We have covered the how and dove into the why, ensuring you grasp the underlying logic that powers these techniques. We also explored the world of generative AI, showing how Python is at the forefront of this revolutionary technology. Plus, we have provided practical insights and tips to help you ace your coding interviews, giving you the confidence to tackle real-world challenges. If you enjoyed watching this video, make sure to subscribe for more Python tips and tricks. Thanks for watching. See you in the next video.